Wow, once again, we're almost at 5,000 subscribers. Thank you so much. This is the start of a new animatronic design, and I wanted to show you a little bit about SketchUp. The reason why I really enjoy it so much is quick and easy. Make a cube, make a square, easy, and I love it when I can find center, like you see here, and measurements. I like measurements, like where I can just click on my measurement device, click on a line, and it will give me the proper measurement. And I've printed a lot with SketchUp, and it's accurate. Okay, this is part one of a 3D printed new animatronic design. I'm going to have multiple servos in this head, and it's going to be small enough to where we can print it and also make a resin print and be able to make a mold of the resin print to make the skin. And this is going to have a lot of realistic movements. So this is the beginning. Well, to start, this is the servo. This is the wing servo. This should save me some space. This is the C410. This is from King Max Servo. It's a wing servo. I have these servos coming, so I can start designing and get started on this and share it with y'all, the whole process of designing a 3D printed animatronic. We're gonna shoot for 8 servos. I think I'll have enough space to make this happen, especially with the size of these servos being so thin, and I'll be able to, and screw points matter too, and that these are, vertical screw points instead of horizontal. But this is a bead. This is what they call a gumball bead, and they have a 2 millimeter hole going straight through. And I'm contacting all of the suppliers that all the parts I need for this animatronic to make sure I have them in stock. So make sure my Patreons will be able to have them available. But as far as the servo rotation is 70 degrees. But here I'm just making these circles and or center points onto the servo arm. That way I can draw onto the servo arm itself, and mainly just to get a center point of the axis, and that way I can get a measurement from one point to another. But I'll just make sure that this is at the correct height. And then as you see here, my eyelids, the rotation won't go back this far. It'll open wide, especially when you have skin on it. You'll see it'll be open pretty wide-eyed. But in the lower and the upper eyelids will be connected to one servo. And then when I start designing the linkage, I'll just take the measurement as you see here. I think it was 2742, and I'll just make a line 2742 and make circles, and then I'll put the screw points, and then I'll just line them up like so, and then I'll extrude it to make my linkage. But it's a design thing, and sometimes it can get tedious, but it's things like screws will be like 2 millimeter screws and nuts, and it has to be able to make sure that those are clear from any obstacles. Make sure that it's probably going to be some nylon 2 millimeter nuts also. That way it'll be like a locking. And then every once in a while I will use them small tiny washers, and you can get a whole pack of these multi-link 2 millimeter screws. But I'll just duplicate the top one, and I'll stretch the other one according to the measurements to the lower linkage length. And you'll see these lines coming out of these holes. Those are my axis holes where I can just, combine them together or, match up to another hole that has that line coming out just to match up the axis. I recorded today about 3.5 hours of footage, and I'm just going to be, and I've edited it down to like 30 minutes because I've had to speed up some of these. Because, some of the times you see me in there, you can tell when I'm thinking, but it's just part of it because I got to just make sure that everything's clear, or can I put this here or put that there? Because, you have other things like wires, and you got other, I want to put other things that move, and I just got to make sure that I have clearance for the next thing. But this is basically part of the designing. Now, these things would probably be best to be printed in some type of, carbon fiber, or, the whole thing would be great in carbon fiber. That way it'd be strong and wouldn't be breaking, or, PLA is pretty strong, and, all the stuff that I've done already has been PLA. But as you see here, what I'm designing is an arch. Now I really need to flip this over where the bow is upside down. Just didn't get it around to it, but that way it would be stronger the other way. But and the same for the lower. They should be both flipped, but I'll flip them later. But it's just a lot of planning and to make sure I have clearance. And once again, this is going to be like modular, so I'm doing one eye here and then I'll mirror it. You'll see this in a few minutes. Now I'm making the center axis supports for the eyelids. This is what's holding the eyelids and the ball in place. There will be a through rod through this whole axis point to where it holds the bead and the eyelids. Now a lot of this is like in a rough design. I mean, it's accurate, but as far as to where I can come back and there is what I call a cleanup time, to where I start cleaning up all the things before I print. And like when I have all the sockets in place for the servos and stuff like that, I try to avoid a lot of supports, and then I'll slice whole panels just so I can print flat to avoid supports, and because I don't want anything to break being in a PLA test. Now here's the lid support, and it has a center axis, but it's having eyes looking straight, but technically most creatures don't have straightforward, center axis eyes. I like to make mine tilt a little bit. I will either have a 2 millimeter rod going through this support, or a 256, RC rod they call them. Uh, but it will have lock nuts on the end for each set of eyelids. I mean, this one right here is pretty clean coming out, and everything's flat. I even rotated earlier today. I kind of rotated that servo, at a 90-degree angle, and I thought about that, and it's possible that I might change that also. But it's just, you got to work things out, because the way it looks like, I might have a table on top of this servo, and this servo table will hold uh, like the other mechanisms that are going to be working, like for the uh, eyebrows, and there's another, like a cheekbone. The cheekbone doesn't move, but the muscle does, and that would make it, you know, squint. And that's another thing I'm trying to calculate. But you see here, I'm doing a rotation of the eyes to give them to where they're not just straight on. And then I'll do another tilt. And the first one was a 8 degree, and this is a 10 degree. Just give them kind of a cat looking look, I guess you call it. But it kind of gives the creature a little bit more personality, I feel. Now what I'll do is I'll open the component up to each one of these eyes and connect the eyelid supports together to make one component. Here I'll just draw lines to each corner and just connect it, make it into a plate. I appreciate all the questions, and I'm trying to answer all of them. There's a lot of them, and I appreciate that. But as far as uh, like a servo controller, I can control these two servos with a controller. Just plug up the servos to the controller, add power and a USB, and I can program it. But like right here, what I'm doing is that, once again, I have a library of parts, and this is the alien that I did that y'all been seeing the move. Its jaw and where the teeth goes to, and I'm going to put a servo onto this jaw, so I'll have another servo open and close the jaw with the servo there, and the servo that's on the jaw will be pulling the lower lip up and down. And it has to be done that way. I'm just trying to bypass cable or either guitar string. That way I can have a direct line to it. I can't put it anywhere else because the jaw servo will lock up the other servo. So this servo has to be in the jaw to get this to work. As time goes on, there's some, RC supplies get discontinued. And plus, I'm trying to avoid putting cable housing, which one of my good small cable housing has been discontinued. So I'm going to just go directly with this servo here and to move this lower lip. Here, making a screw point socket for this servo. Just I'll just copy the tab and then just extrude it, the screw points, and then connect the two tabs together to make a socket for these wing servos. I'm right clicking to get rid of the component of the servo, but you're not seeing the other window that's popping up. I'll make sure I'll make that correction on the next video. When you design an animatronic, you put a lot of time in it, and you can get to where you spend hours, and days, and weeks, and months. But I've done so many, I can do it pretty quick. But it's still, you have to keep double checking. But it's a great feeling when you make something and you see it move. Now this servo is small and it's flat, and I'm trying to get it into this jaw, but I'm going to make sure that it fits well, so I'm going to widen this jaw. Then you'll see I'm trying to line up this servo arm to center, but it can be a little to the side, but I'm going to go ahead and remove half of this jaw, and then I'm going to enlarge it or just, stretch it out a little bit and make it a little wider, so that way I won't have any issues in a way to hide this servo, even though it's going to be behind the jaw and the skin's going to be covering it. That way it just be out of the way and won't be bumping into anything that's behind it. And later on, next video probably. I'll make a low poly set of teeth, and I'll make a high quality, highly detailed set of teeth. I'll copy the plate of the lower jaw and the plate of the upper arch, and then I'll put them into Blender, and I'll design it. I have a library of teeth I've made, and that way I can cut it to make an accurate bite to where they fit these plates, and they just fall in place and get just a perfect bite. We're working on the upper arch and the height. The whole mouth can be higher or lower, but I try to keep it more compact. And before I make the adjustments for the upper lip movement, I'll make a kind of a rough set of where the teeth are going to be. Just a form and a shape of teeth, or where the teeth are going to go. And since we got a servo in the jaw, it's going to make the mouth somewhat bigger, so we have to cover this servo. But just a fake little form for me to rotate around with the lip mechanism. Now this is going to be where I'm going to put the location to the lip movement axis. And there's going to be two paddles, or two lip movements here on the upper teeth and one on the bottom. So each of these movements, that would be equal to be 3 servos that's going to be working this. But the axis to this lip movement needs to be in a certain location for the rotation and moving of the lip in a correct position. Now this whole thing will be remodeled, and the hinge point at the back, if if you see here, if I rotate it too far high, it will pull away from the teeth, and that'll make it look strange. But if you go lower, it hugs the teeth closer, so it's more natural how the lip, you know, moves around the teeth. There's not too many wing servos that are this small, and King Max is the only place that I really found them, and I'm sure that they exist, but this is the smallest one I could find that was that small. Just, the smaller the animatronic, the smaller the printer will need to make this, this bust to be molded to make the skin. Now, as far as me remodeling here, the lower lip movement, I'm just getting something a little bit closer to hugging the teeth, and then I'll find its axis, and see it's pulling too far from the gum or teeth area. So I'll just locate this axis and go from there. Here I'm going to chop up this jaw to where I can mirror it, make it wider so I can lay this servo in there closer to the jawbone itself. I will add a chin to it later, and then that way that lower lip mechanism can kind of tuck underneath the teeth and kind of hide that mechanism. When it opens up, it it won't have a bulge, but yet the bulge could be another movement underneath the chin area. And during, like cleanup, when I start really getting down on each mechanism, like with the paddles, I can put like little sockets into the paddles because I want the paddles to grip the silicone also. And then when I make the core, that way it will be transferred to the core. And then when the skin is casted, the sockets will appear for the lip paddles and the brow paddles and so on and so forth. Well, when I start doing the skin work, I'm going to be using from Smooth On the EcoFlex 10. This silicone has a 4-hour cure time, but a lot of this remodeling the whole jaw and things like that, and also when I start making the skull, I can put a covering over this hinge point too to kind of give it more of a jawbone appearance. And then you can also, we'll be able to see that through the, when I do the sculpt, we'll see it move through the skin. And that's my goal. The whole thing is I want this to have some realistic movements, and it should, especially with this Smooth On EcoFlex 10. And when you apply it, and I use this Silpoxy adhesive, and when you apply it, you put it in certain spots on the skull that you're sticking. You know you're going to stick the eyelids, and you're going to apply it to the paddles that we're moving. But you also apply it to certain parts of the skull. You just don't paint the entire front of the face and stick it, because you're not going to get that really that flesh look, that muscle movement look if you just glue it all. It's just not going to work that way. Now I just worked on one side and mirrored it. Now I have a wider jaw. Now I'm going to rotate this servo to where I can get it matched up with the bone, the jawbone itself. But I need to flip this servo. That way the servo arm is on the bottom instead of the top. But it's just this kind of tinkering design to, I'm building a watch. Okay, I pulled back on the jaw, the teeth, and the lip mechanism, and I want to add the teeth to the from the other alien I did. I'm just gonna resize it to this arch here, and that way I can get a basic shape for the lip mechanism and just the whole creature itself. But I will redesign these teeth that actually fit these arches here. Yeah, the teeth make the creature, and the eyes too. But I'll remodel these teeth and to match them up to these arches and give it its own kind of expression. But I'm gonna, here where I made the eye plates, I'm gonna adjust those too. But to where I'm gonna bring the eyes in a little closer together. I moved them in 3 millimeters. I don't think you've seen it yet, but it's coming up. But compared to the other animatronic, it's a working mech. But that's the other servos, the standard the standard servos. But these wing servos here should give me a lot more space, and plus be able to reduce the size. Made the eyes a little closer, 6 millimeters closer. And that's looking good. Have a lot more work to do, but and have, I believe, 5 more servos to add, equal 8. But we're going to play around with this. But this has been part 1 of a 3D printed animatronic creature, and part 2 coming soon. I appreciate all the support, all the new subscribers, and I'm glad y'all like it and have the interest that I have. Thanks again. Hello? We have reached over 5,000 subscribers. Thank you very much. I see that we have a big interest in animatronics. Now we're going to get into part 2 of this animatronic build, and I'm using SketchUp 2017. On this video you'll see me basically just lay everything out. I'll work on all of it and redo a lot, and you'll see here how I go about doing it. And once again, this is SketchUp 2017, and I'm doing the different recordings so you can see how I'm clicking the pull down bars and activating and deactivating like components. And like components are like when you make an object, you can highlight the entire object and select it, and it will lock it into a component, and that'll be a box. And then you can have another object and you can do the same thing, and you can put those two components together without joining together. So you can unlock one and work on it, but if you unlock both of them, they'll connect, and that can be kind of a pain sometimes. Here you'll see that I'm working on the lip mechanism for the upper lip, and it has an axis, and all these movements that I have a rotational axis. And it's, you have the eyelids, you have the jaw, you have the lips, you have the lower lip, you have the brows, and they all have this. What I'm making is an axis, and it's basically where the hinge mechanism will rotate. But that's what I've been working on throughout the whole process of designing. Each movement will have a servo. Now, even though that some of the so-called objects that I'm designing, like the double fork of the lip, even though it's double, it's just still one movement, but it'll give the illusion to when you have the center hinge mechanism moving, it'll make the lips do a more realistic shape of moving it. These axes that I'm designing are like maybe a little bit longer than probably 50 millimeters, maybe shorter, 40, but they all have a threaded rod going straight through. It's just like the eyes and the eyelids. They have a long rod. I mean, they're probably maybe 22, maybe 30 millimeters at the most, but then they'll have a nut, a lock nut on the end of it. Well, I want to be able to, when I'm designing this, so I can get to that nut, so I have room, to screw in place. And if it's like, for instance, if it's behind the arm of the jaw, I can't put a screw, or I cannot put a long rod through there unless it's modular, already designed to where I can attach it first and then place it there when the jaw is already attached. And there's just different things about this. Is what I have to design to overcome any kind of obstacles. And the thing about designing animatronics that you know, I've been doing this for a little while, really got into it, just when you do an old school way, you're sitting there and you're carving these blocks, or you're bending wire, or you're sculpting something, and you're casting it to be a certain length, or it's hands-on work. But with digital design or CAD, you can kind of like design it in 3D space. And this is what I'm doing. I'm designing these parts, and I can I can get it to work to where I can move it and check, well, is it going to bump that servo behind that jaw? So I have to, design it where the servo is on the jaw, and I can rotate the servo and the jaw to see if it's going to bump into anything. And if it does, I have to make changes. Or, it's just things like that you have to work through. It's something that's never been designed before, so you have to make adjustments. And here I'm just working on the lip mechanism and the center lip. Even though that these are kind of bulky right now, I'll reduce the size later, and you'll probably see that. And then, like you see here, it's bumping into the eyelid. And once again, you'll see me remove a whole piece and pretty much like redesign this whole eye mech or eyelid mech mechanism completely. And it's just a part of it. Like we saw it bump into the upper lip, so I need to make adjustments. But I'm wanting to make sure you'll see it also that I'm gonna have the eyes on a flat plane, and then when I'm working on the jaw, I can build off of that flat plane. And there's times where, I'll struggle with a part, even though I have to manipulate it, and, that's just part of it, you know, uh, or it's not doing what I want it to do, or it's not, level. Like I'll grab a part earlier. Well, yesterday I did a part, and I noticed that my servo had a slight tilt to it. But then I looked at it, and it did have a tilt, but it made all of them have that tilt because they were copied. So it copied all of it. So I had to physically go inside the component and level them all out. And you know, sometimes and a lot of times I'll make mistakes like that. Like I'll accidentally move something, and I'll say, "What happened?" And then I'll find out later that I have to click, the undo button a few times to go back and correct what I messed up. But it does happen. And once again, I appreciate all the thumbs up and the kind words in the comments. You know, I really enjoy this. I've been doing this art for a long time, and it's a passion you really get out of, in the world of 3D printing and just art itself, is when you make something and you have it printed, and especially when you get it to move. It's just a wonderful feeling, and it's like, I made this, and I want y'all to be able to experience that too. But once again, thank you for all this, the shares and and just overall all the subscribers, and I know everybody has the same interest that I do. But and as soon as I get the Patreon set up, I'll have SDL files available for this, and I'm probably going to be having some other smaller ones available also. And then that way you can print it, and I'll have a listing of what servos to get, and then that way y'all can actually do hands-on and see this thing move, and then I'm telling you, when you see something like this move in front of you, it will, you'll start to think, and it's just a great feeling. But I've been contacting a lot of suppliers that for all the parts that I use in these animatronics, and there's certain types of servos and there's wires and it's just overall supplies for these certain things that I design. And I just want to make sure that these parts are available, and or or do I have to like redesign something so I can find an existing part available? But that's what I've been working on. It's just getting everything set up with Patreon. I got an account, but I have to do other things, and it's been growing. And I've been working on this animatronic, and I have other animatronics I'm working on at the same time too. But I appreciate y'all's patience. Another question someone asked me about that, could I just solder the wire on the servo to make it reverse? And you can do that. And you can do it and, save a little money and not just buy, a reverser. But the reversers are so cheap, and that way you don't have to break down a servo and risk messing that servo up, especially if the servo is expensive. And there's other options. You can buy a programmable servo, which is really high dollar. I mean, some of those are almost, if not over $100, where you can go in there on your computer and change it, reverse the, the rotation of the servo. But now, with reversers, you can get 10 of those for like, maybe $1 a piece, like $10, $12, and you can have, a handful of, reversers. They used to sell them on Y cables already made. That way you just buy the Y cable reverser and just do it. But now they have them separate, the Y cables, and then they have reverser cables. Somebody's comment was, do I tilt the eye to kind of get rid of this uncanny valley? And I do. I prefer to tilt my eyes. And you'll see later at the end of the video the reason why I tilt. The smaller ones I just can't tilt because they're just so close together. But I'll explain that later on. But yeah, I like the the tilted eye look because it doesn't look like straight. I guess the uncanny valley look. Yeah, and another question I had was why don't I use Fusion 360? Well, Fusion Fusion 360 is good. I mean, don't get me wrong. I just I've tried it and I have played around with it, but it's just a different format that I'm used to. And y'all can agree with me. You get used to a certain software, you get kind of spoilt to it, and then you throw in another software. But you know, I played around with Blender for years, and then it was let's say Sculptress I played around with for years and loved it so much I wanted ZBrush and got ZBrush, but ZBrush is huge, and it's a learning curve also, and it's different than Sculptress is, and it's different than Blender Sculpt. But like like in CAD or like in this SketchUp 2017, I am limited on certain things that I can do. I couldn't do a sculpt of some creature in ZBrush, and it's no way for SketchUp to carry it. But yet you could put the sculpt in Fusion 360, and that's a plus. And it's just you know, uh, you get used to a certain format, and when something is thrown into it different, it's just hard to get, used to it. But there are a lot of good softwares out there that you can use to make animatronics. I've always wanted to work with SolidWorks, but it was so expensive. And it's just like ZBrush. ZBrush is expensive. I mean, and I technically I'm a starving artist, so it's hard to get some of them high dollar softwares. And and even though this SketchUp 2017 is free, and some of the new versions of SketchUp is expensive, and there's just some things I just can't afford. With this whole YouTube channel, this animatronic channel that I put together, I'm trying to keep costs low because I want you guys to be able to experience what I experience, and I put a lot of research on what servos to get and which ones not to get, and some to stay away from, but and I try to keep costs down so y'all can afford this because this can become, quite expensive because some of the servos they have out there are, I mean, like I said before, they can be $100 a piece. And just picture if you had, you know, 20 of them in an animatronic, you're looking at a pretty high price tag there. And I'm working on this lip mechanism, and this is, the axis point, and it needs to be correct so I can get the full motion of the silicone lips in the future. And even though that this is still on the bulky side, I can reduce the whole jaw mechanism, lips and all, and the teeth, and reduce the size of it so we could even just make the whole thing smaller. And these are the low poly teeth. And once again, I'm going to put new teeth on this design here, and I'll show y'all the process of how I do that to make an accurate bite. And when I mean bite, it means it will close according to the teeth. I mean, had a lot of I had a lot of time in the dental lab making dentures, 30 years of making it, and I've made a lot of dentures, so I can make sure that them teeth are going to look real as possible. But as you see here, I kept working on the jaw. I just really wasn't satisfied on how the jaw was, you know, moving, and I had, and the other thing is that I'm trying to still keep it. I'm trying to still keep it like 130 millimeters from nose to the back, and I want to keep it that small, so when I have the skull on and have this whole thing complete, then I can put the skin on, and then adding the skin thickness to it, maybe around 150, maybe a little less. I'm still trying to keep it down so we can get this in at least a normal size large resin printer. I mean, I really wish we could uh, print something on a FDM printer that would do the detail, but there's not too many FDM printers that will make I mean, it'll get pretty close. But the other option is print it on an FDM printer and then put a thin layer of clay on top of it and actually sculpt on top of that. And then you know, that would give you more likely to mold easier because, silicone and resin prints don't get along. You have to do they have that issue of not liking resin prints where it kind of hurts the silicone where it doesn't. But there's ways of fixing that. But it's a process. But resin prints look good, and but I hear that they're working on fixing that issue. There's other developments of certain resins are going to be available to bypass that not liking resin prints with silicone, and but there's other silicones you can use. But you got to also realize that when you mold things, there's shrinkage, but this silicone very rarely shrinks. I mean, it's micron. shrinkage. But that's if you do a proper mix. But there's all kind of things we want it to work in our benefit. It's just that we have to work to make it work. I made this eyelid mech a little thicker so I could put a plane in here and make a cut. And what I do is I make a component of a plane, and then you'll see here, and I'll join it, and then that way I can come back in here and I can just remove everything underneath that plane and make this flat. And I I really like using this method, and I also use the same kind of method when I'm making before I print the final skull that holds most of all the axes and working components. I can just slice it right down the middle and print the top and print the bottom, but I'll print the bottom by inverting it, and that way I can print them on a flat plane. That way I can avoid those supports. But I really enjoy designing. You can kind of get lost into it, but you'll see me play around and what's next to do, and I'm thinking. But like right here, I'll just copy, mirror, flip on the red axis, and I have the shape. And then I'll take my measurement and see how the space. It's 77 millimeters, and then also I have to you have the brows and you have the eyes and you have the jaw and you have the teeth, and you got to make everything center. So I'll take this, for instance, on this design here, I'm actually making or finding the center point to this whole, I guess, modular section. I mean, you'll see me here. I mean, I'm always taking measurements because I just want everything to be square, center, and because if it's not, it can throw things off, and then you'll wonder why. But and if you keep the designs, like keep the eye mechs one, keep the mouth mech one, and keep the brows one, and then you can join them all together. That way you'll keep things pretty much center. And this is in a design way, mirror it and just keep checking measurements. You'll see here's me working on this jaw here again, and I just keep mirroring it. And what that is, it benefits me, is that I sit there and I work on just one side, and then but even though that this is going to be different on the other side anyway, because I'm going to be putting a servo on, I believe it's the left side's going to have a servo mounted to it. So I got to design a mount for that left side of the jaw. Now these axis points have like I believe it's like a 3 millimeter or a 440 measurement screw hole that like a threaded rod will go through this, and then I have it's just a design thing to make sure that I can get everything able to work easy and small enough to do it. Now here I'm mounting that servo, and I have a servo socket already designed, and what I'll do is I'll just line this up to where that hinge mechanism or the axis of the lower lip is lined up, so then later I'm going to design on that mechanism for the lip a linkage point, and then I'll have a linkage point to the arm of the servo, and it'll just be lined up perfect. But there's some days that you might notice that I didn't post a video. I'm trying to post a couple of videos, maybe 3 videos a week, but I'm going to try to keep up with that. Sometimes I might not be able to. I do have other animatronics that I'm working on, but I'm going to keep y'all informed. But like if you see here on this is the small mech here. that has two servos in it, and this was the one that I I put skin on. But this is the early design where when the mouth opened, it pulled these rubber band springs or tension springs, and it made the lips move up. But this has two servos, and it has a rod going straight through to the other side, and that makes those eyes just straight. Okay, but I had to design it that way because how small it is, so I could make one servo blink all four lids. And this one here is the same way. This is uh, the dark gray one is the one that is the newborn baby design, and it's the same way. And even though the eyes are close together, I designed it that way because it's hard for me to put a screw on the inside or a nut on the inside of that because it's just so lack of space. But when I tilt the eyes, I'll be able to put, nuts there on, they're far enough apart that I can put a nut there and lock it in place, having a tilt mechanism like there for it. But this is what I've been working on, and this is what I got. You can see the size compared to all three of them together. But I appreciate y'all. Thanks a lot. Thanks for the support. Thanks for all the sharing and thumbs up. Later. Well, we're almost at 6,000 subscribers, and it's really growing. And I just wanted to, this is a little bit shorter. I've been working on uh, the baby animatronics core head, and I've been, switching back and forth. But I just wanted to show you what I've been working on the animatronic creature, and this has 8 servos in it, and this is where I'm at. I'm working on the jaw. This is the whole modular design. I would call it a mouth mech kind of modular design. Now this mouth mech, I guess, would have 3 servos: the upper lip, the bottom lip, and the jaw. The center upper lip, it will be on the top plate, and that's where the eyelids are. Entire mouth. And I did that today to kind of tuck it in a little bit. It wasn't looking right to me, so I shrunk it down a little bit, and I moved that servo that was on the jaw. I moved it a little bit more to the left when I'm looking at it from behind, but I moved it to the left so I could, uh, get more space for that area, because I extended where I could put the linkage to the lower lip. I could scoot it over. That way I could scoot the servo over. And that way I could just make the whole mouth neck smaller. But it's coming along. It's just, this is the tedious part of designing. I've just been like designing a little bit, looking for the areas where the screw holes are going to go. Because more likely I'm going to cut these plates or keep it like the mouth neck separate. See, I can invert it and print it flat on the, build platform of the printer. That way I don't have to deal with them supports. But as you see here, I'm working on the brow mech, and I pulled these 2 servos right here out of their component, and I labeled them green. That way they'll stay. 2 servos will stay in a component, and not have all 8 being on, all of them being on a component. But like this brow, I'm making sure everything's kind of center, and then I'm trying to develop a holder for these 2 lever mechanisms for the brow. And then this holder is going to be like a table, and it's going to have to go and connect to the floor below it. And this table is going to have 3 servos on it, and it's got to make sure that everything is clear. I've piddled around with certain kind of designs, but in all, everything has to fit kind of tight so I can put a skull on top of it. And then the skull is going to have more likely neodymium magnets, and it'll just pop on top. But like I got to make sure everything's going to be clear. But plus, like the so-called table legs are going to have some type of connection point screws, and then I'm just trying to foresee on what kind of design that needs to be. I was even thinking today that I could probably add more servos inside this head, being that the wing servos are so thin. And I did talk to my servo guy. He's shipping them out tomorrow, and I'm happy to hear that. And we can get this thing going. But I appreciate all the subscribers and all the wonderful comments and the thumbs up and the shares. And I'll be in a YouTube studio, and I'll be looking at all these so many comments, but I'm just surprised that how fast this channel is growing and how many people actually have an interest in animatronics. I knew that there was an interest in it, but man, I'm really happy. Yeah, it's can be kind of nerve-wracking sometimes when, like earlier I was saying, I'm gonna put a leg here for this table, and I'm gonna put the other one here, but then you can't get it in a place you really want it because something's gonna be there or it's gonna be too far out. But that's just part of it, it's you work at it until you figure it out and you solve the problem. But when I have the STL files available to some of these animatronics, and then I'll tell you the things that you'll need to get, and as far as supplies, and I've been once again been contacting all the suppliers for these little parts, and basically got a little list of what to get, and there's some things different from one servo to another, and different type of animatronics. But if you build one of mine, that one of the SDL file kits that I'm going to have available, if you build one just to see it move, you will have that, I guess, the fever, because you'll understand on it is when you see it, you'll say, well, wow, that's pretty simple. But it's it is simple, but it's designing it to where nothing interferes with each other. These little rib things, I do a lot of testing to see how I could get something, if this would work, test it, if this can be attached somehow, some way. Can I connect this table to these legs or these arches so I can have kind of a form how I want the skull to go? And then when I get the skull made, I can copy the entire thing with everything partially open, and then I could put it into ZBrush or I could put it into Blender. Either way has a sculpting program, but that's the goal. But there's probably about 15 parts I've been working uh, on this so far. But this plate's almost done. I got to add 2 servos. These sockets right here, I have to add those or connect them to this plate. And then that way it would be, that'd be complete. But then I have to add screw holes to it also. But I worked on this jaw. Y'all seen that earlier, to where I was just mainly working on it to see where I could put screws at. But and to see, like right here, how open can I open it until it bumps into something. But it's pretty neat. I'm kind of happy with this little design. So I got clearance there on that servo, and like I was telling you earlier, that I had moved that servo a little bit to the left. That way I wouldn't have any more of that clearance. But then I still got to add a linkage point to where the linkage will connect to the jaw, and then finish the linkage that is on the lip too for the servo that's stuck to the jaw. And then another linkage that goes to the upper, uh, I guess the double lip. A linkage would need to go there, but that's um, four pieces. But I also shortened the eyelid supports on the outside. I brought them inside some so they wouldn't be so far apart. I'm just kind of condensing down everything. As you see here, I shortened both sides down, and being mirrored helped. But it's starting to look more appealing to me. But then these little table leg things, I'm just playing around with them. I extended them, see if I could add some kind of support. But they would be pieces on their own because I'd have to connect that to that. But just to show you the size with these 8-wing servos, this is $1 and a 156, 156 millimeters is the size of $1. So this is the size on what I have so far. But this is great. I'm happy with this size. You know, once again, I could probably change more things and probably will change things. But it's coming along. Got the brow table started. Uh, Worked on the mouth. But once again, I'd like to say thank you to everybody, and thank you for sharing. I was surprised on how many of y'all have been sharing my work, and it's getting out, and I appreciate that. And the likes, and we're going to be making our creatures move really soon. So thanks a lot. Later. Hello, everyone. We're over 6,000 subscribers on this channel. Everybody has a fascination with animatronics, and we're going to build one. Well, here I'm making a platform to pretty much hold everything in place, mainly for it to be flat, not any angles, because eventually I'm going to be designing the skull for this, or a cover for the whole mechanism. But I just kind of make an oval shape and, you know, stretch it out and just place it here. But I just need to make sure that I have it, you know, long enough, but I can't go too long because I'm still trying to realize that this needs to go into, when it has skin on it, needs to go onto a printer. And when I say it has skin on it, that's the sculpture part of it. I'm going to physically make the skin by making molds of the print of the sculpture. And then that sculpture will have a mold, and then I will insert a core inside of that mold that would produce a layer of skin, and the skin will be a silicone. You'll see later that I'm using multiple programs to make this thing, and I do that because some things I can do easier on another software than I can on this one, because you know I couldn't put once again I can't put a sculpture in this because it can't handle that kind of a, you know, large file format. I got to make sure that I have room in the back. On the bottom there, you see the two servos on the in the back. That's where the gimbal is going to go. But I was sitting here making all these ribs and just trying to get some kind of support for the brow table. That way, you know, just to have some kind of legs to hold up everything. Sometimes you'll see on these videos, and I do edit because to sit there and watch me spin this thing around is because I'm studying and trying to figure things out and taking measurements and things. But it's just that some of them things might just seem kind of boring. It's boring to me because I'm the one that's doing it. And when I record, 15 minutes of me just spinning this thing around, you know, that's just part of it. And I try to avoid having that on YouTube so it don't bore y'all to death. And this is just all part of the design, and you don't want to print something that's going to fail, or design a jaw and the jaw don't open and things like that. But here I'm just making an arch here and trying to get some kind of a look that I need to how the skull is, and like eventually I'm gonna have like a flat. It's gonna be all flat and not necessarily round. It's round for me to get a basic structure of the like a skull, but most of these might be more square like later because there's gonna be a covering these ribs, these supports, and those will have a magnet and it will attach, the skull will attach to those magnets. You know, servo cost is also determined on the movements. Now I could add more servos, ears, or whatever, or cheekbones. I'm just trying to get it at a point, a cost. You know, uh, if you have 8 servos, something costs $10 each. That's $80. But then, if some of these servos can get on up there, $15, $20, and it's getting kind of costly. Now here, I realize that I need to do a sculpting test. That way, I can determine if the brows are too low. And that's what I did to determine, and I did raise the brows up. I made one big STL file, just copied the whole thing out of SketchUp and put it into ZBrush. And if you see here, I start sculpting, and it was mainly because of the eyelids, and underneath the eyelids where the brow is. And I wanted to make sure that I had clearance to where the eyelid will curl into itself, where, that way it won't be messing around interfering with the brow. Yeah, I just doodling around playing with this, trying to get a basic structure of the alien, just, making sure I keep the right thickness, but yet, it's just a concept doodle right now, and I can use this later to when I have the skull completely done, and then that way I can put this in, and but actually I'm going to be sculpting on the core for the final process. That way everything can be, 100% the thickness that I need to achieve this. And I'm still learning ZBrush, and I've had it for a couple of years. But I used Sculptress for 5, 6 years, just dedicated to it and you get Sculptress and ZBrush is, they are different, but it's just a learning curve. But this is what I got as far as a design, and you'll see. And I'll post these pictures on the comment section so y'all can see them a little clearer than the video. Now I moved my, I use a software called OSB, I believe it is, that records my, my screen capture. And it got shifted, and it's not, you know, centered right, but I'll work on that. But what I did was here in Blender, I started designing a skull shape. And once again, I'm using multiple softwares because I can manipulate certain things in one. Like I can't manipulate the vertices in, in SketchUp like I can in Blender, and this helps me with the roundness shape. And then some people say, well, why don't you put it in Fusion 360? See, this part doesn't need to be all smooth because it's going to be underneath the skin. I mean, don't get me wrong, I can make it smooth, but it's easier to edit in low poly than it is in high poly. But, like, I'll take this whole mech, and like I said earlier, that I will make it into an STL file, and I'm able to put, export this into other softwares. And what that does, though, it gives me a proper measurement. And that's what I like about, well, STL files. Now, I couldn't put an OBJ because it's going to be tiny and I would just be guessing. I mean, I could still use an OBJ, but I'd have to reduce the sizes and things like that when I bring it back into SketchUp. But here I'm just, I have it in the sculpting a blender, and I'm just sculpting it and matching up to where I made that little platform, and even, and it is low poly, and you'll see me here add loop cuts or just loops, and it adds more vertices to it so I can manipulate it, and then I can bring this in uh, back into the sculpting, and any points I was not satisfied with, I can just manipulate and smooth out. But then I can take this later. You'll see me where I put it back into SketchUp, and I'll save just this piece as an STL file. Yeah, I just trying to get this thing kind of a basic shape of a skull. Nothing too, you know, too elaborate right now because it's later, and I still need to finish the main, mechanics of this animatronic. But you'll see here, uh, I'll pull it back into SketchUp, and then you can kind of see the skull shape that I'm going for. But I can manipulate this to where I need to have a skull, but I need to just finish the entire thing before the skull is going to be one of the last parts. But I needed to make this. It's like one of those foreseeing what I'm going to have and getting measurements and how high this structure needs to be, and don't want it to interfere with the eyelids. But so in SketchUp, I took the creature and opened the jaw up, opened the lips, and adjusted the eyelids. And then I made another STL file so the creature's mouth would be open. And then exported it to ZBrush, and then I started sculpting the skull or sculpting the creature with its mouth open to get that visual look. And there's some things when you sculpt on and in printing sculpting, sometimes you have to exaggerate for it to print right. And plus, on top of that, you need to make certain folds like eyelids for those eyelids to bend into itself, and like creases and things like that to give a more lifelike kind of a character. But it's just a little concept doodle. But as you see here, how it looks with in and out there. But like here it is with the mouth open, and how I'm saving it as STL file. But I'm closing. Now I'm going, undoing everything to get it back in its right position. But you'll see all these other ribs I've added just to have a look in this shape and size. But But here's what I got so far, and I'm still working on it to get that table for the eyebrows stationary, and it's coming along. But here's the full video of the sculpt I did, and I'll post some pictures also in comments in YouTube. Hey, I appreciate all the nice comments. Thank you for all the thumbs up and sharing, especially sharing. It's getting out there, and I appreciate that, y'all. So thanks a lot. Uh, I'm just I'm glad we all have an interest in the same thing. So y'all have a great day. Later. Hello. I just wanted to say thank you for all the new subscribers to the channel and the old ones too, and all the questions and the nice comments and the thumbs up and the sharing and but it's been a crazy ride. YouTube has said that since in 28 days I've had over 5,000 new subscribers to this channel, and that's an achievement, and I appreciate every one of y'all. But when you click on those likes and stuff like that, it generates more watch time, I believe. I'm almost at 4,000 watch hours, and then I can get benefits through YouTube. Now, I will set up a Patreon, and that's where I'm going to have SDL files available. And and then I'll have listings of like maybe servos and hardware and what to get and things like that to make this animatronic work. I'm going to have other files available, but it's just setting everything up. But YouTube has also some kind of um, sub subscription deal or to where you join my thing or it's something that I'm learning and I might have two of them. I just don't know at this time. I'm just trying to set everything up. It's just everything's just been going so fast, but we're going to take care of that. Plus, I've been designing, as you see here. I shot, I did screen capture of 5 hours of footage, and I got it, edited down so y'all don't have to see all the studying part of the whole animatronic. But you'll understand that when you start designing your own. And eventually that's what I want y'all to be able to do because it's just a special feeling when you design your own. And that way it's just a good feeling. But but what I'm doing here, this is uh the designing of the so-called brow mech. There is three servos that are going to be mounted to this so-called, I'm calling it a scaffold now because it kind of looks like it after you see it finished. And it really turned out well. And I go by the pre-existing shapes that I had put these ribs on the last video that we've seen. And I'm going by that as far as height and length. And I'm kind of doing a kind of a block version of not so rounded because you'll see later uh, I will put magnets for the skull to attach and it needs to be a flat base and that and then I have also screw points and you'll see me and I've been making screw points today but it's coming along. I have it all mixed together here just to so I can see what you know I need to do with these blocks, and I'm just trying to attach everything to this iMech or the Blake mech part. So what I'm going to do is manipulate this part of the iMech that I don't need, and this is where the servo lays. So, and this is they call this let me see. Yeah, they call this intersect faces, and but that's what I've been doing using here. I'll put a block there and I'll highlight that one face and I'll right click and say interface with face, and it will just know what's surrounding that face or what it's into, and then it'll copy the so-called new lines or vertices to that shape, and that way I can go in there and edit. Now, some of the complex shapes, you have to seriously do some editing, but you know, it works 95% of the time really well. And a lot of these videos I have sped up, and this is like times six because, once again, I probably put in so far on this one project, and I can get a pretty good calculation, but I probably have probably close to 30 hours, if not more, into this animatronic here. And it's the design thing. I mean, everything that mechanical especially has to be designed. And it's just that it can be kind of tedious when you're doing it uh, with any kind of software because you're looking at it a three-dimensional object on a 2D monitor. So it kind of gets kind of strange to do that. And plus, something so, if it's the size of your monitor screen, you're thinking this thing's big, but yet it can be size of your hand, and it can kind of throw you off. But I'm just working on this iMech part or the Blink Mech, and just trying to get a base for me to connect that so-called scaffold, uh, the brow mech scaffold, to this area here because I'm going to put screws in there. And I determined that this is where I want it to be, you know, fixed to with some screws. And I'm going to use two screws right here, but it's mirrored, so they'll have two other screws there, but plus there'll be two on the back end ribs, and you'll see that later on. But this is just me how I'm forming this little area to make the mesh to have screw points. Now you'll see me jump around and I'm working on a platform, and this platform here is going to be holding the so-called the blink mechanism, and it's the servo sockets, and that's going to be its area, and then this so-called scaffold is going to attach to it, and then then you have the eyelids, then you have the beads, and then so on and so forth. It's just you're making everything kind of modular. Now, you'll see it later on in the design, the so-called the brow mech, uh, you know, scaffold. You'll see that I'm probably going to print it in one piece. I have joined legs to of the object and then try to break down so many into multiple smaller pieces, mainly so I don't have no support. But this thing is just so, it's a good size, and you'll see later. It's just that, I'm not a big fan of supports, but sometimes you have to do it. But I'm trying to, maybe less parts to print, but this would just be one major part because it holds the brow mechanism, it holds three servos, and plus it's going to be supporting the skull lid itself. And that's what I've been prepping for by designing this whole thing to do all of that whole process of kind of, I have, like here, they're mirrored, and they're not, and whatever I do on one, it's going to be copied to the other one. So before I release the so-called component and make them non-mirrored, I can join it as one, but anything that I do on one, I'm going to have to do on the other. So it's best to do all you can on one side as it's mirrored. Someone had a comment that I could do reduce the poly of my ZBrush design, from, reduce the polygons to where it won't be such a big, large file and would be able to put it inside SketchUp. And I've done this a number of times, and especially when I was working on the Hulk character, I'll do that to get kind of a size ratio of the skull that I want to build for it. But what happens is that ZBrush is primarily on units. They're not on like a metric. They do have a measurement thing at the end, but it's nothing like you have some kind of like a ruler or anything like that. But ZBrush has Decimation Master, where you can reduce the polygons. Like if I have something that's 200 megs, which that would be a pretty good size file, I can, turn it into something like, just a couple of megs to put it inside uh, SketchUp. And like if I did the sculpture and I put it on here, and I've done it before, it's just that my measurements are somewhat off. Even though it says it, I'm not getting that same measurement. It's a little off. I like ZBrush, don't get me wrong. It's just that there's some things like it can't handle a large, like my large Hulk creature I'm doing. It's a 17 inches from the chin to the top of the head, and things that size, uh, it really doesn't like things that big. You have to reduce it and then relarge it, I guess, to that original size you want. But I think you're limited. But yeah, once again, I don't know everything about ZBrush. I mean, I'm no whiz at ZBrush at all, and it can do a lot that I've not even touched the surface of ZBrush. I'm just in there to sculpt monsters, basically just skin for my creatures, and I'm just getting by. And I try to use multiple tools, but it's only a few handfuls I really like to use. But as far as um, designing on this brow mech here, I'm kind of closing things up a little bit so I can remodel the shape. And there's a certain shape that I see that in my head that I'd like to have. And plus, it needs to have clearance through everything. And also, I need to be able to get like my my fingers in areas that might be kind of small, or I got to make sure that if I need to screw a nut in place, I need to be able to get to it. But like for instance, this whole rig, the scaffold that I'm building here now, I'm going to have to put the servos on first and then lay this onto the skull itself or onto the main base. And then I mean I can still manipulate it to a point, but that's just other things that you have to calculate. Even I've had, some other smaller animatronics where I had to put or screwdriver holes into certain skull areas, so if I needed to adjust a screw or whatever, I could do that. But see, when we're doing an animatronic with skin, soon as you attach the skin, everything needs to be done with. But once again, anything mechanical is subject to failure. That's all mechanical objects. There's always that possibility of having something fail. But
we're just trying to avoid that, and we don't want that. Nobody does. But that's when you put in the hours and days and weeks and months into something, that's what you're trying to avoid, to have to fix something. So, and like I'm trying to make this thing somewhat durable too. You know, there's other there's other ways to print this, and and also I'd like to see some of my things milled out of aluminum. But once again, I don't think like this size of the scaffold. I mean, some of these things are 6, 7 millimeters thickness, but with metal, I could reduce that half, if not more, and then add also uh, threaded screw holes there to just bypass any kind of a nut mechanism, where you wouldn't have to have you know, a lock nut situation, and that would save even more space. And 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 that's another thing about animatronics. It's all about space, and you got to have clearance for your linkages, and your linkages have to have clearance also, so they don't bump into something. And then you have your wires coming from your servo, and they have these leads that you need to slide them through them holes, and they might have to travel through multiple floors so you can get to either a servo controller or some type of receiver. And but it's all in part of the design. But here, like, I'm working on the table, and this is a new table, but it's going to connect everything from the top up. The new brow scalpel, and then the eyelid neck, and all this has to be where I want screw points to connect all that stuff together. Now, the the eye blink neck will be connected to that plate already, and then that will be one one part. And then I'm wanting to get the another. I'm making this plate thick enough so I can cut it flat right down the middle of this thick plate, and then I can print that one plate, and then I can print the so-called uh, mouth neck plate, and then that way I can just screw everything together, one time. I mean, it's going to have a lot of screws because you have to calculate the servos, the linkages, and then the whole prints that you have to screw in place. And then there's going to be nuts and washers and things like that. But, sometimes you try to eliminate a lot of that, but it makes it fluid, and it makes it strong and durable. And also on that main support plate, I'm going to have a gimbal, and that's going to be on the very back end of the skull itself. And then, but the main plate will also have a so-called border, and that border is going to be from what I build upon the skull. And the skull border has a thickness, and that's the thickness of the shell skull part. And then you'll see here later on the scaffold where I'm adding these boxes, and I'll probably point it out to you in this video, to where I'll have these neodymium magnets set, and then they're going to have opposing magnets that are going to be part of the skull. So that the whole skull will just click into place and fit correctly. But I just design these things because everything is going to be covered with silicone, and there's going to be some places that are going to need to be glued, the silicone to the so-called skull, and there's some stationary points to the skin where that part of the skin doesn't need to move. But on the other hand, that I'm going to have some type of skull plates in certain areas just so I can stick glue or the silicone to the skull. And it's just designing a whole cover system for the entire mech. But like under the eyelids, there's going to be a skull part there too, because I want something to be glued underneath those eyelids, so it will make. I don't want the whole. I guess the whole bag of the eyelid to move. I just want the eyelids to move. Yeah, I like designing all these things. I mean, it's pretty relaxing, but once again, that there was 5 hours I recorded, and that's what I'm editing right now. And I edited down. Uh, it was it was 5 hours, and there's mess ups that I do that I edit out, and I'm talking about mess ups like the hourglass that comes when your computer kind of freezes up when you're doing too much work or something. I have that, you know, all the time when I'm designing, and then it'll freeze up for a minute and I have to edit that out. But then there's other things where, well, there's no sense of me showing you that because because there's things that I add to this design that I changed my mind. I says, well, I'm not going to go that route. So, and then I'll just edit that part out. I mean, I even did a smile mech to where the creature would smile or frown. It'd give more of a cheek movement. And I could probably do it, but it's just, once again, every movement has another servo. And I'm trying to keep costs down. And it's cost down for y'all guys because it's like, you know, you got to also understand that uh, animatronics can get very, very expensive. And I'm trying to keep this, low cost. I'm trying to do a really good multiple movement expression animatronic lifelike for little or nothing. So, I mean, and y'all see, on that little creature test that I did, that so-called proof of concept, you know, uh, you know, I've been wanting to do that for a while, but I was so busy doing Grogu's. I mean, but I got to the point to where I just did a little test just to prove and I've had this so-called theory for mainly a good 10 years. I mean, I knew the technology of 3D printing because you could see on my other YouTube channel that when I made the old school way of animatronics, I mean, I was making these little blocks out of polyurethane. I would pour it and then I would cut these blocks and make these so-called shapes. But now I'm doing the same thing with 3D printing. And that's eliminated that so-called process. So now I can do it this way. But, it's like the old school way. You could do a sculpture, make a mold. Then after you made the mold, you'd have to put a layer of clay inside the mold. And then when you did that and the mold is closed, you would have to pour another to make the core. And when you demold, remove that clay, you have a core. But then you had to mold the core to make the skull. And then to make the skull, you had to either make another mold or do what they call a slush mold or a rotational mold where you build up a layer of solids with polyurethane and you would have a shell. Well, as soon as you do your sculpture and you molded that, and then you molded your core, then you molded your core to make the skull, you're thinking, well, how many servos can I use? Well, you really didn't know. I mean, you kind of you knew what you had to do, but you would hope you would have enough room. But by doing it this way, it's kind of reverse engineering to where you do your mechanics first, and then you make your skull, and then you do your sculpture, and then, I mean, there you go. You done reverse engineering. But you can take it further by you can get your basic movements that you need. If you start designing a lot of animatronics, you'll develop a so-called library of parts. And then you can take these parts and use them on this, if you're going to have a so-called alien or a creature that has like a more human look than more of a like a werewolf look or a dinosaur look with a long muzzle of some sort. You can change it. I mean, the eyelids are eyelids, so you can just enlarge them to any size you want to. But but like this plate right here, I'm trying to build up an area at the back because it's too short. And and then eventually you'll see me pull this back. I don't want it to interfere with that border with the skull. And that skull border has a has a measurement of like I think it's 3 millimeters and or 3.5, and that gives the thickness of the skull. But I mean, you'll see later on how I develop the skull. It's going to be the whole process of this, but you'll see me put this skull on here, and this was from the last video. But you see how much space I have here available. I'll remodel this again to fit that border, which is already close again by me just stretching it here, but I want it a little bit more precise. But you'll see here I'm joining the scaffold together. And this little square right here, that's where the magnet's going to go. And you're going to have a mirrored magnet on the other side also. And then on top of those, you're going to have the opposing magnets, and those opposing magnet sockets are going to be attached to the skull. And if you do all that, plan it, and go by the borders, the whole skull will fit like a glove. But no, it's a wonderful feeling doing these things, and there's a lot of softwares and servo controller softwares. There's some that make things look robotic and some cheesy, and I like when I can have multiple movements going on at the same time. That's called like a mixing. I like that, and VSA is one of them. But once again, you're stuck on one software, and that's what I prefer. And but uh, I want y'all to be able to make that. You can say I made that. I want y'all to be able to design your own animatronic. And it's not that. I mean, don't get me wrong. You have to put a lot of time in it. I mean, you have to, but you can start off small. You can do an iMech. You can do a blink mech first, and then a lot of times you take you an eyelid or take you some beads. You can take a bead, get the measurement, and then make you some eyelids. And then you get a servo to move those eyelids. Then you're going, wow, that's cool. Well, now you can take that eyelid and mirror it and have two eyelids. And then you're going, that's even cool. Well, now you can enlarge it and get you a larger bead and make you a bigger one. Or better yet, you can reduce the size and make you something smaller. But then it goes on and on. You can have the same servos in the same if you plan it right with the right servos, if you plan it right, if you enlarge the screw points of a micro servo, enlarge it to a standard servo, you can make your animatronic that much bigger. Instead of something that's, I guess, bigger than a softball, you can enlarge it to a basketball size. I mean, by but don't get me wrong, you still have to make some minor adjustments because most standard servos have four screw holes than just two. But that's nothing to it. Just copy, move up, copy, move down. You have four screw holes. And another thing about designing is measurement. You're going to have measurements, but and you check again, and then you double check. But that's just something I've always kind of I've been doing it, and a lot of times for these big animatronics, uh, it's nothing for me to take this like this big Hulk creature here. It's nothing for me to take this thing apart 15 times, and it's not to fix something. It's to maybe adjust or maybe let me move this way to get this effect, or this is I got to make sure that my it's fitting correctly, or it could be a lot of things, or just to modularize everything. Your eye mech, your mouth mech, your brow mech, your ear mech, your gimbal. You have all these things that you when you make all these so-called modular designs, you can put them all together and you'll have a whole animatronic head. And when I start printing this animatronic, I'll film the whole process of me building it and probably give an estimated time from start to finish. And it will probably take a few hours to put together. I mean, if you just screwing in place 8 servos and then sliding all the parts into their places and screwing them parts down and stuff, and you can pretty much build it. And soon as that is done with, is you can connect it to a gimbal. Then after that part, you'll be able to set up a program with your radio. I always test everything that I do with a RC radio, and I have posted that in the comment page on the YouTube channel. And you can find you any radio that you really like or you prefer. I mean, it doesn't have to be expensive, and some of them go up to 1,000 or even more dollars. You can have a little basic $50, or I've seen them as low as $30. I would prefer you'd have more than 4 channels, but you're primarily going to be using 4 channels anyway. You'll have some finger dials that you can use, but mainly most people, as far as most people that are doing the so-called puppeteering, are primarily just using the joysticks, and that's just 4 servos or 4 channels. And but that's going to be a must to get when you're doing this, because you need to check your movement or your center point of your servo. And right here on the video, you'll see me centering that to the plate. And that's another key point that we have to make sure that we do. When you do this, the plate, you find the center of the plate, and then I find the center of the scaffold. And you see me here adding the so-called border that I was talking about for the skull. And this is the border that we're going to be using, but I don't need the center part, so I'm just going to add these vertices here to make it where I just make a continuous loop all the way around, and I'll just mirror that one side and put it in place. And then on this, I raise the upper lip up because I'm gonna need some kind of a shell cover for this mouth area, and not knowing if I want the lips to go up inside of this, but yet I kind of want it to like wrinkle the creature's nose, but yet it still needs to have something there for the nose to lay upon. Because I call this, you don't want it so baggy. If you don't have anything there, it will be baggy or have a raincoat effect where it looks kind of rubbery mask type look. So it needs to lay upon a skull. But now here, what I'm doing is I'm finding the center axis or the center point to where these eyelids and this eyeball is. And I'm going to be making a circle, and I'm going to make that circle in half so I can give it some rotation to make a so-called uh, the eyelid the the eyelid eyeball mechanism, the hole in the skull part. This is what's going to connect the skull, like the bridge of the eyelids, I guess you would call it. That way it will, this is where the hole going into the skull will be from. This is what it will become. But it's, and this is something that you'll notice that when you rotate the servo linkage that is on back of the, or linkage point that is on back of the eyelid sticks out somewhat because when the servo linkages are pushing the eyelids, it, that so-called linkage socket is visible. Well, I don't want it to bump into the skull, so I have to close the eyelid so I can design around it. That way I don't have any kind of interference. And don't get me wrong, I've had that problem before, but now I've learned from that mistake or that issue, and I always try to correct it to make sure I don't want to have to go through that. Because once again, you don't want to print something for 12, 20 hours and have to reprint it or even redesign it. So it's best to just try your best to eliminate all that. And even if it takes you a couple of days of redesigning or design it right the first time, but it's just part of it. But like, this is the thing about SketchUp that's kind of hard to do is when it all depends on what view you're in, but also when you're rotating at an angle and not rotating on an axis, you got to kind of have I guess you have to have a so-called flat base or it will not rotate correctly. And that's what I'm kind of having to add here. And that's just, where I can change my axis according to the flatness of that plane there. But, it's just part of it once again. But, also, I've worked on the main floor plate. I worked on the eyelid socket area for screw points to do the scaffold that is the brow mech. And then also I have the border for the skull. Now I have the so-called socket areas for the eyes for the skull. And I'm getting close to doing the skull. And then I got to do the underskull also. That way I can kind of, more likely I will have that form placed on there to print when I print the bottom plate. I want the bottom plate to have that already on there and just making sure that I can do that when I print it. But then it might also be where the mouth mech area might have the cut part of that bottom skull plate too. But but then I got to redesign the teeth and then after I redesign the teeth, then that way I can finish out the so-called lips. But lip pieces and hinges, the little small parts like that, you know, I can make adjustments. I can finish them and do the best I can, but they don't take long to print at all. But as you see here, I'm checking all my measurements. Now I'm going to have to readjust, and I just figured this out earlier when I was editing that I'm going to have to readjust the so-called scaffold the bases there where the screw points are, I'm going to have to redesign to where that's going to print flat. I'd rather print it like it's laying there, like it is there on a flat plane, like so, but those legs need to be even. Like I'm going to have to reduce the height of the back ones up to match that height. And I know y'all are wanting to join Patreon, and I'm wanting to know if there's going to be people going to be wanting to join the so-called uh, membership on YouTube. I mean, this is something new to me. I've known about it, but I've always known about Patreon, and I know what Patreon does and how its file format is, where they share files and things like that, or or videos. But uh, but plus, I look at having some kind of income so I can invest in research, like in servos, and because I study servos really, and it's really a process that I go through, that I like a servo to be a certain type. I don't, I try to do uh, a good review on servos, and that way I, and other things also, like certain hardwares or softwares, or just so-called components, servo controllers. But I, I love a good servo, and if it's good, I'll use it. But there's one thing of having a servo that works hard, great, it's quiet, has good torque, and it's a great servo. But if it costs $200 a servo, I really don't have a need for it at this time in my life. Because if I need 20 of them, I can't afford that. And but there's servos out there that are that expensive. I can't afford that. I mean, I'm in the $20 range, if that. If even $20 is kind of high. But I'm into you know, the $100 servos. I mean, it might be a name brand, but I'm trying to achieve this quality. I mean, those servos in that little small creature test. Those ser- though there were. Let's see, what was it? Two, three, four, five servos. Those servos were less than $20. I mean, and I got that achievement of that movement with that silicone. Now, silicone's expensive too, but that's just what you have to do. I mean, but I'm, and that's why I'm doing the size that we're doing here. To make it the size that we can make this affordable, because we're going to have to mold this, and it's going to be like, it's smaller than a dollar bill, but it's still like a size bigger than a baseball. But it's going to be it, you're all going to love it when it's done. But I rattle on about animatronics because it's just an obsession I have. I've been doing it for a long time, and you know researching it, and I've researched it for a long time, and it's part of the passion. But once again, this is probably one of the longest videos, I believe. I'm not quite sure. I have to double check. But this whole video here is 44 minutes long. But it was from a 5 hour. I mean, I was up last night for 5 hours recording this whole process that y'all see here on this video. Uh, from It's just a breakdown of everything that I've done throughout the 5 hour period of doing it. But it's it's great, and I'm loving it, and everything's coming together. But once again, I thank all of y'all again. Just thank you for subscribing to my channel. Thank you for the comments, the likes, and the shares, and uh, appreciate all of that. And I'm trying to get the 4,000 mark. I know it might have ads on my video, but it's the way I can produce some kind of income to support this channel. I need to have some kind of support. The Patreon is coming. We'll have all the files and all that other merchandise stuff like servos and stuff. When I get all that, will be there more than likely. The membership stuff I'm still thinking about, but that's going to be like a primary, another source of income through YouTube, where I'm going to be, helping to research and do reviews and testing and things like that. But I appreciate every one of y'all and thank y'all for y'all support. I hope I'm giving y'all good content, so let me know later. Hello, this is the 3D printed animatronic creature part 6. This is the gimbal. But first I'm going to show you how I'm demonstrating how I'm doing some block out. It's kind of testing where I want the skull pieces to go. How I'm going to enclose this whole animatronic. This is kind of like a sculpted sketch. Just seeing and knowing to where I can actually put these pieces at, and also just knowing, the foreseeing what I'm going to need to do to make this thing possible as far as making sure that everything is clear, all the mechanisms work. But I'm in Blender and I take a sphere and then I divide it uh, 3 times to kind of make a shape like this. Then I use the Blender modifier and go into mirror. So that way I can mirror this other shape on the other side, and works rather well because you can edit in low poly really easy. And then as you see here, I just stretch it out, and then I start adding the sculpting program they have on there, and I can just kind of manipulate it to this area of this so-called ring circle around the eyelids there, and what those are really there for. So my eyelids, when they're closed, don't bump that skull piece on the inside of it, and that way I can kind of model what I can on the inside of it, and then I can turn around and add something like this to the front of it, and that will be like a skull piece. So after I make the modifications to these pieces, I'll delete the main skull piece, but then later on, I'll just hit undo and it'll bring it back after I send this off as an STL file, and then I'll import it back into SketchUp, and then it'll match up correctly by matching the two software's center points, and I have it like so. And then I'm going to be able to manipulate this or come back and just redo it or make it thinner or, more flatter underneath it to give it more room for the sculpture or whatever. But then what I do here is I take this circle to the skull. And what I'm going to do is I'm going to do a cutout. But before I do a cutout, I'm just going to go ahead and cut this skull in half. So that way I can just mirror it. Well, after the mirror, well, right here, what I do is I'll just extrude that piece, and then I'll move, where I feel comfortable, so it don't go too far. And then I'll just like move it over some, and then I'll go ahead and do the extrusion all the way through, and then I'll hit intersect with model, and then or intersect with faces, and then I'll just remove this entire sphere, and what little pieces are circled onto the skull, it'll be a round cutout area for where the eye is going to, or eyelid's going to be. Later I will add the inside uh, shell cover or the shell version of this whole skull, and I can do it by copying this, reducing the size, and then making certain cuts to make it a solid piece, plus binding it to that so-called border area to the bottom plate. But here what I did is I did another STL file export into Blender. So now I'm going to add some more sphere shape brows. So this part will connect to the skull. So I just add a sphere into Blender, and then I'll just make my cuts and divide it into the basic shape that I need, and then also do the same modifier and do a mirror. This way I can just kind of, and it's just a simple low poly standard sphere. I mean, this is like I'm still testing. I'm just making sure that I have clearance around my eyelids, and that's the eyelids that are connected with the linkage, and that way they don't bump or come close to the inside of the skull and skull pieces. And plus, this will also have another cutout where the brow is, and where that ring is will also have a cutout because all that's going to be open. So because of the movement of the eyelids plus the movement up down movement of the brows. So once again, I'll delete the skull and the bottom pieces, and then I'll export this into SketchUp, and I'll just hit undo twice in Blender, and I'll bring it all back. But here I have the skull piece, and I see what I'm having to do, but now I'm looking at this and seeing that now this needs to go into it needs to go into ZBrush so I can put the skin on and see how that looks with it and see how much I need to adjust. But I need to design a gimbal, and that's going to be for the bottom plate, and the bottom plate it's going to be a small area there for the gimbal. So now we're going to build a gimbal, and we need a gimbal to be on the underneath of this skull, so it have a up, down, left, right, look all over the place. But to achieve this, we're going to need some parts, and these are the parts that I choose to use to make a gimbal. But and all these parts are available at Servo City or Go Build a, and these are good RC places where you can get servos, but they sell this little aluminum
bracket or aluminum plate here to go on a servo, and it has a bearing inside there where that hub is, and it gives it a lot more strength, and it's just more stable if you use that. And I would recommend this all the time. I mean, this is a really great piece. The only piece that I don't have designed is this hub right here, and I need this hub to make this gimbal possible. So I'm going to sketch it out. Now, all these files available on Servo City, they're step files, and you can download these and you can put them in your Fusion 360. Now, I can't put step files in SketchUp. So I can put STL files, and you can use another software called FreeCAD, and you can take the step file and you can change it into an STL file. But the thing about that is it's a time thing, and then on the other side of it is it makes it so much larger. It adds so many more vertices to it, and plus it's it's from a milled software program or a file. So it's going to be a larger size file. So I just make a simple version of it because I'm not printing this. I'm just using it for measurements. So I just go by the schematic which they provide, and I just sketch it out, and I will always have this piece to put in my own library. I get a lot of these parts from Servo City, a lot of these aluminum pieces, and this uh, the servo block is really made well, and even the beams I use, which I'm going to be using on this gimbal. But you just you know if there's a part you don't have, you can sketch it out. Plus, it helps you develop your skills in drawing or sketching. You know, just to have the piece in your library. And then now I'll probably use this piece multiple times in the future animatronics I make. Okay, now since I have this piece designed, now I can just place it. I can rotate it right here, and this little line that's sticking out, that's my guide, so I can place it center axis to the other object and just raise it up to where I need it. But now we're going to design a universal joint. I mean, I use universal joints for my large eyeball mechs, and usually the U joint right here you're seeing is 22 millimeters long. Now, some of the smaller eye mechs I use is 13 millimeters, and they're much smaller for smaller eyes. Now, a U joint is what it's called short instead of universal joint. Is you have a center axis of this U joint, and you have a center axis of a sphere. So if you line up the center axis of both, you will have the perfect rotation, especially of an eye. And the thing about it, I mean, if you see here, it's just it's perfectly centered. So, and you can see in some of my other eye videos how I determined to make this to fit my making of my IMAX. But it's a process. It's a learning curve. But the benefits are great. But this is the rotation it does. So you have your left, right, and this is how a universal joint you know rotates. But what we're going to use it for, instead of moving an eyeball, we're going to move a head with it. But with this head that I'm designing, it's kind of on the small side, and this 22 millimeter U joint, I've used them before, and I've had to buy other hub pieces so I can mount it to my animatronic heads to make the gimbal. So what I'm going to do is I'm going to make a kind of a poor man U joint or universal joint. Now these aluminum brackets right here are mounting brackets. They're used to mount shocks, like RC shock absorbers. So, but I take them, and you can also make heavy duty linkages for them too. So I take it and I take a 2-hole beam, and I have this 9-hole beam, and you should check these out. I'll send y'all the links of these beams because these things help for large projects. I mean, these aluminum beams, there's a hole every 8 millimeters, a 4-inch hole, and on each end of the beam there's a threaded hole for a 4 millimeter screw. But you see how I mounted this so-called U-joint to make a poor man universal joint, and it works great. So, but for me to get this thing to rotate, to move up and down and left to right, well, we have the left right because that's the servo on the bottom. That's going to rotate. So I'm going to need 2 more servos to move linkages to tilt the head. And I'm going to need something strong enough because you got to also calculate it's going to have skin on it. And all the servos is just going to be the whole skull mechanism plus skin. So that's going to be a little weight. So I'd rather do overkill than under. So this is what I'm going to show you here. This is some of my library. I have a lot more servos that I design. So I just, get all the schematics and just draw them up, and I can just, if I need a servo, I can just pick it out of the library and place it here. But this one here, I'm trying to determine to when I have the chest piece made for this alien, and I'm going to show y'all that later. And I need to make sure that I have clearance on the skin, because this whole alien is going to be like a bust, and then the chest piece and the neck has to be designed because this is going to have to be in underneath that whole skin area, and it has to rotate. But the neck is what's going to rotate, and the chest piece is not. That so-called rubber or the silicone chest and neck, all that's going to have to be glued down to the so-called chest plate. I guess it's plastic part underneath it. It's going to be a support for that skin so I can attach the skin to that chest plate. That way, when this thing rotates, it's all that part's going to stand still, and the head will rotate and tilt, look up and down, more natural looking. So this is why I'm designing this gimbal. It has to be a tight design. So, uh, you know, cut down any kind of space or whatever, and I might have to tilt these servos up and remove the so-called plate that I designed on the sandwich in between the 2 hubs. But I'm making servo sockets for these servos here, but once again, I could bypass the plate and connect the 2 servos to the so-called beam, and this go directly to make it more narrow, I guess, because the servos are going to have to turn with the base. There's no other way. You can't have those servos off that base because it just won't work that way. It's not mechanically correct. But as you see here, and I'm going to rotate it, and you see how everything turns with it. That's the rotation of the bottom servo. And to get it to tilt, you'll have the 2 servos on the bottom doing that, but you can pull one and it will tilt to the right and raise up the other one, and it'll have a really good tilt mechanism as you see here. But when you combine all 3 of them, you'll have a full gimbal. So later I need to design a chest plate to hold the so-called servo block in place. And all that's going to have a hole on top of it to go up to the head. So now what I'm going to do is I'm going to do a STL file of the whole thing here, and I'm going to put it in the ZBrush and see how far adjustments that I need to make. As you see, the skull is bigger than I had designed, so I mean that's just part of it. and more likely I will reduce a lot of this because this is just a sketch of the skull. So I'm going to manipulate this sculpture here to fit this, and we're going to, see what it looks like. And this is fun to me. I enjoy doing this part. But I want to thank everybody for subscribing again, and all the comments and the likes and the sharing. And I appreciate it. Now I got things set up where I'm sorry you're going to have to start seeing ads, but that's the way I can produce some kind of income to support this channel. And I also have it where uh, they call it a super like. If you want to donate to this channel, you can. But once again, I will have a Patreon set up soon. But I'm setting up all the so-called, I'm getting all the information to all of my suppliers and servos and things like that, and even the beads that we're going to need to make this animatronic possible. And I just want to make sure I have enough of the supplies for the demand it seems like we're going to need. But now, as you see, this gimbal's been made. That's going to be an added 3 more servos to this whole animatronic. So we got a total of 11. But you see here, I'm forming the neck. And this, it's going to be like a bust shape. And I still not quite sure if it's going to be this tall or not. Even though I have that 9-hole piece of aluminum, I can reduce the size of it and raise everything up some. But if I raise it up, it's going to jeopardize maybe some of the shape of this so-called skin around the neck. But it's something that I'm willing to try to just see if it can work, and I can manipulate the so-called servos onto the beam itself to narrow everything down. And the smaller it is, it's more easy to mold and more easy to print to make the mold for the skin. So that's another thing. And once again, the smaller it is, the smaller the printer also. But I just sketching some kind of design. I kind of want a neck similar to this. I mean, it's going to be and when the skin's made, it's still going to have to stretch over the head. And don't get me wrong, there might be some time I might have to make cuts and repair it, but I'm trying to avoid that also. The closer I can get where I don't have to do that and just make one big mini mask out of silicone is my goal. So I'll just manipulate this and add some textures to it, and that way I can do a low poly version of this and bring it in there to help me design my so-called bus shell around that servo block. Yeah, I got almost 6,000 subscribers now, and they said 5,500 in less than 28 days. That's a big achievement. And I just received 4,000 hour watch time, and they say that they I heard that that's pretty hard to do and within a month. But I, it's just that y'all have an interest as I do. Is everybody kind of wants to make animatronics. But this is the neck I've designed. But I'm happy with it. It's just something to see a neck on it. But I'm just trying to see if I should later on, it's always making some kind of minor adjustments and even major adjustments. But we're going to have this thing up and running soon. But this is the big planning area just to make sure that we have, everything has to be precise and measured correctly. But what do y'all think? If you like it, y'all hit that thumbs up, and hope that gives y'all ideas for y'all animatronics. Well, I hope this helps. We're going to get this thing up and running. We're going to make some more adjustments, and we'll get this animatronic completely made as far as
the whole mechanism working and moving, and then we're going to start on a core, and then we can start on a final version of the sculpt. Y'all have a great day. Later. Hello, everyone. This is part 7 of the 3D printed animatronic creature, and I'm going to show you today on me building the so-called or design the gimbal cover or gimbal base, bust, or housing. This is what's going to be holding the so-called the turn mechanism for the gimbal, and or hold the entire gimbal in place so we can cover it with a chest skin and a chest plate. So I'm going to show you all the whole process here. In Decimation Master and ZBrush, I was able to reduce the polygons. But then also what I do is after I do that, I bring it into uh, ZBrush or the Z remesher, and that way it'll clean up the poly groups as you see here. And I'll still want to reduce it. I don't want it too large. Try to keep it under 2 megs if I can. But this is what I have. But still, I have to make sure everything is kind of, centered. I mean, that's the key to this whole thing. And and at the final design of this, now what I'm going to be doing is making, once again, the bust enclosure, I guess it would be, that holds the gimbal in place and covers it so you can put skin over it. But in that skin area where that plate is, it's going to be glued. But what I did here, I made a copy of the chin and neck area, or the chest piece, what we're going to be using. So I want to just cut away this chin area and just do a slice cut of this whole chin area. Now, later on, this thing that I'm designing here is mainly for when the animatronic's finished. But it's going to have, there's going to be there's going to be 2 more of these. One is going to be for the sculpture, and an exact duplicate of that one's going to be for the core. And y'all have not seen the core yet. Now, that creature being low poly is probably the closest to the core that we're going to see this early in the process. But it's going to be mainly the more of the shape of the animatronic than you see the creature. But it's going to be blocked out. But this whole base is going to have it's going to have mold keys in it, and this is the critical part of the whole thing, because when you mold the creature in silicone, and them keys are copied into the silicone, and then when you take your core, the core will fit into those keys. So now you have a space generated through in the mold. So when we put the silicone in there for the skin, it will make the skin. But here's where I started designing this so-called, I guess, the chest plate. And as you notice that I had reduced the size of this thing so skin will lay on top of it. Now this will be a 3D printed piece later, just so we can put the skin on it. And the skin on the very, border of this whole skin area will be the only thing attached to it. Everything else will be moving freely. It's just to keep that skin stationary when the head turns left, right, up, and down. So, but you notice the size of it being somewhat smaller, so we can go ahead and just generate the skin for the later process, like I just mentioned earlier. But now this is kind of the enclosure part of it. And all this is going to have to be modeled, edited. All this underneath this will be removed, and it'll be like a shell of this so-called chest piece on the inside, and all smooth and stuff like that. So,
there's clearances, and there's also going to be an access panel. I did make one for the back, I mean for the bottom of it, but there's going to be one in the back also, so we can make any kind of adjustments and things like that. And if we're going to have a servo controller, it's just the location of that. But and like this, the servo block has screw points, and I have to design all that kind of a carriage. I mean, you could even put another servo in there to move the gimbal back and forth to make it where the whole neck moves forward and back, like in a like a seesaw method. But here I'm just kind of basically forming this so-called area around this chest piece, so we can and I have to have clearance for these servos, and you'll see later what I had to do from what y'all seen from the last video, what changes that I've had to make. Here what I'm doing, I'm just kind of modeling an area so I'll have room for the servo block to rotate, but it's up a little high, and you'll see that later where it's going to be placed at. Because the higher the gimbal, the the shorter the linkages from those servos to do the tilt mechanism. But it's just a simple design. This plate right here is just going to be an access panel to where I can work on anything. But I can't. I mean, I could probably pull the gimbal straight from this box, but I'd have to make sure that I have access to all my screw points to the so-called servo block. But this is a lot of planning for this animatronic to achieve this realistic movement. It's just a lot of designing and planning, and you test, and if something don't move right, you have to redo it. But you see here, and this is what I've gotten so far, and this is what it would be like. But you see my servo horns are sticking up or sticking out of the skin, so now I know that it's not enough room. So now I got to make adjustments, and this is how I made the adjustments. So what I do here is I'm going to bring up the gimbal, and you'll see where the servos are. And the servos will show those so-called servo arms, and that controls the linkages. Well, if they're sticking out there, so I got to manipulate this. So what I'm going to do is I'm going to invert these so they're up, and I'll be able to mount them on this aluminum beam, and I'm just trying to work out all the problems. And you see now I've generated some area to work with, and these servos are small, but they're end to end. So, but I mean, they are considered micro servos, but they're on the wide side, and they're heavy. They'll lift heavy torque. So what I'm going to do here is I'm going to remove that so-called spin table because I won't need it. Like once again, I'm just going to mount it on this beam. But what I'm going to do is instead of having a 9-hole aluminum beam, I'm going to go with a 7-hole aluminum bead. So I put this circle, this called cylinder around this. This way I can see some kind of clearance area, as you see here. When this rotates, this will show me clearances that I have for these, because these servos will be spinning, and I mean, they have to be there, and they have to spin with it. You can't put them separate, as you see here, but it's still too large. So I got to the point to where, to save even more space, we're going to design another servo. So I'm just going to eliminate all the headache and worry or try to figure out that. So
I went on the King Max again and I got a schematic of another wing servo, but these so-called screw points are horizontal instead of vertical. So that way they're thin and they're pretty strong. And I just did the research and I searched through a few of their wing servos and I found one that had a pretty decent torque, but not a whole lot of torque. It don't need to be, lifting 40 pounds. It only needs to be lifted maybe a pound. And that's overkill because this thing is small, but you got to realize that I will be lifting or rotating uh, about 8 servos in the head and plus the skin. So what I'm going to do is I'm just going to go by this schematic right here and I'm going to draw out this servo and get it all, just a quick, easy reference. And it's accurate because I'm just following the schematic measurements. Now, I like servos a lot, and animatronics, and it's a passion. And I go in there and I search and do research for the servos and which one to use. But everything is a measurement, and by having a library of these servos, you can know what sizes to use. And like it's a perfect demonstration of what we're dealing with now. The servos that I had in there, and I couldn't put them, any other way. It's just that way. But I'm going to show you what I did with these servos, and I think you're going to like it. So after I designed the servo, I'm going to make a servo block. But I'm going to do this setup a little bit different than the other one. Instead of being bottom to bottom, I'm going to put them, because this is half the thickness of the other servos. I'm going to invert one and have the other one the other way. So that way I have left, right, and they're sandwiched together. But you'll see how much space I've saved already. And this will narrow the so-called linkage area. And I'll just place this on that same beam. And I may lower the beam back down to a 9, but we're going to see, and I'm going to demonstrate it. Here, I'll just copy a servo horn off this other one, and I'll just place it right here onto this servo because these horns match the same size. Now, on the schematic, you'll see 90, I would say 99% of the servo schematics that they have out there, you'll very rarely see one with the horns on the servo or design, the schematic itself. And I wish they would do that because you need to know the height of the servo horn that's on the servo, because that will give you the correct measurement where your linkage is going to be. And see, I don't really truly know that until I put that screw inside that servo and mount that servo horn and measure it with a caliber. But once again, you know, it's one of them things is, I guess, I should have done this first, and then that way I wouldn't have had any kind of problem. But you see the clearances I have. Now, it's not going to be moving, 180, this creature's not. It's just going to be, maybe a 70 millimeter, uh, 70 degree, but I think this is going to work well. What do y'all think? Now we're going to take a look at X-ray, and you can see how everything's going to be mounted, and you see this the servo block on the bottom there. And then this way I can kind of work things out, and where I can maybe location for the servo controller, where it will need to be located, kind of design the so-called openings and to where I can have everything laid out correct. And then, but as you see here, you can see a good profile look, but it turned out well. But I'm happy with this. This is the start of having the thing, it's getting close to where I can start doing finalization on all these parts. But it's coming along.
I'm going to pop this skin on, and then I'm going to remove the skin again and make an STL file of the animatronic. And then I'm going to import it into ZBrush, and we're going to put the skin on this, and we're going to do some studies to see how it's going to look with the skin on, and see it in an X-ray version. So what do y'all think? Let me know in the comments. If you like the video, leave likes and comments and share, and I hope y'all like what I'm doing. You know, it's fun. This whole video right here was 2.5 hours of recorded work, but you know it's what I like doing, and we'll get this animatronic up and running with skin on, and it's just fun. And I want y'all to be part of it. As of right now, I'm looking at it, the numbers right now, I have 6,670 subscribers, and thank you so much. And thank you for the thumbs up and likes and the sharing, and I appreciate y'all, and I'm glad y'all have an interest in my animatronic creature here. And this has been 3D printed animatronic creature part 7, and this is what we have, and this is what we're going to be making, and I'm going to be setting up Patreon, and when y'all share these things and comment and likes, it helps this channel to generate some kind of revenue for me to support the content that I'm doing. But we're going to have the Patreon set up, and we'll have files, and y'all be able to build it and make it move. Y'all have a great day. Thank y'all again. Later. Hello everyone, this is the 3D printed animatronic creature, part 8, the teeth. And I'm going to show you how I put teeth in this animatronic, and there's a certain process on how to do it. I've made a lot of teeth. Like I said before, I was a dental lab technician for like 30 years and made enough teeth to fill a city. So, but I like making creature teeth, and I made a lot of those too. So I want to show you how I do it for an animatronic, because it needs to be kind of precise. So what you're doing is you're going to be filling a space, which the space is the upper space and the lower space where the teeth go to make a bite. And then when you have your hinged jaw, it will fit correctly. But like if you see here, I've made a lot of teeth with this free software called Sculptress. And Sculptress has been around for a long time, and I've been using it, and a lot longer than I had said before, because I didn't realize is, you know, I've found things that I've done in 2014 and 2012, matter of fact. But these teeth here are just like designed for, you know, doing SketchUps or doing sketches and sculpting and stuff like that, like wolf teeth and ape teeth and just creature teeth. And once again, I've made a lot of them. But when you have creatures and stuff, you know, the teeth kind of make the creature, you know. But, you know, being this alien type deal, I really don't want to go anything too fierce, too much spang, be more like human or whatever. But you can kind of manipulate these teeth, you know. Basically, what you need to do if you wanted to do this yourself is you would copy, or you would make teeth individually, and then you would bring them uh, into the software. And how you would do that is like you got your central, your lateral, your cuspid, your bicuspid, second bi, and then your two molars, and that's just on one arch, one side. But you only need one bicuspid and one molar, and you can just resize it. Just keep adding it until you have a full set of teeth. And then you also have four other molars in your mouth, and that's wisdom teeth, but most of the time they're not used in making dentures. But anyway, I just basically model this and just kind of shape it to get a look what's fierce. Everything has seemed to have like fangs, which a fang would be considered a cuspid, and or they also call it a canine. So, but in designing these set of teeth, I'm wanting to show more gum. That way, when the lips of the animatronic, when they raise up and lower down, you'll see some of the gum on the animatronic. So I got to keep the teeth kind of on the small side. I just don't want you to see all teeth. I want you to see teeth and gum. But basically, when you can design these teeth in sculptures a way where I've kind of, and you are limited in sculptures now. There's a lot of things you can't do. You can't bring in a lot of things. It has to be really simple. It's no ZBrush, it's no Blender, but it's a good fluid modeling tool. And it took me forever to just figure out that I could actually delete things, but but that was way back when. But I want to show you the whole process on how to make these teeth have a bite for an animatronic. But on here, I'm just modeling something just to show you that you can bring in teeth, model a little bit at a time. You can remove teeth. Now I removed one of the bicuspids and one of the molars, so I can, this is an alien creature. We're gonna do a little bit different kind of setup instead of having a bunch of teeth in the mouth, and you see me just moving those teeth out. But a better way is, I feel like on doing these teeth is you make an arch and you save it. Now, when you save in sculptures, it's OBJ, and that's the only way you save it. But then if you bring it, if you copy that upper, and then you can bring it in, and then just mirror it, invert it, and then you have two arches, and you can just resize one to the other, which some of the teeth on the lower are smaller than the big centrals. So I just kind of model this, and you have your gingiva and your gum area, and you kind of want to make it kind of tight, but not too tight, because you do have some long canines, and space for the fang, and you just don't want it to be too much to where when the animatronic bites, it's biting into a tooth. And you kind of design the teeth to fit in the cusp. That way, it won't be like an open mouth all the time where it can't close the teeth because it's hitting something. But when I finish these in like dental acrylic, they'll look better, and I'll be able to manipulate a lot of that, any kind of problems that it may occur by not closing the teeth all the way. But by doing it like this in a design, as you'll see, they'll fit really well. A lot of my art that y'all see me do is, I'm using free software. I've once again I've been kind of a starving artist, and I just do what I can with what I have, and also it's kind of just to show what you can really do if you just set your mind up and just do it. And some things is you can do it, but once again, you see me here modeling this lower denture, just doing some detail. And a lot of these things is when I get this molded, I can do a lot of this work on the dental lathe that I have, and y'all actually see the process of like making the denture for this alien creature. But it's fun, and you just gotta watch things like back here. I'm kind of smoothing this back of the upper arch here because I don't want the mechanism of the lip to interfere with anything in the back where it might hit it or bump it, and it might prevent it from closing or whatever. But this is part of it, and this is the sculpting part in Sculptress. But we have another sculpting area that we have to do, and that's to manipulate for the plates. And the plates are coming up soon. Now this shot right here that I'm doing, this is all sped up times 8. And I mean, it can get, I mean, this is like, I don't know, 20-minute video, but I put like 2 hours into it, I guess it was. But there's just a lot of parts, to make this process happen. But I've kind of figured out a way to, you know, once you do it enough, you get where it's pretty natural. But once again, I'm just kind of smoothing things out, making sure that I have room in the back. Maybe even add a tongue later or something like that. But which would be if I had the tongue to move, that would be another servo, or I could just link it to the upper, and every time the upper or the lower jaw moved, it could maybe raise some kind of tongue or whatever. But that's later on. We're going to get these teeth made. But I'm happy with this design right here. But once again, in Sculptress, you save as an OBJ. So then you gotta manipulate that size in OBJ. But what I have to do here is delete one arch and then send out that file, and then I'll bring it back and delete the other arch and then save that upper arch. And both are saved as an OBJ. Now we're going to be in SketchUp again, and this is what we have to do to make this work. Now these are the old teeth, something I just threw in there to get some kind of a look and pre-measure my lips, but I need to put its own teeth in here. And the way I do this is this little plate right here, or this panel, I'm going to copy it and make a panel or a plate. And this is going to be roughly 2 millimeters in thickness. But these plates, are the big key for these dentures I'm going to make for this animatronic. And I also make a plate. I copy the plate off of the jaw, and this one's a little off here, so I have to make sure that I can level it and get it back into the right position. But this is also going to be 2 millimeter thickness, and you'll see why in a minute. But and here, when I copy these two plates, and the space in between here is where the denture is going to go, and that will generate the proper bite for these teeth. And these plates now will match up correctly. So now I'll take these plates and I'll make a line here. And this line's going to make it center to my software, which I'm in SketchUp here. And I want it to match up the center in Blender because we're going to be sculpting. And got to make sure everything is center in both softwares for this to work right. I've saved those panels as a STL file, and imported them, exported them into Blender, and here they are. Okay, so this, and STL files is the proper measurement. The measurements are stable. Now OBJ file is not stable, and if you see these teeth that I bring in, I'll export them into Blender, the teeth, as a OBJ, and they're tiny. But I copied each one of them separate, so when I send them in, they're both separate upper and lower objects, but they're matching the proper center point. So now what I got to do is I need to manipulate this size, as you see here, to go in between these two panels. Once again, this is sped up times 8, and but what I'm just shaping it. It's X Y Z. Press G, and you can move it when you press G and X. You can move it that way, and X, so on and so forth, or S to shape it. X Y Z also, and I basically get a fit on the panel. And the key to this right here, I'm going to be using a software or a plug-in or an add-on, they call it in Blender, uh, called Box Cutter. And what I'm doing is I'm manipulating the sculpture that I had using Blender Sculpt. And I'm making sure that I go through this panel. And I just, because that panel is going to be a part of that upper denture. But those two panels are one object right now. And later I'll have to separate those objects, and I'll tell you how to do that. But here I'm just modeling the upper, okay? And it's mirror design as far as in sculpting. And now I'm going to do the lower so I can manipulate those gum and gingiva. And if I have to move the teeth to get them right, I'll do the same thing. But I'm actually going through this plate. But but it, and this is basically how I've been doing all my teeth for a few years, and to design any kind of creature teeth for animatronics that I've been making. But it's not a really, it's just a quick demonstration of what I can do really quick and give some realistic teeth. And a lot of this detail will be also made when I make the dental acrylic version. But right here, I crashed my computer. And what that was is when I went into, and I put this in the video for y'all to show. One thing is, you see this? This is old teeth that I had made. When I went back to see if I could recover, it brought back some old teeth. Well, what it is that I found out later, because this is the newest version of Blender, 4.0, I believe. Well, there were some issues with the so-called plug-in or box cutter, and it didn't want to work right. But I had not saved yet, so remember to save your projects. But what I had to do is I had to change Blender software, go back to an older version, so I could use uh, box cutter. But like right here, I'm in 2.8. But right here, if you see these plates, I go into edit mode and I highlight one of those plates, the upper, and then I press P, and what that does is separate and makes that upper plate its own object. So now I use box cutter and I cut through that top plate. All right. So you wait a few minutes because my computer is slow because I'm recording everything on top of that. So now I've made that cut in box cutter. So now I'm going to highlight everything. And I like doing this because it's more it's more comfortable. I don't want nothing to move right now. So I just tilt the whole thing. And then I do box cutter for the lower. And it just removes everything, everything that's underneath that panel. But that panel plate, as you see here, I'm doing box cutter again, and I'll remove all that there. Plus, everything else it is inside that panel plate. So I get that done, and then the next process is I just rotate it back in its right position. Now, the box cutter is like a bowling tool, and it's really good. It really cuts well. It can do all kind of wonderful hard surface modeling. But after you apply that, you got to apply that boolean, that cut tool. But also, when you apply for each arch, we also got to make sure that we join each arch to its own panel. But on the boolean or the box cutter tool, we got to make sure that we remove these so-called, they call them in the directory, cutters. So I have to delete those because these boxes will appear when you save as an STL file. And when you put them up to print, you'll have these so-called boxes like you see here. They will appear on your file. But to remove those, you got to delete those cutter in the directory. But everything has been set now, and I've joined them to the panels, and you just, highlight both and you join them. Now, I had saved those two as one single piece, upper and lower together. That way, this is the bite, and I want to make a low poly version in that destination master in ZBrush. I can lower the poly count because it would be like 100 megs, I guess, and it would be too big for SketchUp. So I went through that so I could put it into SketchUp, a low poly version. But there's just certain things that you have to do to get this thing to work right. But it's important for this to be this way because you have to have a correct bite for this animatronic, and it's because it makes it look so natural. But as you see here, STL file matching up to the other panels, and they match up correctly being STL files. So now I'm going to put them into the animatronic, and this is the old teeth. Now I just put this in there as far as a guide for my lip mechanisms. So I'll just a basic set of teeth. But and this was something that I made from another creature. And matter of fact, this was probably from that small baby creature that y'all saw the skin on the first YouTube video, as you see here. But I made some to fit this animatronic correctly, and then there they are there. Well, the teeth fit well, but also I wanted the teeth to be a little smaller because I want to see the gum, especially when them lips raise up. You'll see more gum than just a bunch of white teeth. But sorry, I was very happy doing these. It's I appreciate everybody. I hope y'all. I hope I show y'all some techniques that might help you in y'all's designs of animatronics. And I really do. And I appreciate all the likes and the comments. I really like the comments, and I try to answer all of them. But here's the prints I made of the teeth. Now you see how big the teeth are going to be. And after I get all this stuff cured, we'll make a mold of them in silicone, and we'll cast dental acrylic, and we'll make them look like really dentures, realistic teeth. But once again, thanks everybody. Comment, tell me what y'all think. Uh, like the video. Thank y'all so much. Channel's still growing. Hey, y'all have a good day. Later. Hello. Well, we're about to hit 7,000 subscribers. We're like 25. Last I checked, 25 subscribers from 7,000. Wow, thank you very much. Thanks everyone for the comments and all the thumbs up. Thumbs up's great, man. It helps my channel. Well, sorry I ain't had a video up earlier. I've been sick. I had a stomach flu, and on top of that, I have Crohn's disease. So it kind of magnifies it about 10 times. But anyway, to the design, this is what I've been studying, mainly to get this connected to as far as this ring underneath the eyes, so I can have this in like one piece. And it's not necessarily the outside of this ring, it's the inside to where the linkage connects to the servo. I got to make sure it has clearance. but also I'm going to try to join these two together. But you'll see me, I'm trying to study because if I can cut this, horizontal to where I can print it like a flat plate, I like to do that because it helps with the supports, and I try to avoid supports if I can, even if I have to have multiple pieces. But I just that's just the way I like it because everybody knows that 3D prints, supports can't suck. Now this is recorded as far as I've sped it up times four, but you're seeing what I'm trying to edit here, and this is just part of it. You'll find out sometimes mirror seems to be off, so I'm having to make adjustments. Now, once again, it's at speed 4, and I'll remove a lot of stuff like the hourglass. My computer is about 12 years old. It's an i5, but it's still powerful and still, still does the job. So, like I said earlier, that the measurement's a little off, and I'm talking like a, a quarter of a millimeter. And you don't think that's much, but it can, you know, later on affect things. So what I'll usually do is just mirror again, and it's just me just editing. And what I did is I uh, linked up the interfacing faces and joined these blink mechs to this main support table here. And I'm just going in here and editing the inside to where all this needs to be removed. Like, you don't want to have anything that you're going to 3D print. You don't want any kind of, extra vertices or anything like that. So I just go in here and I edit all this and make sure it's clean, because that way, and I check everything on NetFab, make sure I don't have any, you know, problems with the print, because it sucks because you have to do it. It's just part of it. But like these screw holes here, I'll just, once everything is set right, I'll just push them through again, as far as extrude them and be new holes through the whole new plate. But it's just a little editing and getting everything set up just to get this one side of the mirror complete, so then that way I can just mirror it and it'll be all correct again. Here I'm just trying to, make sure I get one side correct before I mirror it. You know, I use NetFab to check, and sometimes it'll find errors, and I can't find the error they say is wrong. But and there's auto repair and stuff like that. But still, I like to try to fix it myself. So I, I have those two uh, IMAX connected to this main panel. So if I mirror one, I have to mirror the scaffold also. But it's just part of it. And then I'll keep it in mirror, and then that way, I won't physically join them into one piece yet. I'll wait because I'm going to probably keep adding things to this base plate anyway. But as you see here, I got to make adjustments to this scaffold area here to where it has a little support that raises up about 5 millimeters. But I also have to make sure that that scaffold is level when it prints. I'm going to print the whole scaffold in one piece. And usually I find myself working on the right side, but and sometimes I'll switch it up, but you got to be careful, and that's when you'll, you know, mess up a mirror. And it's kind of hard to do that, but sometimes I mean, I'm talking about as far as, a quarter of a millimeter off, and it'll add up. You will see here that right here on the component on the left eye,
that when I remove the component, it locks it onto the frame of the eyelid neck. So I know I'm going to have to just remove this whole section anyway. So basically I just highlight this whole side and just delete it and just clean up any vertices, lines. I noticed I had a few comments on people. They hear me breathing, but I don't have, I just have a simple mic, ain't no high dollar microphone. So I apologize if y'all hear me breathing. It's just I have a close mic. If I have it away from me, you can't really hear me that well. Another thing about Mirror is that you can go back to it if you want to make another animatronic. You can use this again as like from a library. But you can only go so close to where the linkage is hit. But then you have to either change to two servos to one servo. That way you can control them with one. But that will kill the mirror design. But it's fun though. But you'll see here where I'm trying to work out this so-called ring under the eye. And I just have to make adjustments to this ring so I can have clearance on the mouth or the lip hinge. I got to make sure I have clearance there, but I also want to join that ring to like the bridge of the nose and things like that. All that needs to be filled in because I'm going to have skin attached to it too. I don't want an empty space there because that skin will be baggy, but yet it could produce a weird kind of movement when I'm moving the lips. But I would prefer to have something to stick the very upper top of the lip there so it would just curl up the upper lip itself. But a lot of this design stuff here, like, I want to be able to make sure that that second part of that ring is the same flatness as that first ring. So I have to make, little plates to do that interface with mesh so it'll be flat. But that flat part's going to be connected to that support of the lids. And I make mistakes, and also I design things, and I says, well, no, this is not going to work. So, and I'll end up recording all of it, but then I'll just trash it all, and then start over and do a different process. But I'm just trying to get some kind of and this is where I'm wanting it to be critical, is the inside layer to where that hinge mechanism connects. The linkages have to have clearance, and I can't be bumping on anything in there because it's just going to ruin the whole effect. Then you have to either redesign it and print it. It's just foreseeing what I need to do. But another thing I've been working on too, if you when you design these things, you have servos, and that's the primary key to the animatronic. Have something move the so-called object. You have to have the servo motor. But if you can't find the servo you need, or you can't find a certain type or size or shape, and you have to, there's thousands of servos to choose from. And like for instance here, I want to make sure that I have another plan. Like these servos will work also. So what I do is I search the internet and make sure that I have a plan B. And just like right here, I'm making servo sockets for these servos. But I want to keep my servos in this head the same. You know, have them 8 of the same size, like 8 wing servos or 8 sub micro servos, because you know I have my subscribers eventually will be on Patreon, and I need to make sure that I have plenty of servos available for y'all to get or order through me or order through a certain link I provide, and then yet you can find some available, but yet they might only have three instead of 8. But if we have 7,000 subscribers here and half of y'all joined Patreon, we got to make sure we have a lot of servos, for this animatronic to work. But I've been talking to, a lot of suppliers just to make sure that we have this available. But as far as another little trick, what you can do, if all the servos are the same size, let's go up even bigger. So what I do is I'll take a measurement once again of the so-called screw point, which I know it's 28 millimeters. So I can take a measurement of a standard servo, which is pretty large. It's a standard size servo that probably everybody has seen, as you see here. So it's 48 millimeters. So I'm going to make this measurement here with a tape measure on SketchUp 2017, and I'll tell it to be 48 millimeters. So what does that do? That makes every screw point in the animatronic to be 48 millimeters, and I've just enlarged the entire animatronic. So you can see the size comparison. If I had standard servos, all standard servos, this is how much bigger the animatronic would be. And that's just making the adjustment to the servo. Instead of 28, it'd be 48. Now here's an early design of a Grogu, and I made several of these things. And see, there's a different process with animatronics. If during the pop culture thing, is just that everybody says, well, no, it's this size, no, it's that size, no, the eyes are this big, and really nobody knows. They're just guessing. But uh, but like I made several versions of this, but mainly there's a different process when you're doing something than what I'm doing. I'm creating a new alien, my design, and I'm doing it this way. But when you have like this baby that I've been designing for a client, a doll maker, and I've been working on this for some time now, but everything has to be precise so we can get a skin on this baby. But what I had to go through was I took she sent me a baby that was silicone, and I took measurements of the baby. But I'm using so-called calipers, and I had to make a core. And this core is modeled from the skull, as you see here. And I filled in all the spaces, where the eyelids go and the mouth and stuff like that. So I sent that core to her, and she did a sculpture on it. And I'll show you that now. But as you see here, she sculpted the entire head on here, and I removed half of it so I could get a profile picture on how thick it is. Now, my measurements were off, but I'm measuring from a different baby size. And I measured the eyes with calipers and took all the measurement. The wideness is correct, but around the mouth and how the mouth is puffy, so I redesigned a new core to go by. And then I'll wait for her to resculpt that, and that way I can go and adjust it, and I had to make a new core so that you can sculpt it. But see, this is a different process than what we're doing on the so-called alien creature we're designing now. This is that we're designing it because this is digital sculpting, and clay sculpting can be done the same way. Like when I make the core of the alien, you could sculpt whatever you want on it, but you just have to be careful on your thicknesses because you don't want your silicone to be thick. And that's the whole key. We're trying to do our best to keep it very thin. And I'm saying maybe under 5 millimeters thickness. Now see, this is the silicone baby. And as you see here, I took the measurements of the eyes. And this was before I've even done anything. And she's a really good sculptor, and she sculpted all these lifelike silicone babies. And she sent me the core. I mean, she sent me the sculpture, as you see here, and I'm making adjustments even where I'm pushing a tool through the clay to get the proper measurements. But this is the original right here, and I'm trying to just match it up to what I have from the baby. But having the eyes have eyelids and things like that makes it kind of not anatomy correct. So, but this would be a key tool to use would be a scanner, a 3D scanner. But once again, it's a different process because this is working. The alien creature is working inside out, and the baby creature or the baby newborn is working outside in, and that can be difficult because if you're doing it free-handed or without digital help. But as you see here, here's the lid, the new lid for the skull. But as as far as how much I replace uh, the parts on the core, I'm going to have to replace the parts on the original skull, the animatronic part, and then I can make adjustments to the face also to where the cheeks will just be sliced so I can have it move those cheeks connected to the top of or the face part of the animatronic. But you see here, here's how big the animatronic here, the creature compared to the baby. Once again, I'd like to thank everyone for the support. Thank you for the comments and the thumbs up. And just overall, really, I thank you so much. And y'all have a good day. Later. Hello, everyone. We reached 7,000 subscribers. Thank you very much. Thank you for all the comments and the kind words and the thumbs up. And we're going to start doing this animatronic work. And let's get started. This is 3D printing Animatronic Creature Part 10. Well, we're going to start here. I'm going to show you what I've been working on, and mainly to get clearance where the lower eyelid and the linkage connects to the eyelid, that clearance underneath there. And I've been mainly designing on it and just kind of connecting things together and just seeing what we're going to have to do, because eventually I want to connect this to the mouth, but more than likely it's not going to be connected. It's going to be a separate piece. But what I'm doing here is I'm adding kind of a mesh look, kind of a sculpted bag underneath this eye. And what I've already done is I've connected that ring to to give the clearance of the eyelid. And now I'm going to add this so-called mesh underneath this eyelid to give it, like I said, like a more sculpted look, you know, more, I guess, organic look. I highlighted that section of the eyelid socket and just this what you're seeing here and in SketchUp, and I made it into a component and I sent it out as an STL file so I have something to sculpt on top of. But I'm in Blender and I'm working this mesh, and like once again it was I pulled up a mesh which was a cylinder, removed the ends, and then I made some more rings or more vertices, and that way I could manipulate it a little bit more in the grab function of the sculpting of Blender. And as you see, I'm just basically just trying to match up what vertices that I can see in the SketchUp file and just kind of stretch this mesh and then form it like I kind of want it. And all this is subject to change also. I mean, this is the whole process and I'm just trying to, to get a look. And plus, I or foresee what I'm going to be needing because when that when that sculpting is done for the so-called alien creature itself, I want it to be able to flow underneath there because if it's too big underneath there, it's going to start looking more human-like, and I'm just trying to get that so-called small mouth, big eye, and just trying to get some kind of an alien creature look. Is This is kind of fun to do. It's kind of relaxing when you kind of do these kind of sculpting the meshes. It just flows pretty good. And once again, I'm trying to match the so-called eyelid socket to its vertices, just kind of blending in and more likely the mouth, I guess you would say the lower cheekbone's going to be connected underneath this also, but I wanted to put this mesh there so because I'm going to have another mesh come underneath that also. But I'm going to probably have to cut the bottom of this off flat because it's now going to be two pieces. And I'll explain that later why it has to be two pieces. Here I'm covering the existing mesh to what I previously have already done. So, but I want this natural or this organic look, but I'm removing all of that work that I did earlier. But I needed to do that to have a guide to do this. But I'll sit here and edit all this, remove what's underneath it, and then I'll attach this new piece to the main form. We're going to speed this part up of this editing right here because and I shot probably 5 or 6 hours of this, and I was doing some video editing on doing it, but some of the stuff, you know, there's no need for you to see, and I'm trying to show you what all I have to do to make this animatronic, and there's a lot of planning and there's a lot of design work to where you're making something that's never been made before, and then on top of that, you're it has moving parts, and you got to look at quality and strength, and you just don't want anything that's too flimsy. It's got to be strong and durable. I've made changes to this animatronic because you know when you sit there and you're measuring, especially if you're seeing it on a big screen all day, you'll sit there and you'll think that this thing is uh, you know 27 millimeters thickness or an inch thick or whatever, but really it might be 2 millimeters, and then you have to say, well, I gotta build that up. So, but that's just part of it. And it's when you get the whole thing made and built and you can actually see it move and it looks realistic and just you it's the closest thing of Dr. Frankenstein, and I've said that before. You know, a lot of these things like this ring, there's a ring on the top of of the upper eyelid. You'll see it right here. Now, that's going to be part of the skull lid or skull top, and where the screw points are in the of the lid socket, all that's going to be flattened, so I will have the skull to lay upon. So that's just going to be part of the ring of the skull, and the center brow and the nose area is going to be filled in, but you'll see that later what I have to do to make space for the nut area for that threaded rod that goes through the center rod, through the eyeball, and through the eyelids. And that's one continuous rod on one eye. Now here, you'll see where I made some changes. And uh, right here in this yellow area, and you'll see that tube coming down. That's a screw socket where the screw falls in. That's just the whole area. But this yellow space that you'll see here, that's a screw point to where I can screw down the mouth plate to this iMac part. And that's just things, and I'll have to countersink the area here in the design. But that's what I'm coming up with is right now. And all that area above it has to be open for the linkage to flow right. And I just don't want any kind of interference. And then you'll see this space here where the nose is. All this has to be open here. And I'll show you here in a second, but the reason why for that. But this bridge nose area right here, that needs to be there because I want the silicone to have something to grab a hold to there. If it's going to be an empty spot there, but the lips are going to be working there too. But right here is where that threaded rod comes through. And there's going to be a nut here so you can, bolt down or screw down, as we say it in the South, you know, just connect this rod together. But I just make a simple nut design and use it to go by as a guide. But the space there is so I can get a tool to work this nut, and I have to have either my fingers or my tool to get in there, and that's where there's going to be a space there. Now, when I make the so-called uh, the skull lid, I might be able to cover that some too. And I'm just trying to determine if I'm going to have some type of magnet on that skull lid there in that area. But you'll see where the screw point is going to be on the mouth area here. I worked on this thing for hours, and I was trying to have room, but the previously I designed these so-called lip hinges, the movements, these paddles for the lips. But there's also one thing you have to consider is how, if I had this in one piece, how would I get them in there? And you get to thinking, and if you see here, I'm moving that center lever there for the center lip. I won't be able to get it in there unless it's two pieces. And that means that when it's being built, I'm going to have to connect the lip hinges on the mouth first, and then I'm going to have to attach that plate to the upper plate where the eyelids are. But in designing to where the bridge of the nose is at, and that whole, I guess, the upper cheek area that I've been working on, that needs to be there for support. And it needs to, and also I could probably design it where I could connect that part so I could print one big piece, but it would just be easier this way just to print it, two separate pieces. And, but this is what the clearances that I had to been dealing with for the past, day, just working on this design just to make sure I have clearance. And I can bring that so-called the nose piece or the bridge on further down. So, and I might change that design, but we'll see.
But I just need to make adjustments to this plate because you'll see here where I need to have where I can fit these in there and just slide them in place because there's also another rod that will go through that to make it a hinge mechanism. And then there's also, you got to make sure that you have, you know, space where I can put a tool or a screwdriver or some type of wrench or whatever. But like right here, I'm going to show you how design a linkage for this mouthpiece. And this is the center lip. And the center lip linkage is going to be pulled from the top level, the top plate. Now, the other two lips, or the other lip mechanism that has like a forked lip, I guess you'd call it, um, it's going to be pulled from the bottom of the eyelids. And I have to have that there just for, because I really don't have enough space to pull it, both of them from the top. But as you see here, I just simply designed a linkage, tab so I can connect linkage to it. And then you have to also think that I'm going to have more than likely a 2 millimeter screw nut going to be attached there, but I'm going to have to design the arm as you see here, the linkage arm that will run from here to the servo to control this whole mechanism. A lot of these adjustments that I'm making on the video where I speed them up because, with it slow, it can get kind of boring. Well, boring to me, but y'all might like it. But I just like trying to speed it up a little bit so we won't be here for 4 hours. But so I got a tab started on the so-called, linkage. So I measure from the linkage to the so-called servo horn, and I had like 62 millimeters. So what I'll do is I'll extend this arm right here, this linkage, to like 62 and a half, whatever, and just make it this so-called, this little linkage plate. But as you see here, it's it's better to move it to the other side and make it thinner. And you'll see here how I'm just cleaning it up, making it, narrow. But then I'm just going to move it to the other side to be closer to that servo. And sometimes I'll sandwich the tabs together where I can have a good grip on it, but that would make a longer screw. But as you see here, it's going through the table, so I got to make adjustment to this. So this is what I do to edit this to make it fit that table area. I just rotate this one part up, and then I'll just edit the whole thing to where it has a curvature and avoiding that whole table. But this is where I can get that clearance from that table. So I'll just make adjustments to this whole linkage here and connect the two together. And just at first I'll connect them, a simple block style. Then I'll come back with uh, a circle tool and just kind of round everything off. But once again, now this will give me clearance from that table, but like I'll have another linkage for the other lip, and then there's 4 linkages for the eyelids. But wherever there's a servo, there's going to be linkages. So, and we have 8 here, 8 servos, so that's going to be 8 linkages. But yet there's 2 linkages for each eyelid. So, I mean, it's a lot of parts, and you'll see here in a minute all the parts that I've been accumulating. But this so-called upper ring in that brow part will be combined and attached to the skull. So that the skull piece will be the largest piece of the whole animatronic. Well, next to the so-called chest piece. But but this is what I have as far as accumulated pieces so far. We have our scalpel, and then we have the skull. It's so-called total 22 pieces so far, but I have several linkages that I've not made yet, and that will be later. But it's coming along. But I have 4 linkages for the eyelids, and the one we just made that you saw me make, that's just 5 linkages right there. But for every servo, there's going to be 1 linkage, but there's the two eyelid servos that I have. They have 4 linkages, but it's just a learning. Learn as you go and design it. Make sure you have clearances and design what servo you want in it, and kind of keep them all the same. But I'm gonna order another servo that's gonna be mainly a lower cost servo because I want y'all to be able to experience what I'm doing, and that's the best way I can do it. But this is what I have so far. Now that will be printed. It's gonna this bottom plate's gonna have servo sockets underneath it, and then there's gonna be 2 main plates, and then we'll have everything just to connect together, and then we'll have it able to move. I like watching them watch videos where they repair the old watches, and that just fascinates me for something having such small parts and all those parts have to be milled and casted and laid. But it's just fascinating to me to see that, and I guess that's what's kind of drawn me to making animatronics. But it's entertaining, and I want y'all to be part of it. And thank you for all the thumbs up and the sharing and all the subscribers. And once again, thank you so much. Later. Hello, everyone. Hope everybody's doing well. Since the last video, which was yesterday, I've accumulated like over 200 new subscribers and been getting a lot more comments and thumbs up, and thank you so much. It's really growing fast, and I appreciate every one of y'all. But this video here is I'm just going to show you I'm kind of it's one of these things that when I have these prints available on my Patreon, I want to make sure that the supplies that go into this animatronic is going to be available, you know, to y'all, like servos. And I'm doing 2 different versions of this, and what I'm doing is I'm replacing these servos here with these other servos, and these are cheaper servos, and they're available. But I just want to make sure that everything, all the supplies on building this animatronic is going to be available. So let's get started. I just basically just replaced the servo sockets with the horizontal tab screw points. That way, instead of screwing down, they screw, sideways. And, it's a standard looking servo because most people don't really realize that wing servos exist. But, they're pretty neat servo, but it's just finding them small is on the rare. There's not too many available that small. And the whole reason why I'm doing this animatronic is mainly is to put skin on it and realistic movement. But for me to put skin on it, we have to have it to fit a resin printer, the whole bust size of the alien creature that we're designing.
and it has to fit into the printer so I can print that, and then we're going to mold that sculpture or that head bust so we can produce the skin. But here on this servo here, uh, now I just laid this servo in place. The original wing servo, when I first started designing it, I started with the eyelids and the eyeball, and I worked, from there. But it was on a flat plane when I first designed the eyelids, and when I rotated it with that wing servo. But here I'm just laying it there in place because, the servo is just a part. It's not going to be printed, but it's going to be at the right angle that I can see to where this servo will move the uh, the linkage is correct to move the eyelids. But mainly it's just to get all the servo sockets in the right position. Now these servos here did have a servo socket that I had previously already designed, but I went ahead and just started just designing it straight off just to replace it. That way I wouldn't have any, off, I guess not square to the tilt position it was already in. So I just decided just to go ahead and just design it from here. But like on this the scalpel, I just removed the screw points and just squared everything off, and then just adjusted and made these little posts, I'll call them, and they just come straight up, and then so I can put screw points there. And then I have to also look and see at a profile view to where I got to make sure that I can get the screwdriver to go that direction, so I'll have you know access point to that screw. And but it was quite simple to do. Like I said earlier, it was only 2 hours of work that just to replace all 8 servo sockets. But I just wanted to show you, and it was pretty quick and easy. But I've not got a final design yet because I want it's getting close because I guess I've been working on this not quite a month yet, but it's getting close, and it should be getting close to start finalizing all the designs and start getting ready to do some test prints so I can get it, just to make sure that all my servos the right socket, because there's tolerances. Even though, like, if something is 30 millimeters and you're going to make a socket, you can't make it 30 millimeters. You should make it 31 millimeters for the socket because you need it to go in, and that's basically called tolerance. And when I'm designing these things that, and I print primarily with PLA, and eventually I'd like to print, something a little bit stronger. But like these tabs might be a thickness of 6 millimeters, which is okay, but I still like, I'll go 7 and maybe 10. But then there's other things that you have to calculate, and depending on the servo, is they have a grommet coming out of the side where the so-called servo arm is, and that grommet is like a little rubber gasket around the wire. You have these 3 wires that come out of it's one wire, but it's 3 wires that you got to make sure you have clearance on that post, because if you stretch out that post too far, you're going to bump into that wire and it's not going to work. But that's just that, foreseeing what you need to do. And when you do enough of them, you get where you don't want to mess up. And and that's why I keep designing and redesigning and keeping things in mirror. And plus, I want y'all to see what I do to produce this. And that way, when I mean, some of y'all are going to be true designers of what you want to create. And that's this whole goal of this channel, is that I want you to see what else that you can make with a printer, a 3D printer, instead of having something that's, making benchies. Now this creature that we're making is going to have 11 servos, and that's going to be 10 channels that we're going to be controlling. So 11 servos and 10 channels, well, the reason why it's 10 channels, because 2 of the servos are going to be mirrored. So that means that two servos is going to be on one channel for the eyelids, and they're going to be mirrored with a Y cable and a servo reverser. Now, I just, like on this scalpel right here, I'm making adjustments right now so I can make sure that I can have my tool to get to the screw point or the nut to where I attach that servo to the servo socket. You'll see me sometimes on these videos how I'm studying what I've designed, and what I'm primarily doing is I'm lining up that servo to what that servo is supposed to be moving. And I can put the servo arm, I can put the linkage on the servo arm on the top or on the bottom. That way I can control it and have space to work with where I'm placing the servo socket. But here is what I'm concentrating on is if I just do one side, I can mirror the other side because I noticed I have another servo on that side, so I'll just cut this in half, and that way it'll be less work I have to do, and plus it'll be accurate. But I don't need that servo to be too close to the other servo because, I don't want those servo horns to be, too close where they bump. And also, like I said earlier, that I can put that linkage either on one side or the other. It just all depends on what kind of room I have. You can see here how I'm lining it up because what I'm lining up there is the servos that are going to be lifting the brow. I have 2 brows, that's those 2 servos we just replaced. And now I'm going to replace a servo on the bottom of the left one here, and that servo goes to uh, the upper center lip. And to make it easier is I just highlighted this servo socket that I just made, and I duplicated it and flipped it, and that way I could just put it underneath there, and that is going to lift the so-called center lip. And I've been designing a lot of these animatronics where it's pretty much line of sight to where, the linkage is straight on to the servo horn. Now, if it's up or down, I can curve and rotate or angle that linkage arm to that so-called part that I'm trying to move. I just clean up this servo socket and get it right, and then I do a flip and just make any kind of adjustments that I need, then I can just drag the whole servo over there and fit it into the socket. But this one here, uh, the other day I had designed a linkage arm to this servo to move that center lip. And now I can push that servo socket closer to that arm as far as move it a little bit more to the right there so it will line up a line of sight. Basically, I just kind of laid a lot of the servos in there before on top or inside the other servo of the wing servo, and I just removed those servos after I get it designed.
because I'm kind of like matching up the servo arm because they're basically the same shape. They do have the same screw points, but these are just what these are sub-micro, micro. Now you'll find out that some of the servo, once again, there's nano, there's sub-micro, there's micro, there's mini, there's standard, and then there's large, and then there's giant servos. And once again, there's thousands of them, and there's thousands of manufacturers. I'm saying thousands, but a lot of them are like rebranded servos. So the same, you'll see a lot of servos like that where it looks like the same one, but they got a different, name or manufacturer name on it. But there's some servos that I just don't bother using. I mean, if you've seen the cheap servos where you can get 20 servos for, you know, $20, I don't even bother because even just buy one and it either is too loud or it's just not dependable or it's no torque. And that's this thing. And don't get me wrong, there are some good cheap servos out there, but when you're moving something, you got to really study the torque and like and I do a lot of tests and I test some of these cheaper servos just to see if what they could handle. And it's just like that little creature that I made, even though I mean it was a small creature and had three servos in the head. Those servos had enough torque to move that thin skin, and this skin's also going to be thin, and I'm sure enough it's going to move it because the torque on these, I mean, it it's they're really good servos, and I've been using these servos that I'm putting in here for about I guess four years, I believe it was. But putting this replacing the servo on the jaw, and this is where I'm getting uh, where I have to make adjustments to this servo because the wing servos are 6 millimeters thickness. These servos are 12 millimeter thickness. So you're looking at double the thickness, but they'll still work. And, it's going to be hidden behind the jaw. So it shouldn't have any kind of interference, but it's primarily there. That one servo there that's on that jaw is there to move the lower lip. But you see here, I'm going to have to make adjustments to the so-called servo socket because I'm only able to move it 30 degrees as opening. But when I had the, 6 millimeters thickness of the other wing servo, I had more room. But you're not going to be able to. I mean, there's only a certain amount of openness that you'll have on a jaw anyway. But I can make adjustments so we can get at least 40 degrees. And being in the design stage right now, I could change the jaw by lowering it down some, but I would have to make adjustments to the teeth. But and that would be another design of the teeth. But I have them on file that I can just manipulate those to fit that socket. Now this upper center lip, this is the fork lip, you know, I have to add this piece right here, and I still need to make adjustments though. But because I'm using the same axis to rotate the center lip and this fork lip, so what I had to do is I needed to connect the two, but I had to make a crossover beam. That way it will have the two as one. But I need to still make adjustments though because even though that this is up and give it clearance, if the fork is down, the center lip is up, you don't want it to bump into that support or that so-called beam. But here now, I'm added that tab there, that linkage tab to that fork. And I just need to make sure that it lines up to that servo to where it's going to be on the bottom panel right here. I have two more wing servos to replace, but also I'm moving this jaw to make sure it has clearance, not only bumping into those servos, but I need to make sure it's not going to be bumping into any linkages either. But here you can see where I'm moving that. This is the center lip. And with these servos now are being thicker and bigger, I really don't have a whole lot more room to put others. Now, don't get me wrong, there's going to be other animatronics we're going to design, and we're going to load them up with a bunch of other servos in it. But if we have small servos, we can have a lot more space to work with. But once again, to have that lower lip move also is a big key of having something realistic movements. And I had to make the servo being direct working mechanically on the lip instead of using a guitar string or a cable push pull method. It just it's more subject to fail, my opinion, and it's better to have a hard linkage going directly to it. And the only way to achieve that is you have to mount the servo onto the jaw itself. It won't mechanically work that way if it's not on the servo. If you had it off the servo, it would have a conflict with the jaw servo. And so when the power's on, the servo arm is locked because it's in a lock position until it's commanded to move. But I wanted to show y'all this process. I wanted to show y'all all the whole process. I know some of this, I know some of y'all just maybe like printing and some of y'all like designing. It's just, I want y'all to see the whole process. And even though that, like I said earlier, that I might have been working on this a month, but a lot of this stuff has come from my previous designs. And to go through a whole setup, which we will do in a future animatronic build, to where I go through the whole process from start to finish, and that's from a sphere to the eyelids and so on and so forth. And like eyelids, there's two different kind of eyelids. You got a blink mech, and then you have a floating eye mech eyelid, to where you have eyelids designed where they have uh, countersink holes in there where there's no straight through rod going through the sphere and the so-called eyelids. There's that method too that I'm willing to share my knowledge that I've accumulated on doing all this, and I learned from it, and I learned from my mistakes too. And trust me, you will make mistakes, and you try not to. No one does. I've had a person ask me a question today. One of the subscribers had said, should he get ZBrush? Hey, ZBrush is a great tool, and they have subscriptions where you can, it's a cost factor there. And this channel here, I'm trying to do it as low cost as possible. And there's a lot of great softwares out there, and some are free and some are really expensive. Trust me. I mean, there's software I'd really like to have. But, once again, it's a learning curve for every software. But Blender is free and it does pretty much everything. But there's pros and cons to every software, and there's some that is really good on measurements. And when I say measurements, the only reason why it got me I guess obsessed with SketchUp is I like the measurement tool. And when you're designing these animatronics, I love how the metric works. And I could tell you probably uh, 4 years ago, I was doing everything in Imperial, and and I kind of learned that metric is when you're designing anything, it really needs to be in metric. You know, we all have the passion for animatronics, and I really enjoy animatronics and love designing them. But there's like two types. There's the kind that you design from something, like you're working outside in. And this creature that we're doing here is inside out. So it's kind of reverse engineering. But you know, I designed like several Grogu's, and you know, a lot of people had certain measurements that they thought it was, and nobody really knows, but except the original designer. But as you see here, I made a lot of them. But you know, it was a challenge and fun and a learning experience. And after a certain amount of time, you get kind of tired of doing Grogu's. But as you see here, I I had to get a part from it, and it was the magnet part, the socket, so I could put it on the alien creature that we're doing now. But this is what I would send to the people that would purchase my files. You know, a kind of instructional video on how to put this Grogu together, and a lot of these parts have disappeared. And as far as you know, Servo City had parts, and they were pretty much Imperial, and now they're going all metric, and some of their metric parts won't fit it. So I'm going to have to be redesigning this and probably put it up on the Patreon, and that will probably be later on. But I just wanted to show you this process, what I went through on designing some of this Grogu stuff. But you know, it was a experience. But I would send this instructional video and some pictures just to help them put this thing together, and they would experience the world of animatronics. Centering a servo, power on, it will automatically center. And then what I do is this is a servo horn that we're going to use, and then what I'll do is I'll just snip off this end of this arm right here, and then I'll line it up to where it needs to be. This is connected in the ear servos, which is the 225 Mighty Mites. This is a Y cable. Y cable is where you connect one normal and then you add a servo reverser. That way you can mirror the servos, as you see here. Here is the linkage for the eyelids. As is connected to the eyelid controller, and it's kind of a loose fit. It's still tight with the nylon nuts. This is the metal servo arm, or the disc. I never could find the right thread. It was not a 2.5, so I just went and drilled them out and put M3s, and then I'll just place it on here, and then so I can mirror it to the other side, and then this has the Y cable with one of them having the reverser. Hello, this is Gary Willett. I'm going to show you how to put this thing together. And this is all some of the hardware and some printed pieces. You'll have a few
There is going to be some, like with the ear servos, I'll send you some other parts to it as far as the ones that's going to have like real skin on it. Because and the long pieces of the ears are just mainly just for looks. You won't use them in actual skin because they won't tolerate it. It's not strong enough. Well, and the upper lid and lower lid, as far as the roof, will have magnets and one will have pegs. But this is the main unit. This has all main servos and controls. And the eyelids this can be kind of fun to do and can be kind of tedious because there's really not a whole lot of room in there, but I have made smaller. But you just put them in there one set at a time. Then you kind of like open the eyelids after you get them all set with the flathead screws. And these screws are 440 screws. And on the outside, and maybe on the inside too, you could probably use the so-called nylon nuts. And but once again, I just open these eyelids up, and this is the closest I can really get to show a quicker way without the messy bench. And these eyes here have a standoff, and this rod here is a 6/32 thread rod, and you just have that 6/32 standoff, slide it in place, and it can be a tight fit. And if it's a little loose because the tolerance is really, really close, you can just drop a little super glue or a little epoxy on there and keep it in place. But you just pretty much thread it on through, and then you tighten your pressure nut, and then you put on the put on a nylon nut on the end if you prefer it. I just don't want it to back out, especially if it has skin on it. You really got to be pretty much, it's going to be a set deal. Excuse me. But just finding the tools to get it in the small space. But it's really fun. You can probably put this whole thing together in a couple of hours. But as you see here, the distance between the eyelid and the eyeball, it can get pretty close. Now the linkage here for these little ball joints. Now for the upper lid, these ball joints need to be cut. And this rod on these is the 256 rod. And I cut about maybe 4 millimeters off of it. You'll still have plenty of room to thread it in there. And then you just kind of remove it. And you can do it, I didn't do it with mine. I'll show y'all a picture. But it works out good. I mean, it's making linkage to make it work and be more reliable. Now the eyelid control mechanism is here, and you'll have a rod that will go through, and its main rod is a 440 rod thread, and you might be able to find a screw that length, but it's just not. I couldn't find them at even a local hardware. I know they have 3-inch, but I mean you could probably make it, but you're so in my designing, everything is metric. It needs to be in designing, but once again, you just put that rod on there, and you'll seal this off with the nylon nuts, and then you make sure your upper is first in the thread, and the lower lid is on top of the upper lid. And then you put these nylon nuts on, and don't tighten them up against the ball joints. Just make them tight on the rod itself and leave it loose. You can touch a little bit, but not put a bind on them. Here is the linkage for the eyelids. As it's connected to the eyelid controller, and it's kind of a loose fit. It's still tight with the nylon nuts. And then as far as setting the servo up, I put this little clock on there just to show you it's basically at like a 5 o'clock position. But you need to turn the servo on first, make sure the servo's center, and then you put your arm in there. And then that that stop link, that's the little brass fitting that's on the servo arm. That's gonna it will thread that 256 rod to the linkage, and it will be tightened down to hold that in place. Sometimes them holes are not small or large enough for the 256, and you can just drill them out with a drill. Just make sure you remove your screw and then drill it out, and it'll screw back in place to give a tighter fit on that 256 rod. Now, the screws that I have on the servos, on these lower servos, are 440 screws, and you just bolt them down, and then as far as you center this mouth servo, and it's at more of a 430 position, and then once again you power up the servo, making sure it's centering, and then you set your servo arm, and it's basically the same way you did the eyelid servo, but you have them opposite from one another. And then you put the mouth, and the mouth also has a 440 support rod or hinge mechanism rod. And then these parts here, I'll send you these parts. These are the newer parts I made just the other day because I've been working on the core, and they were coming out of the core skin. But these are 440, and that connects to the linkage for the so-called gimbal. And this is the gimbal mechanism. This is the main support of the skull that holds and supported by the gimbal. And these little hubs, and these are 256. No, I'm sorry. These are 6/32 screws that holds, and this is from Servo City. And they've made some recent changes to the size of these U-joints. They used to be like 9 millimeters in diameter, but now they done changed it on me. But that's what y'all have ordered. You just tighten that down. You sandwich. It's pretty common just to make sure nothing bumps into each other, but this is the tightest that I could get it. But and these screws here, once again, are 440 screws, and you'll thread the larger ones down and the other ones up, and you can probably use the nylon screws. Alright, we're going to put the servos. These are 225 servos. These are what they call a Mighty Might. They should support skin. There are smaller servos, but they're 70, 80, probably around $70 a piece. These little holes on the side are for the grommets. They kind of want to bunch up against the inside of the skull. Just make sure you test your servo. Make sure the center, you'd have to put a Y cable and a reverser on there and make sure they mirror each other. Now, these servo horns are from China, and I never could find a thread. I think they're M2.5, but they wouldn't work, so I ground them out, drilled them out, and put M3 screws to attach the ear print part, and I just put them in place and tested, and as you see, it works great. And once again, you'll have these servos connected. You'll have 3 channels. You'll have a mouth, eyelids, and then the ears. And the ears have a Y cable with a reverser, and that works. And then as far as the gimbal, you have main part of the gimbal is the Servo City. That's the servo block. It'll be sandwiched with a 3D print, as you see here, to a hub, and the hub is connected with 6 32nd screws, and you just screw them down, connect that first before you put in the servos, and the servos will just be bolted in. I'd prefer little bolt screws, probably 6 32nd. And then your main rod, I told you to order. It just slides down. That rod needs to be cut to 100 millimeters, and it slides all the way down. And it will be a stop. And you just connect it to the U-joint, and these have a ball joint on the servo arm, but if you can't find the ball joint, you'll have to use the so-called ball links as you see here at the top. This rod here is a 440 rod. These a little bit more support, and you'll just connect it to the servo arm and connect it to those little 3D parts right there, and it works great. Just thread it with a 440 screw, and then these ear parts are just mainly for looks. I don't believe they would support skin, but I'm in the process of designing that part for the people that are wanting to put skin on, and I'll send those parts to you. They'll have a place for a rod that you can put in there, and then you put this lid on. This is the one with the pegs, and it'll just pop in place, and it works like a charm.
Well, I just wanted to show you that, video, instructional video on how I got the Grogu, up and running. But as you see the size comparison to the one we're working on here now, and I designed the Grogu probably a year and a half, maybe 2 years ago. But as you see here, like in that nose area, the two nuts, the space that I had to design it, being so close together, I mean, it was a challenge because, once again, it was something that was pre-existing, and I had to make something inside of that so-called measurement that we were all coming up with. But and I'm designing the alien, or this so-called 3D printed creature that we're doing, and once again it has to be according to a certain size, but that's the size of the build platform of the large resin printer. And but I mean, and plus on top of that is that the Grogu has 6 channels, and the the creature that we're making is going to have 10 channels, and we're going to have a lot more realistic movements. But you see the nuts there on that Grogu where the nose is. But I mean, that was a tight fit, but I have made tighter. And but I just wanted to show you this and show you the size comparison, and just show you other animatronics and these eyes right here are floating because the they're countersunk screws in the eyelids, and those eyes are floating straight ahead. Even though that the eyes are tilted at an angle, they're still aiming straight. So, but in these eyes on the creature we're making, they are beads. So that's a lot more easier for us to do, just having control eyelids like this, than having like the Grogu. But once again, I had to get a Grogu part in the skull lid. The skull piece had a magnet that I put to attach the skull to the other part of the skull, and it had a measurement. And since it's part of my library, I can go in there and just copy that socket, and I can move it to the side. And now when we make the skull lid to the creature that we're making, I can use that same socket, and so we can insert neodymium magnets in there so we can get it just to snap on and snap off. We'd like to thank everyone again. Thank you for the comments and the thumbs up and the shares. And y'all keep sharing and keep pressing that thumbs up. It helps the channel grow. And I appreciate y'all. But y'all have a good day. Later. Hello everyone. Hope y'all are doing well. This is 3D printed Animatronic Creature Part 12, Research and Design. I made some changes to the animatronic. Mainly what I did was this so-called eye socket. And this is what protects the linkage in the eyelids. Well, I felt like it was coming out too far. It was just starting to bother me. It's usually closer up to the eyelids, but the reason for that is I'm going to have silicone skin up here. And the other designs that I have, like the baby
monkey creature, and even the the Grogu's and the baby. The eyelid or the eye socket comes up really close up to the eyelids. Well, I want it to have kind of an eye bag there underneath that so-called eyelid, and then that way when it opens and closes, it will actually stretch that part, and it will be more flexible, and it'll look, you know, to me it should look cooler looking. And also, this will make the eye come out more instead of being so inserted or I kind of call it like a zombie look. I don't want that look. It's just that I want it to visually see on the profile. You'll see the side of the eye more instead of being all sunk in. But I think it's going to look good, and I was glad that I removed this part, and you'll see later. But basically, what I did was is I took a flat plane, and then I just did a slice cut with that plane. And then in the software, it's called intersect with faces. So it just basically it just joins them together and kind of makes its own calculation on what it should be like. And I'm trying to just make a flat cut. And the other thing that I made changes to is I was able to make the connection between the upper mouth and the eyelid to make a flat socket. And it's a flat socket to where I put a screw through that joining area. And that screw would be like a either a 440 imperial screw or either a 3mm screw. And the length of this screw should be about 12mm. But basically what I did first was I made a so-called kind of a design of the screw with a so-called countersunk area for a flathead screw to go in here. And then I'll probably make a socket of this nut also. But it just goes through here. But what I have to do is I have it already attached to the so-called uh, the eye socket. It would be, I moved it a little over so I would have more room to do this, so I could attach it here instead of closer to the mouth. It was in the way of the upper gum. And also what I'm doing here is I'm prepping all this and building all this up right here so I can put that organic sculpted mesh over this. Even though I'm editing all of this and adding all these spaces to this area here, when I add the mesh on top of it, I will, need to re-edit the inside and remove all that stuff that doesn't need to be in there. But what I did here is I made a flat socket on the eyelid and also on the mouth neck. As you see here on the red, on the bottom here is a flat surface, little area right here where I joined the two together and I inserted that screw in to, secure them in place. That's the connection point. But all this other area in front of this so-called square shaped area is going to be covered with a sculpted mesh. That way we can also connect it to the lower part of the eyelid and up here connected to the mouth area. But I need to cover this with a sculpted mesh, and then I'm going to divide it also. But once again, I just go into Blender, and what I do is I just highlight the whole creature head, make an STL file, export it to Blender, and then I take this so-called cylinder and I divide it into a quarter shape, and then I'll just add some more vertices to it, and then I'll start shaping it. But even though on the SketchUp video you saw me adding all those shapes to it and covering it, but I'm going to add this cover to it, but I had to have that to go by as a guide for me to make this covering so I could place it, you know, on this so-called, square shape area. And I don't really want that, in my design because, when the skin comes around, I want the skin to hold the skull. I don't want it to hold them square shapes because that's going to prevent any kind of stretching or, it's not going to have that movement that I'm wanting there. You can do this kind of modeling of the vertices in ZBrush also. Now, moving these things around in SketchUp, no, you can't. That's why I'm always going back and forth between different software. SketchUp is primarily CAD. It gets my basic shapes I need, and plus it has measurements. Now, Blender has measurements, and they've improved it somewhat, but I still don't care for it. It's not like SketchUp. But you see here, I'm just, uh, after you set up your mirror and you just start moving these vertices. Now, this so-called mesh is still considered low poly. And if you just put it in there in Blender sculpting, you can move these things around and then I'll come back and smooth it and I keep adjusting it and sink it in a little bit. And, you're just sculpting with it. And then if your vertex gets like inside of the design that I have, the STL file, you just come back with the so-called smooth brush and it'll pull it out. But I'm just getting a basic shape like I'm wanting and covering what it needs to be covered. Now I exported the mesh back into SketchUp, and what I'm going to have to do is I'm still going to have to edit the vertices to connect, the part to the upper and part to the lower as far as the eye mech and plus the mouth mech. And as you see here, I'm going to have to make another cut, but you'll see how I'm going to do this. But it worked out good. It's just time consuming. I mean, it might have took me 45 minutes if that. I mean, but as you see here, I have it, I've already removed the so-called component. Now it's, I can just edit. But yet, uh, the mouth mech is also, I've removed its component and now I can edit it also. But the eye mech or the eyelid mech is not, it's still in its component. So if I'm adding anything to it, I'm physically making the shapes to fit its vertices, but it's truly not connecting to the eye blink mech. But like, once again, this is where I wanted my new screw point. And I mean, it's coming along. And even though on this right here, on the mouth mech, I removed when I opened the so-called component up, or what they call exploded. When I exploded this, it removed the mirror. So I'm going to have to come back later and re-mirror. But this is just part of the designing and it flows really well. Now, like right here, I'm adding it to the so-called iMech and it's not been exploded yet. It's so-called component. So I'm physically going by its so-called vertices, but I'm having to create its vertices. So when I do release the so-called uh, component, it will join there. But when you do this a number of times, you get where it becomes a workflow. You start realizing that this is what it's gonna it's gonna be this way, and it flows good. But when you get into some weird shape and you're trying to make a socket, you got to get to the point to where you need to flatten it to make a socket because some of the shapes, I mean, you got to be careful where the shape can lock it up or not go down, or the so-called, you got to watch your tolerances. And as you see here, I've highlighted everything here. Now this is it in its own component. Now I'll just do any kind of cleanup if I have any so-called trash in there. But what I do is I copy this flat socket, and also that little angle is also part of the socket also. But I make a square and I'll put it back onto its original shape. Then also I do intersect with mesh, and then I'll connect these two all together again. Make sure that, because sometimes when you do intersect with mesh, it'll calculate it and leave some spaces. But right there, what I did was I copied it. I didn't want to remove none of that, not yet. But what I've done is I removed it now, but I made a copy of it first. So now I can come in here and do the cleanup. So then I can just join and remove the top part, as you see, and join this so-called flat plane to it, and then you'll see the results. So now what I'll do is I'm going to join these vertices and do all the extra cleanup, because sometimes it won't make that dark line appear until I make it connected, as you see here. Now it's connected, so now I can remove all this excess panel, and we have a new flat so-called socket, I call it. And now I'm going to take that where I've copied it, and now I'm going to transfer that copy back to the so-called blink mech, and you'll see how I'm going to do that by just doing the same thing, but it's going to be in reverse. It's going to be on the upper part, not the lower part. So since I copied it, now I'll remove the lower shape, and I'm just going to so-called clean up the upper part so I can make it join and create its socket according to the sculpted mesh. But it's still in its component stage right now. But now I'm going to bring it in to the eye blink mech, as you see here, and then I'm going to remove its component when I have it matched up to this plate. There's still editing to do. Like when it's a dark line right there, it's not set in place yet. So basically what I do is I find if there's an artifact or a mesh out of line or something's not fully connected to make that, contact, I have to go in there and make sure that nothing's missing, or I'll clean up this area here because needs to be removed anyway. But as you see here, I'll have like little hiccups here and there that I have to truly fix for this to actually achieve this. But a lot of it is that this is CAD, and I'm trying to do organic stuff in CAD, and that's kind of weird. You can do some, but I mean this thing right here is a 25 millimeter STL file, if you think about it, as one solid piece. But I have to, like I said before, that I changed windows into a cleaner window to kind of, because it gets kind of slow. And I have an i5, and it's a pretty good CPU, and it's working. But here's the flat plane or the flat socket, and this is how the two join together. Now I knew that I was going to have to remirror the mouth, so this is how I did the arch, upper arch on there. I just mirrored it. Now I have two sockets and two screw points and new cut on that. See that profile of the eye there? That's what I'm talking about. Now it'll give that rounded shape right there on the side of the eye, but you can see it here also compared to the one on the left is the old one, and then the right one is the new one. But when I do the profile, you can see how much more of the eyeball I will be seeing. But I'm happy with these results. And, some of this can be kind of you know, it can be work. But, you work your way through it and you'll be happy with the results. But here's a trick you can also do. So if you got a library and everything is basically a modular, but there's some things that you can do, like you can stretch things and you can also enlarge, you can tilt things. Now, as far as the eyeballs and things like that, you don't really need to stretch it because you're going to mess up the so-called shape of the ball and it needs to be a sphere. But you can rotate it and you can also angle it and then you can duplicate it and you can enlarge it and shrink it down to any size you want. But as you see here, I just changed the angle and made a different, cat eye look. And then even though my design has circles in it, all that can be changed. Even the servos are messed up now, but you need to change it and remove them and put in the correct servo sockets. You can also, change the shape of your teeth, and you can just build up a so-called platform on what you're wanting to design as far as any kind of animatronic creature. I mean, you just, really the sky's the limit because you can kind of make all kind of neat shapes with this. But I mean, you're still going to have to change like the servos and put in the right size servos, the right size so-called servo socket. My birthday was Saturday, and some of y'all contacted me, wished me a happy birthday. Thank you very much. Very kind of y'all. And I appreciate all the new subscribers and the comments and thumbs up. I'm glad that we all have an interest in animatronics. Hey, I once again appreciate y'all. Y'all have a great day. Hope this helps. Later.
Hello everyone, this is 3D Printed Creature Part 13. I hope you're all doing well. I've been doing skull work on this animatronic and just a lot more designing. This piece here is the mouth part, or mouth cover that covers those forks as the lip mechanism. But this will allow the lip mechanism to go underneath that so-called mouth cover. There's a lot of design work in an animatronic. It's like making a clock or making anything, matter of fact. It has to be designed. But mainly here is that I'd have something for the silicone to attach to and not just be open there. But this mouthpiece right here, I just kind of connected all the pieces together just to get this one solid form. And then after I had this form made, I wanted to put a more smoother cover for the silicone to slide when it stretches. So I exported this STL part into Blender and made a cover. That way it would look more like a skull. When I got that lip cover, so what I did was I connected the so-called eyelid nut area. I made a little cavity there for me to be able to put the tool in. Plus, I made the stops for the skull. I had to also design another mesh that would flow underneath this so-called mouth cover and join into that mouth plate. The nut socket area has a stop on the top, and also I made stops or a flat area on these other side of the eyelids. This way I can have a placement key for the so-called skull lid. This is the first concept of the skull I did. Being low poly on this so-called skull lid, I needed to make a higher resolution, so I put it into Blender and did a subsurface modifier. You know, when modeling like CAD, it's usually squares, but when you're sculpting, everything's turned into triangles. So in the Blender sub modifier, it turned a lot of these things into like hexagon patterns. So I exported it into ZBrush and did also a Z remesher, and then it cleaned it up a lot. Even though it's still triangles, it just makes it so much smoother. And on that main plate, as far as what has the eyes, there's this so-called border that I've designed. It's mainly flat area, and this border is going to be the so-called thickness of the skull. And these stop plates are going to be keys for the skull to lay upon when I have everything designed for the skull itself. But I make adjustments to this new so-called skull piece, make flat cuts and just kind of get everything prepped for me to lay it to this border. There's areas in this where the lid goes down. I gotta just make sure I have clearance and tolerances correct so that way it will fit correctly. But the border and the key stops are all measured to so-called, like this extrusion here is part of the shell. And when I get all this put together, as you see here, I will reduce the skull again and fit it back inside the skull to produce the shell. There's a lot of back and forth going, you know, to Blender and to ZBrush, and it's just back and forth. You know, mainly I go into Blender just to manipulate. Like now I need to move this so-called new skull piece, and now I'm going to form it to that so-called eye socket border. And that eye socket border was that ring, or you know, above the eye, and it's already a so-called shell piece already, and I will connect that inside to the lower part of that so-called ring. But once again, a lot of this is subject to change. You know, it just all depends on how I want it to look. But also I got to keep the inside thickness correct, because I just don't want anything bumping. And plus I also need room so I can attach the so-called magnets to the inside, and then they will be able to attach to that so-called scaffold. There's a lot of work to do on this skull lid. Not only to make it into a shell, I got to make some space cuts where the brows go, and that's the one above the eye, and also the forehead area right there in the center for its center brow. So I'm just going to check the stops to see if they match, and all I do is I just place it right there on top of that other stop. I did the lip cover, and it's being mounted to the so-called eyelid nut space area, and then I also did adjustments to this mouth plate. When I release the so-called mirror, there will be like 5 main pieces. That way it'll be less to print, but they're going to be the primary pieces of this animatronic. You will have the skull, you will have the scalpel, you will have the eyelid socket, and you will have the mouth, and then the jaw. Well, it's starting to look like a creature skull. Now you'll see me demonstrate how these so-called lip hinges will go underneath that lip cover. This video is 3D printed creature part 13, and this has been 3 weeks in making this. This is how far I've gotten. Now I'm going to start getting ready to do some test prints and see how everything is lining up. But I appreciate all my subscribers and the new ones. Hit that thumbs up button. It helps my channel. And please share this, and let's get everybody involved in animatronics. I'm going to add another servo to this, so we're going to probably have 12 servos in all. But once again, I thank everybody, and once again, thumbs up, comment, share. Appreciate y'all. Later. Hello everyone. This is 3D Printed Creature, Part 14, Skull Work and Cleanup. Well, I did a little bit more design work on the skull, but I had to kind of start cleaning up all these other parts. And as far as this part here, the scalpel, I inserted that yellow part right there is where the magnet goes. And there'll be opposing magnets onto the inside of the skull. Added some support to some of these servo sockets. I mean, they need to be strong, and you know, if it's PLA, you got to kind of be careful, because if you have a lot of torque on a servo, it'll snap it. In the title, I say cleanup. It's just prepping everything to get ready to print. But you know, you foresee in the design there's certain things that you need before, as far as in this animatronic, you know, like screw holes. Got to go inside the mesh to make sure there's no artifacts in there, and you just clean it up. And then you'll see me change the color to this mesh. And when I do that, that means it's pretty clean. It's ready to print. But you know, you just finalize everything, and then I'll just change that color, and then I can start printing. But once again, I just keep checking and double checking, just make sure that I don't have forgotten anything, like screw holes or a place for wires. In this scalpel part right here, I'm adding another servo socket, and I had to add this last because the other part is mirrored. As far as connecting everything together, I've made screw holes throughout these. There's like 3 levels. There's the scalpel, the main plate where the eyelids go, and there's the bottom plate, and that's the upper part of the teeth where it goes, the mouth part. So I have, if you see all these holes here, they all match up to that so-called middle level, and then you got the top level. But here I'm making an area to where I can put the servo lead wires to go through that plate. And you know, these are the things you just don't want to forget, because they'll be dangling from the side. You got to have them where I'm trying to hide all these wires underneath this so-called head. The eyelid mech has 9 screw points, and it's matched to the so-called mouth mech plate. It has 9 also. The scalpel only has 6. But you can see here where I'm making a pathway for those wires, so that way I can bypass any kind of threading through anything. Now sometimes you might have to do that, especially if it's a larger animatronic. But there's a lot of double check, triple check, make sure everything's right before you even want to print it. But like right here, I have to add some push-pull tabs, and this is going to be for the gimbal, for the head to tilt forward, back, up, down, left, right, and it's just 2 little tabs, and I just mirror them and get them all set and ready with a screw point in there for the servo horn. You know, I had done some work on the skull, and I'll show you all that later. But here I wanted to add a mesh to the so-called jaw, and I'm mainly trying to hide that lip mechanism, kind of hide it to where it's like coming out of the so-called jaw itself. But to do that, I just went into Blender and kind of shaped a chin and divided it through the center where the so-called lower lip mechanism is moving. Its sort of pathway also. 3D printed animatronic creature part 1 was made December 15th, 2023, and it's 2 days, and it will be a month, I guess you would call it. So it takes time to make an animatronic, and I just want to appreciate every one of y'all. Thank you for the support. Thank you for the thumbs up and also the comments. I have servos coming. I'm waiting, and also little parts here and there come on their way now. But I'm gonna start printing all these pieces. I still got to design all the linkages and print like eyelids and things, but it's coming along. But as you see here, I wanted to change the skull shape, and I would really like to know what do y'all think. But as you see here, all my clearances. Now, this is not a shell yet, and that's later. But I'll have plenty of room to put a shell in this. But I'm just trying to see if I can kind of change the so-called shape. When you look at this thing head on, it's too square to me. It just looks kind of, I don't know, even though it is an alien creature. But, but I made two different versions of it, so I wanted y'all's opinion. The forehead has by the eyelids has a stop, and I designed this little loop stand that this is going to be a stop. This will be connected to the skull itself, as you see here, and there's going to be a space created there for the center brow. But it will once again be attached to the so-called skull itself, and there's no screws. It's just something for it to rest on, because the magnets is going to be attaching the so-called skull to the animatronic itself. Also, there's going to be some more cutouts above the eyelids for the brows, the left-right brows. So I got to get that ready after I make the shell inside of the skull itself. So which shape do y'all like? The square shape or the round shape? Hey, thanks a lot, everyone. Thanks for the likes, comments, shares, thumbs up. I'm going to get some of these things printed. Once again, y'all have a great day. Later. Hello, everyone. Hope y'all are doing well. This is 3D Printed Creature Part 15. Once again, thank you for all the new subscribers, thumbs up, comments. We're almost at 8,000 subscribers now. So let's get started. Here I'm designing this, I guess the biggest piece of the whole animatronic is a skull cover or skull lid. And here I'm placing these red pieces here. These are the magnet sockets, and the other pieces are stops. And the stops mainly is when the magnet pulls it down to the so-called scaffold, it will, have a rest area. On making this skull lid or skull top, I took that border that I created pretty much at the very beginning of this series, and I extruded it so I could get clearance, just to make sure that I had clearance. And in the other video, you saw me copying a mesh and reducing it, kind of giving it a rounder, I guess, inside. But this way I could really truly see my clearances. And plus, these red pieces that I'm going to have to embed inside the skull. As you notice that I document pretty much everything. And I'm just showing y'all the whole process of what does it take to make it. And some of y'all actually want to make your own animatronic. I mean, from from scratch and design your own creature yourself, and just to show you just different options on how to do it and hope it helps develop your own animatronic. Here it's just kind of like lining up things. I'm just trying to, and this is at 8 times the speed, I believe it is. But as you see here, I mean, I can go through this mesh a little bit, but the thickness of this is maybe around 3 to 5 millimeters thickness as far as the shell thickness. Making this skull shell this way, I'm actually inside the mesh itself. So I'm doing, you know, inside mesh and intersect these so-called pieces, these stop pieces, and the magnet sockets. And they have to be joined on the inside of this shell of the skull. So I guess technically I'm doing the inside of the shell right now. So I get this inside mesh where I like it. So now I mirror it, and I just want to make an entire head STL file, so I'll be able to do the front part of this as a mesh, a sculpted mesh, and this will be the inside steel of the skull. So I imported this STL file into Blender, so I'd have something to go by to do this so-called front part of the mesh. And this needs to be kind of sculpted because I'm trying to go around or have some kind of space area where the brows are going to be moving. And all this will be adjusted here in the sculpting area. Just get some kind of a clearance a little bit. But you'll see this whole process later. But I'm just kind of giving it a skull form and kind of connected, matching it to the extruded edge that I created earlier. So I just match this whole thing to the edge of those rings around the eyelids. So I just bring up that edge of that sculpted part right up to it, so I can, make the whole thing flow into one piece is basically what I'm doing. And like this center stop right here, it's the stop for the skull plus it's a space for the center brow. There is quite a few pieces just to do the inside of this skull shell. So I exported this piece, this piece alone, into SketchUp. Now I have the piece inside SketchUp. Now there's some things I just don't want no overhangs where I generate any kind of I guess, a weird look to it. So now this is editing vertices, and I'm just pretty much connecting the dots. And if it's not a dot there, I'm going to make one. So it's just make sure I have a connection and kind of fill in the gap. But here you'll see me in some of the areas. I'll stop and I'll move into another area because I need to pull it back up as far as see what I'm connecting to, like the whole skull. Like this piece right here, I have to estimate or pretty much guess
on how I want this to flow, but I can't do anything on the other side of this because that's the stop. And even though that I moved that stop away a half a millimeter, that's my tolerances for clearance to this so-called part of the, I guess this area here would be the cheekbone. And as you see here, I'm doing this in reverse faces. So this is technically, once again, the inside of the shell. But as you see here, I moved the brows up, and I'm thinking, well, it shouldn't go no further than that. So I want to make sure that I have an area that it's not protruding out of, where I made this so-called sculpted mesh in this front area where the brow is. Just make sure I have, coverage of that piece. There's a lot of steps to doing a shell cover, and I have to just make sure that everything has clearances. And plus, on top of that, the shell has to have a thickness. And the thickness I'm going for is, like, once again, 3 to 5 millimeters thickness. And and then the other video, y'all seen the so-called shape of the skull that I was liking, kind of a more rounded look. Well, I'm going to pop that mesh in here now to where you can kind of see the so-called shape and what I need to do by bringing this back into Blender and manipulate it around this inside shell cover. So once again, back into Blender, and I pretty much just did another STL file of the whole head as an inside shell mesh, and now I'm just gonna do a mirror. But this is just the workflow I'm doing here, just covering that inside mesh. But you notice that I'm also giving it thickness, and that's the thickness of the shell. I can't go too close to it because it will make the shell too thin, but it's basically around 3 to 5 millimeters as far as thickness of the shell itself. I just model this mesh to the outside border. That way it'll generate the shell. So now, since the outside mesh is pretty much formed the way I like it, and now I'll export it back into SketchUp. And as you see here, you can see the thickness on this profile angle here to how much room I have. And now I have to connect these stops in the magnet socket and the center brow stop. That way I can make everything into one piece. Now I'm going through with the extrusions of the stops and the magnet sockets and attaching them to the inside of this mesh here for the shell cover. And I basically still do one side. That way I can just mirror it. That way it'll save time. But I'll just do intersect with mesh, and that way it'll join it to this mesh itself. And then I have to go inside and remove all this. And basically I'm working inside the shell right now, removing all these, artifacts, I call them. I mean, we can't have it in a 3D print because it won't print. It'll show up as error. It has to be watertight. I just try to keep everything centered that way when it mirrors, it don't overlap. And then also this brow stop right here, I'll divide it and make its own mirror also. So I'm going to start joining these pieces, but I'll remove some of these
some of these vertices away from the mesh I'm connecting to, because I want kind of a smooth transition. And even though that this ring is, I guess, a solid piece, I want to connect it, but the way I'm connecting it, I'm going to have to remove some of the outs. I'm just using the outside of it, you know. So I'm going to connect these vertices to this ring, and then I'll remove what I don't want, and because that way I don't have to re-edit, you know, put it in. I use NetFab to do a lot of my checks to make sure that I don't have any artifacts I miss, and that way I can have a clean print. I notice when I do, you know, 8 times the speed, it might get kind of jumpy, and but you know, if you was to see it, you know, it's several hours. Like I said earlier, it's probably 2 hours of work, and I'm only showing y'all maybe a 20-minute process of it. Well, the rest of it's just mainly connecting the vertices to the inner and outer edge of these stops, and connecting the border, just make it into a shell. Here, as you see that now it's time to uh, release its component so I can see here what I truly want to model. Being out of its component, I can model on top of the so-called rest of the skull. That way I can, like if you see here, I had to make sure that eye ring was kind of no sharp edge there. Now I've just mirrored it, and now I'll just fill in the mirror, and it will be a complete shell. Now the shell is pretty much complete, but there's one other thing that I have to do is make space where the brows will be moving up and down as far as the left-right brow. That way it'll have clearance, no bumping. So I'm gonna make this fork kind of a extrusion to where I do a intersect with mesh. So I guess it's a shape cut. That way I can just kind of remove this hole above the eye area. And I was designing this, and noticed that my brow, which is just a moving object, it was I was getting a wrong look, and noticed that there was a measurement off, and the brow mechanism itself was like a half a millimeter off. So I just adjusted it. As you see here, I'm trying to find center of this so-called piece right here, and I find center, and I notice that I am off, you know, a little bit more than half a millimeter. I mean, the eyebrows are only going to go up so far, so there's really no point to going too far up and just having a hole there, because when there's going to be a hole there, you know, that the silicone will lay there, and I don't want it to have a strange look, but it could also make a pretty interesting look also. So I just extrude this one piece right here, and I mirror it, and then that way I can do a intersect with mesh, and we'll remove this whole socket area for the brows to move up and down.
A lot of times when I do intersect with mesh, it'll remove some of the mesh itself, and I have to go in there and edit. But like right here, I'll just remove what is inside that border area and just delete most of it, and anything that's missing, I just add back. But it's turned out well, and make sure that I reverse any of the faces, and but this is the skull lid cover shell, and it turned out well. So I started doing some test prints, and I have a new printer, and I'm just kind of getting used to it. That way I can see what if it matches my tolerances and things like that. Because sometimes you got to kind of tweak your printer a little bit. But I'm happy with the printer. It's working really well. And as you see here, here's the shell cover, and I printed all this stuff mainly last night, and but this is the size of the skull, and this is what I have. Uh, it's turned out well. Hope y'all like. Hey, I appreciate the thumbs up. Appreciate all the subscribers. Hey, share if you can. Helps the channel. Thumbs up. And any questions y'all ask. But I appreciate y'all. Thanks a lot. Y'all have a good day. Later.
Hello, everyone. We're almost at 8,000 subscribers. I'd like to thank everybody. Appreciate that. This is part 16 of 3D Printed Creature, part 16. So, you might notice my voice is a little different. I've had the flu and cold and high fever, and also we've had a severe winter storm and ice storm in the south. So when we have that here, everything's shut down, even doctor's offices are. So I've been dealing with that, and I've been trying my best to get back into this creature, and I'll show you what I've done. Now what I'm doing is I'm making linkages and the final adjustments to the lips, and you see me adding these little extensions to the front tips, and what that's going to be for is when the core is made, those parts will be visible, and then that would be a socket for when it's made into the silicone skin, and that will pop in place and hold better. Even though I'll probably use some silicone adhesive also, but that way it'll lock in on that lip. So what I usually do here is I'll just copy that one side and just mirror it, add it to the other side, and then I'll go inside here and I'll clean up any other artifacts that will show up as an error if you don't clean them up. And that's what I've been doing a lot for the past few days. When I'm glad our electricity didn't go out, but I was able to finish up all these prints. When I'm designing these linkages, like if you notice that this fork is at an angle to where it's up, and this would be considered fully extended, and you'll see me later move the servo arm back to indicate that it's being pulled back. So I have to adjust that servo arm in the back position. But as you see here, I just pretty much copy another linkage, and that way I'll just remove its component, and then I can just manipulate this same piece
by stretching it or, just making it the size that I need. And I think in my previous, it might have been 2 videos back where I actually did the linkage arm for the single upper lip and the middle one there. So it's already been kind of designed. I just had to finish it up. But as you see here, I moved that arm, and now I'm just adjusting it because technically the way this fork lip is up, it's open fully. Now we'll need to make adjustments to the servo when we have it loaded up in the servo controller as far as the stop. When we open and close the so-called lips, uh, we'll understand how much degree of the servo arm we can create a stop to where it don't overextend it and break something. And also that even though I haven't mounted to the end of each arm, it doesn't mean that I can make adjustments also that to make those arms shorter. But it's just part of it, and this is the planning. And for the ones that are new to this, the best way to set this up, everybody would need a radio, an RC radio, and and I've showed pictures on the so-called community that you can see some of the radios may recommend, you know, on what to get because when we set up these servos, you know, I use an RC radio just to set up all my servo movements before I put it on to a servo controller. And some of these arms, I'm trying to get it maybe 2.5, 3 millimeters thickness. I want something a little stronger. You know, this is PLA, but like if you see here on this, this is the jaw movement servo, and I pull all these out in floating space. They're accurate to what I have already. That way I can just get rid of all the other stuff. I can do it by just doing another component on there. But after you get like 35 megs of information on a CAD program, it gets kind of iffy, as far as, with my computer it does. But if you see here, I'm kind of lined up to where I'm going to do this, where I'm going to add a so-called standoff, and that way I can stretch it to meet the so-called servo arm, and that will be mounted on the inside of the servo arm. If you notice that some of these are blue color or purple, these are the ones that I've checked to where made sure that they're error free and they're ready to print. And then what I do is I check all the other ones in NetFab, and they'll tell me if they have errors. Then I have to go in there and individually fix them so they'll be able to print. So as you see here, all of these are ready to print. Now this is 24 parts, and this is for the head itself. Now I have 2 more things I'm wanting to design, and that's a servo socket and these servo horns that I'm making longer to where I'm actually making a servo horn for a servo. That way it will be extended length so we can make this head move up higher. And this is the round servo horn that it's going to be replaced. Now this arm right here is not going to be long enough to make the head go up high enough for, to look up or look down. It's not going to be high enough. So I'm going to adjust this to where I'm going to make this so-called servo arm longer by taking this round servo horn and we're going to make an inlay to where that will fit in there, and it will be uh, secured with two, probably I'm shooting for 3 millimeter screws. So they'll go through that and hold it in place. Now this servo socket area, and this is the thing that I'm working out on, because this is going to have to rotate with the head. So when the head turns left and right, this will also move left, right. So that means anything like the chest piece, all this needs to be clear. So we needed to make adjustments because these servos are bigger than the so-called wing servos. But as you see here, I pulled it back, but if I pulled it forward, it's going to rotate like so. But the other dilemma is when it tilts up, it's going to be great. But when it tilts down, it could bump the jaw, or the jaw couldn't open because those arms are in the way. Or the linkage would be in the way. But I'm shooting to put them in the back, but I'm happy with this, and it's going to keep the cost down because as far as the servos, I mean, these are like $11 servos, where the other ones are on up there like $30 a piece. But as you see here, here's the prints. But the only thing on my new printer, now this is a new printer that I'm using. I got all the prints done, but my whole design was 3.2 millimeters. But when I put a 3 millimeter screw in there, it should go through. According to my older printer, it worked great. But now these are like trying to tweak the so-called profile. But I'm just still kind of tinkering with this new printer, and it works great. But I'm over quality over speed. But once again, thanks everybody. I hope y'all enjoy this content. Thank you for the thumbs up. Thank you for the likes and the comments. Please share. Thanks a lot. Y'all have a good day. Later.
Hello, everyone. Hope y'all are doing well. Pardon, but I still have a cold. We are about 30 subscribers away from 8,000. Appreciate that. Hope y'all are doing well. This is 3D Printed Creature, Part 17, Building the Blink Mech. We're going to start building this animatronic. Building this animatronic, I would say the hardest part would be building the blink mech. And when I say being hard to do, it's just small linkages and setting up two servos on one channel. And these two servos are mirrored, so we're going to have to use a Y cable and a reverser. Having a new printer, I'm having to drill out these holes. They're a little on the small side, but I'm placing 3 millimeter screws in these holes here, and 2 millimeters for the servo sockets. And in the world of 3D printing, when we have a new printer, we're always searching for the right profile. This eye plate was probably the main piece. This is what I originally started designing the eyelids and eyes. These are the servos that we're going to be using for this animatronic. Now these what they call JX servos, and this is a PDI 1109 MG. MG stands for Metal Gear. Now they got pretty good torque, and it's usually I believe it's 2.5 kg, and that's pretty strong for this little servo. And this servo comes with an assortment of servo horns and some mounting screws and a main screw to screw the servo horn in place. The eyes on this animatronic are black beads. And I started using beads a long time ago because, black, there's a lot of animals and creatures that have black eyes. So I just developed some eyelids around it and printed them. Next thing you know it, I have a blink mech with some black eyes. But these beads come in different sizes. I've seen them as small as
6 millimeters and they go all the way up to 30 millimeters. Now this one here is a 22 millimeter. Well, I'm just trying to make sure that everything is going to be available for my Patreons when I have it set up. But you can see some of these size of these beads. And if you really want to get into animatronics, order you some of these beads and just start tinkering around with them. And I'll probably have some eyelids available as far as SDL files. And when you get a set of eyelids, you can enlarge it or shrink it down to the size you need to fit that bead. A servo has a rotational shaft. It's like a motor and there's a gearbox. In the gearbox are metal gears. Well, they need to be mounted aiming towards the back of the eye. That way it makes the linkage smaller. You will probably see me post this picture here a few times in this video. It's just a demonstration of like an instructional guide on how everything should be placed as far as the linkage and even the direction of the servos. Also for this animatronic I purchased a set of screws which are 2, 3, and 4 millimeters, and they also come with nuts and lock washers and washers. Also, I'm using threaded rods, and there's some 2 millimeter rods and 3 millimeter rods I'll be using. But you know, it's just, this is the building part, and I kind of designed, and some of the holes that I made in the design were for certain size rods. So I'm placing these small 2 millimeter screws with nuts in the servo socket to lock the servo in place. I have some of those nylon lock nuts coming, but they're not arrived yet. But I would put these regular nuts on there first because, once again, I may have to take things apart. But overall, everything is basically is putting it together like a model airplane or a model car. Now it's time to install the eyelids and the eyeball. Now, as far as the eyelids, there's a top eyelid and there's a bottom eyelid. And the top one kind of covers the lower eyelid. And I'm talking about the eyelet, or where the hinge mechanism goes. As you see here, you will see the ends where it's actually covering the lower eyelid. I don't like supports because they kind of mess up the finish of a 3D print, but we have to have them, and sometimes you just have to do it. But once again, it's probably a big difference between a $250 printer and a $1,000 printer. Now, I've done this process a lot. In designing these animatronics, I've come across, and sometimes they can be tedious. Now, this is the tedious part. Now, when I slide this rod out, it's going to be, I'm holding it in place. So I got to thread this rod through the support and then through the two eyelets right there, and then go through the ball and then through the other side. Now this is part of it, but it will work, and it's just tedious. Now this is the hardest part of the whole animatronic. But the one thing is that sometimes that black bead, you can't see the hole that's in the bead, and there's a 2 millimeter hole that you're having to go through, and that's why I use that first rod as a guide, and that helps me pass it straight through. Once again, more likely it's going to slip, or you'll bump it and it'll all come apart and you have to start over, but eventually you'll get it. Now, this threaded rod is a 256, and that is a 256 nylon lock nut. So, I mean, I'm going to have all these so-called listed in the Patreon on, you know, what parts and hardware, just listing everything. But you just have to keep spinning it. And that lock nut is also just there to hold everything in place. I have some more coming, and being so small, some of them are kind of hard to find. But you know, um, I I think I found these on Amazon. But once again, I'm trying to make everything uh, metric instead of having two different, like imperial and metric. And you know, I'm in a small town in Louisiana, and metric is kind of rare. I mean, you can find them in the big box hardware stores, but you know, it's still imperial, but I really prefer metric. And here's a perfect example of what I'm talking about. You'll get it just right there, and it'll fall apart. Try again, and eventually you'll get it. And then it's time to set up the servos. And this is the importance of having an RC radio and doing any kind of animatronic. And most animatronics in the movie industry is using radios. And they call them puppeteers because they have as many as up, up to 6, 7 people working radios. But here's the receiver, and this is, you have 7 slots, but it's a 6-channel receiver. And one of the channels is for the power, and that's the battery. And then this wire here is an on-off switch, and it goes to that 7th channel, which is just for power. And then you just plug up the battery, and it's on the off position. And when you turn on a radio, you turn on the radio unit first, and then you turn on the receiver. And then to shut down, you turn off the receiver first and then the radio. But with advancements of radios, they kind of give you warnings or alarms telling you, are you sure you want to do that? But in the old RC radios, before all the digital stuff came out, if you turned off the radio, your servos would go crazy, and they would actually even break some of your linkages. But I want to help everybody because some people have no what to do. They want to build animatronics and just don't know how to get into it. So I'm just trying to help everyone on how to learn this, and most of y'all probably know how to do this. But as far as setting up the servo itself, I'm going to plug in one of the servos, and I'm going to power up my radio and turn on the receiver with a servo plugged into the number 1 channel. And when I turn it on, that arm will move. And sometimes it won't move, but it just moved barely here. But this is called centering the servo because the servo has a center. It moves left and right or up and down, but it's a rotational. And when you turn that power on, it's automatically going to go to center. There's a few servo horns in the package that they give you, and it's usually a single long servo arm, and it has anywhere from 3 to 4 holes in it. Well, I go to the second from the top hole, and I drill a 2 millimeter hole there for my so-called screw. and I do a hole in the other servo horn also. You have a linkage for each eyelid. The top eyelid is shorter linkage than the lower, and they're all joined at that screw point on the servo arm. So by looking at my design, I laid the top servo linkage on top of the servo arm, and then the lower linkage to the eyelid laid on the back of the servo arm. Then I placed a screw through all three: the top linkage, the servo arm, and then the lower linkage. And this is all for the servo arm. So now I connect the lower linkage to the lower eyelid with a 2mm screw and nut. And to help this process, I'll take some glue stick and I'll put it on the end of my instrument like a flathead screwdriver, and I'll hold that nut in place. I will also apply some glue stick glue to the threads. This way it will prevent the nut from backing out. Then I repeat the process with the upper linkage. Connect the upper linkage to the upper eyelid with a 2mm screw and secure it with a nut. But I've used all kind of stats and tweezers and all kind, but most time it's just a flathead screwdriver with a little glue on the end of it to help me support it while I get the nut threaded. Like I said before, this is the tedious part of building this animatronic. And anything with eyelids, it's going to be tedious like this because it's going to be very small parts. After I connect both linkages to the eyelids, then I can connect the servo horn to the servo. I turn on the radio and I turn on the receiver and I do the first test movement. And if there's any adjustments, if it's not closing all the way or it's too tight, I can move the servo arm in a different location onto that rotating shaft. And as you see here, we have one eyelid blinking. And now it's time to repeat the process for the other eye. After getting the linkage set up for this other eye and eyelids, what I have to do is set up a single channel for two servos, even though the servos are mirrored, just to demonstrate with this another horn that I'm using, as you see here. When I have a Y cable on one channel and I'm going to make it rotate the eyelid, you'll see the other servo horn going the opposite way. And to fix this motion, we need to add a servo reverser to this servo. Now, since we have the motion corrected, now we can connect the servo arm that has connected to the eyelids. We can connect the horn to the shaft, and now we can get both eyelids blinking. We have two mirrored servos connected to one channel with a reverser and a Y cable to produce this blink.
We should be able to put this thing together quick. So what do y'all think? Well, hey, I appreciate y'all. Thanks a lot. Thanks for the shares and comments, likes, and the new subscribers. Y'all have a great day. Later. Hello, everyone. I hope y'all are doing well. Sorry, but I'm still under the weather. My voice is a little messed up, so bear with me. But this is 3D Printed Creature, Part 18, Building. Hey, 8,000 subscribers. That's great. Appreciate everyone. Thank y'all. Let's get started in building this thing. As you see here, I'm just doing it at 4 times the speed. I'm using some glue stick method to kind of keep the nuts from backing out and setting up all the linkages. You know, I designed this thing probably started a month ago or so, and I got it built. So it's kind of an achievement, and I'm happy with the results. And as you see here, I'm putting on the linkage to the jaw, and I'm working out my linkages were all correct. You know, I would flip some because I have that bow and that curve. You don't really want to go straight linkage or a straight line because you don't want to have what I call a backlash. But everything is just pretty much set up at one linkage, hook it up to the radio, and do a test movement, see how I like it. Because a lot of them, some of these like servos, you know, the servos do have a set screw where you'll set that arm in place and it's set to that degree. And then, you know, once you get it finalized, it would be time to set that screw in place so it won't never come off as far as the servo horn. But in designing this whole animatronic, this was one of the main keys that determined the size of the animatronic. Because usually when you have a lower lip, you know, I usually do it with like a cable or something, and I'm just trying to bypass that cable, and it's kind of bypass that kind of procedure, and just do a straight hard linkage, and that would mean I would have to connect the mechanism to the jaw itself, which is the servo, and and I could only be so small with the jaw because of the size of the servo. But as you see here, I designed this whole thing to have kind of a modular, you know, design to it to where I have a mouth mech, a blink mech, and a brow mech. And then I'll just tie them all together into one. I'm happy with this design. I have everything moving. I have 2 brows. I have 2 upper lips, 1 bottom lip, jaw, and eyelids. And everything seems to be working pretty good. It's just doing the final, you know, little tinkering and setting things up. I did print some things for the gimbal, and that's coming later. I'm just trying to get everything kind of set up. I kind of want to glue the teeth in, but just glue them with some glue sticks, something not permanent, so I can, put really good teeth in there. But here's me setting up the so-called scalpel in there, and it's, it fits well. And then also, you'll see later where I didn't film me putting the magnets in place, but everything's screwed in properly. You know, all my screws were measured correctly, and it's worked out really well. I mean, there's some tight squeezes, to where I have to use stats to put screws in place. But these are some tiny screws. M3, they're M3s and M2s is what I've been using. And then I was using some M3 rods and some 256 because I didn't have any 2mm rods. But basically, it would be the same. The only con that I have about this project is the 3D prints. My designs were accurate,
It's just that when it's a new printer and it's printing my supports in some of the holes that I've designed, and the supports are filling, the hole. I understand that, but a lot of the support's supposed to pop out, but it seemed like a lot of these supports were fused in my holes, and I had to drill them out. But once again, I'm more about quality. If I design something in a certain measurement, I want it to print that way, and I don't really care about how long it takes. I don't care about color. I just want my print to be correct. Just made sure all my wire management just went all the way straight through to the next level. Did a lid test. It it turned out really well, and once again, I want to probably secure these teeth in place so we can get some really movements with the jaw and everything. But everything, once again, is moving, and everything's just, the design turned out well, and I'll show you here where I'll set up some of the blink mechanism. But like right here, I have to make sure, and that's something about setting all this stuff up. You must always center your servos without the arms on, but as soon as you get that, you know, set, you're okay. Now, there was one time that I almost turned on the radio with my arm already in place before testing, and I stopped myself and pulled it, and it would have broke something. So I was glad that I caught that. Also, when I was setting up the mouth neck part of this, you know, I mounted the two servos on the bottom plate up backwards, and I had to stop myself there and you know, uh, unscrew all those four screws and flip them back, because you see it as one way in the design, but it's when you're doing it upside down as a flat plane, you're thinking, well, it goes this way. Well, I I didn't catch it until later, and I had to replace those servos in the right position. But here it is blinking, and here is the testing of the lid. But it really works well. Here's the brow movement. I was happy with the results there also. Now this is with just the RC radio. As you see here, I'll demonstrate how I'm testing these things. And this is just like, I believe it's three channels. And I have, the blink neck, and then I have the outer brow, and then I have the lower brow. And it works well, and then the blink neck is just on one channel. So that's three channels in all. But this is the best way to test. Well, gimbal works next. So, hey, appreciate y'all. What do y'all think? Thank y'all for all the new subscribers, thumbs up, and the comments. I hope y'all have a great day, y'all, and thanks a lot. Later. Hello, everyone. Hope y'all are doing well. This is 3D printed Animatronic Creature Part 19. Just wanted to show you, make a little short video, show you some movements y'all have not seen yet, doing some gimbal work, and just trying to show some movements and just check things out. I'm going to have to make some adjustments to my jaw linkage so I won't get a backlash. But as you see here, I got the lower lip moving, and also I have the jaw movement. Now I just stuck the teeth in there with some glue stick, just something, just a temporary type of, lockdown on them teeth for right now. But this is some of the movements here, and I also did the movements on the upper lip also. But everything overall seems to be working pretty good. Just some minor adjustments, little tweaking here and there, but this is just part of it. But as you see here, I got the upper lips moving, and it's working well. There's not really a whole lot of clearance it's going to have to do as far as the gum line is. It's just the gums, and with a closed mouth, the lips should meet. And that was one of the other goals I wanted to achieve. So when the mouth may be a little open, I can still close the lips somewhat. But this test movement right here, you'll see how far I'm going down to the edge of the teeth, and that way the lips should be touching, and that's what I'm wanting to get. And also the lower lip does the same thing. It goes to the top of the lower teeth. You might have remembered that this video segment right here is from part 6, when I was first designing and kind of doing a sketch of a so-called gimbal. And most of these parts are coming from Servo City. Now, I don't have all the parts, but I can get it to do the tilting and looking up and looking down. But this is what I have so far. I still need another rotational servo for the bottom of this, so the so-called head can turn left and right. Now, I do have some type of limitations that I'm trying to work out, because this whole apparatus is supposed to be turning, and when it turns, it's going to be turning inside the so-called chest cavity. So I need to just make sure that I can have clearance for all these objects, like these servo horns and things like that. Those will rotate. This whole shaft and the servos and the head will rotate together, with the bottom servo on the bottom for rotation, and that's to look left and right. But as you see here, I'm setting up these servos. Now, these are the same servos that I have in the head. And once again, these servos are low cost, and they have pretty decent torque. Now, we also got to calculate that I'm going to have skin on top of this animatronic, and we got to make sure that it's going to be able to lift it. So I'm going to place this animatronic in this vise right here, just give it some kind of support so we can do some tests. But once again, this is a part of the testing. I mean, I want to make sure that I can move this correctly, and I like fluid movement. And now when the skin is on, even though it might be kind of, I guess, robotic look, it's not set up on, you'll see a big change when it's set up on the so-called servo controller and using VSA software. But I'm just testing some movements here to see if I can get, as far as the torque, and make sure that, I'm not going to break anything, or just checking some things. But once again, when the skin is on there, it's going to act like a tension spring. So everything will be kind of more fluid-like, but you'll see. But as you see here, I'm just basically testing some simple movements just to see what I can get as far as a realistic movement. Plus, overall, we don't have our rotation yet. And the other part is that the so-called linkages are mounted on the outside now. The first test, the linkages were mounted on the inside. And the main reason I had them on the inside is just see if I can reduce some of the, the space, kind of make things narrow a little bit. And then another thing I'm thinking about doing is, I even went through, and you'll see it later, where I've actually designed the linkage to kind of be like areas where I can bend these so-called rods, these threaded rods, to where I can get a more, I guess, not such a straight linkage, bend them to where I need them to be bent on the servo arm and on the skull itself, as you see here. Well, what do y'all think? I hope y'all enjoyed this content. It's
few more testing cycles to go through, and we're going to get this thing moving. But appreciate all the new subscribers, thumbs up, comments. Y'all be sure to let me know what y'all think. Y'all have a good day. Later. I hope y'all are doing well. And we've had some ice storm, and after that we had flooding, and one day it's 12 degrees, and a week later it's 70. So still under the weather. Family's been sick too, and one thing is another. But this is 3D printed creature part 20. I want to show you what I've done. So I had to remodel the jaw and just move the so-called linkage area to the jaw. I kept getting a backlash, but now you see it's working correctly. I had to do some redesigning on the tilt mechanism servos. I needed something a little bit more torque. The other ones just wouldn't probably handle plus skin, so I had to go with some higher torque servos. Also, I modeled this little panel for, to kind of keep the servo wires organized. But as you see here, I'm testing the each servo before I set it up on VSA software. There's another servo I need to order, but they're out of stock right now, and but I need to get a servo block that comes with it. But as you see here, I even labeled all the servos on this panel so I can kind of keep these wires organized. Now this panel will be redesigned later when I have all the servos in place, and this will be more like in a chess piece, and so we can keep it all organized and in the right position. Now they discontinued this servo controller here. It's a really good servo controller, but this is Endurance RC. But I'll be using another servo controller, and it'll probably be a lot smaller. This is like a 25 servo controller. But this is VSA software, and you get it from Brookshire software. I have version 4, but I'm going to demonstrate this by using the demo of version 6 and how to set this servo controller up in the software. You go into type and you have to go into port, and then plus you can name each servo on what it is. As you see here, the type, I have our endurance servo, and then I have port, which is the servo controller port. I have to change these individually. I'm recording this on OBS Studio, which I can video capture, but it's just setting all of this up needs to be, the servo controller needs to be hooked up to the USB, and also the power to the servo controller is active. As I'm recording the video capture and I click on this jaw mechanism, when I move this so-called servo diagram here in the direction I want, the servo is moving the jaw as I'm doing this. It's just trying to demonstrate the video capture and shooting the animatronic live at the same time. I'd have to do picture-in-picture, which you will see later. But when I move this in the direction I want, because the power and the servo controller is on, and this is how, with this software, you can also put, let's say if you've recorded you talking, you will have your mouth moving, and plus you would be able to edit the so-called audio track of your voice with this software. I mean, this software is so cool. This is pretty much Go Motion, and you're animating the servo to a voice or to a track of some sort. So if you had a 2-syllable word, that would be up, down, up, down. So 4 movements that you would have to control, and you would have 4
separate bar graphs to make this happen. So actually you're doing a form of animation, and this is just a really wonderful software because you can control the software to the point to where if you need your mouth to move faster or your lips to move faster, it all depends on the length of the bar graph. The longer it is, the slower the servo would move, or shorter being faster. So this number one servo is the eyelids. And what I'm doing, I'm making the eyelids, and then I'm moving the eyebrows. And each time that I'm doing this is that so-called certain speed for the eyelids to blink. So I have it blinking open, and then I close the eyelids, and then I open the eyelids. And then on top of that, what I can do is I can highlight that whole section and copy it and put it right next to what I've just created. So, and then here you see that I'm reducing the size of the eyelids closing by adjusting the speed by making them smaller. So now when I have a so-called routine of all the servos moving, I can press play, and then this will be the first what I've achieved. And then if I want to adjust anything, I can go back and add as far as copy and paste to get the same movement that I want. And then I can also do the copy and then paste, and then I can change that paste by making it longer or shorter, as you see here. I really enjoy VSA software. I've been using it for a number of years. I mean, probably 15 years now. But it's just, the workflow is just so comfortable to me to use. But as you see here, I'm adjusting it to do an even faster movement. But like here, you'll notice that my jaw is always open. So I'm going to go back in there and re-edit the software, and then I'll just press play again. As you see, I probably need to make some adjustments to the so-called center lip to where I might need to remodel or either add some washers to it to make it a little bit more tighter. But here I'm adjusting the tilt mechanism to be faster or even slower, or even just add more movements by just copy and pasting. But overall, it's working well. But this is just a movement test. I'm not going by any so-called audio or video file to actually match the movement to a voice or to a sound. As you see here, I have the skull top on, and now you're really getting the true look on how it's going to be moving. And plus, later on, I'll be able to critique it if I have some kind of a audio file to go by, and then it will be even just a crazy look when we have skin on this animatronic. By using this demo, I'm just doing a test of all the movements. Now I cannot save this file because it is a demo, but just to demonstrate what I'm doing here is I'm adjusting the jaw mechanism up, down, and I'm doing a copy and paste, and I'll shorten the whole paste, and in that way I can get kind of a realistic mixing. By me recording this whole process of this demonstration with this software, it might have taken an hour, but that's, once again, I'm recording everything, and that adds more time to it, but it doesn't take long at all. But this is the final result. But look, I hope y'all enjoyed this. I appreciate all the subscribers, all the thumbs up, and all the comments. And please share. It helps the channel. But I hope y'all have a wonderful day. Later. Hello everyone, I hope y'all are doing well. This is 3D printed animatronic creature part 21, gimbal testing with VSA. Well, I'm sorry that I ain't posted recently. I just been doing a lot of testing. Well, as you see here, I'm replacing the plate, the bottom plate, and that's where the jaw, I guess you would say the jaw mouth area. And I redesigned the so-called plate as you see there on the right there, and I'm going to replace it. I did some testing with some servos as far as for the gimbal. One of my servos failed, and it was nothing that I had done. It just, when I turned it on, it didn't want to move no more. So sometimes that happens. It's very rare though. But when I didn't have another servo that would match that or mirror it, so I had to go with some other servos that were bigger. But they are good servos, and I've had them on other gimbals before, and I know they're really good servos. I even tested some mini servos, and they were strong and they had good torque, and I think they would handle it. But I really rather have something a little bit more dependable as far as torque that would handle when it has skin on this animatronic. As far as this bottom plate, I had pulled back the so-called gimbal points where the head tilts left and right. And I pulled them back because the further back from the pivot point, that would make it, look up higher. And then, or you could make the servo arms or the servo horns longer, but then that would interfere with my so-called chest plate. But it's just one of those things where you have to either sacrifice or larger servo. But it was just one of them things I'm just trying to test. But as you see here, I'm, adding the jaw back to this plate, and it's back kind of to the original design. I'd still like to raise them up a little bit. And there's one part when I'm putting this jaw back in, I'm having trouble putting the jaw hinge mechanism, the screw points, putting the screws in that area. But there was a plate that I've been meaning to remove, and I'm going to remove this so-called support plate. It's right behind the lip mechanisms, so that will be easier for when you put this thing together. You'll be able to get the screws in the well, or the screwdriver or the tool, so you can tighten up that screw and nut. I made a lot of gimbals, a lot of gimbal designs, and I've always gone with the lower servo block being my left right turn. And I kind of keep everything in the bottom, but you can design one to be inside the skull, but it's kind of a tricky thing to put it inside the skull because that's where all the other servos are, and you don't want all that weight because it will be all the weight on that screw on the hub of the servo. And you just want to try to avoid that, even though all the weight is on the bottom servo as on the gimbal that I've designed. It's just a lot, to me, it would be a lot safer because there's no servo block for a mini servo, and I'm trying to keep the animatronic small. So if I did it, I would do it with a mini servo, and it would have torque, and it would be fine, and it would turn. But you'd have to have a plate underneath your skull to turn against, and then that hub that's turning on the other plate would need some kind of support, so you would have to have a flat pillar block to make this work. And then on top of that, you would need another pillar block just for added support because you just don't want all that weight on that spline of the servo, the turn mechanism of the servo. And I was just doing some doodle testing for this just to show you that it can be done, but you being a small animatronic, I'm just limited with space because I'm trying to design this, you know, this mechanism, to have a lot more movement, but adding, even a mini servo would be, it would take a lot of space. Still waiting for a servo to be available for a certain type of servo block that Servo City has. And once again, that's going to be a lot more to save a lot more space and lower the so-called heights of the whole animatronic. But for testing, I wanted to test the the one servo block that I do have, but it's mainly made for high-tech servos, and which are good servos, but the one I have it's okay. It's pretty standard cheap servo, but it works. But I also designed this so-called, I guess, a space showing me when the whole mechanism turns, I have clearance, so I can put this in the design of the chest piece to know what kind of clearance I have, so I don't have any servos bumping inside the chest. And as you see here, I can have the clearance to where I can maybe change my design of the chest piece, because I want the skin to kind of cover this area where the chest piece is, kind of making a small mini full head mask for this animatronic, and it will be in silicone. But this is the design I come up with using these standard large robotic servos. Well, I use a lot of parts from Servo City, as these beams is going to be mounted center axis straight line to that hub, and it will go straight to the servo block. And this is a really cool design, and it really helps the servo, and it gives it strength and torque. It just gives a lot more precision because it's all based upon that bearing. It's a really good product, but I'm waiting for a smaller version that is a standard servo block, but it's a new design. As you see here, this is the servo block I'm going to be using later when the servo becomes available. At the time, they don't have the one I need as far as with torque, not available. But I'm using this older servo block here. And as you see, as I rotate it, you'll see how center axis that beam is. And I'm kind of designing it that way to keep everything kind of balanced. But that new servo block will save me in height, probably about 25 millimeters. I got some things coming in, like some lock nuts for 2 millimeters. And when I finalize the design, and like this servo is in the gimbal. Now, I might not use this in the final design, but this is what I'm using just to test the so-called gimbal. But once again, it's it's getting close to do a final design on this. I just want to make sure everything's working, even if I have to order newer servos for the gimbal tilt mechanism. Because I know that I'm going to be getting one for the left right, as you see here. Now this is a weak servo that it's a high tech. It's one of the cheaper ones. I think it might be a 311, but it's got the pulse. But I am moving it slow in VSA. But I'm just testing the movement first before I speed it up. And what I do, as you seen in the last video when I was doing some VSA, I'll reduce the size of those bar graphs and I'll make it go faster, as you see here. Now there's nothing on the animatronic head moving. I'm just using the left-right movement and the tilt left-right. So it's just 3 servos that I'm controlling with VSA. I have a chest piece to design to cover those large servos, but once again, I'm probably going to end up replacing them. It's just finding the right one at the right price. But as you see here, it's moving quite fast, and it's showing, some expressions. And then I decided to hook up the eyes and the mouth and put the skull in on. And you can kind of see where this animatronic is going. It is starting to come alive. Now I'm controlling the mouth and the eyes with the RC radio, just for testing, just to get a look on the expressions. Now this is the fastest speed that I could do. I can go faster, but it would be too fast to me. But I just kept copying and pasting. But look, hope y'all like it. Hey, thanks for all the subscribers, likes, and comments. Y'all have a great day. Later.
Hello, this is 3D printed animatronic creature part 22 chest cover gimbal testing with VSA. Hope y'all are doing well. We're almost at 9,000 subscribers, but been kind of working on this, different servos. Had a servo fell on me. I believe I told y'all that last time. I didn't have a mirror servo. But these are mini servos here, and these are King Max servos. But I made this so-called scaffold with these beams, and y'all see later it's going to be holding the chest cover. But this is what I've been working on and keep testing. Mainly the servos, like the last test I did was with standard servos, and they're just too big, but they have high torque, really high torque. But and they're somewhat like robotic servos. But as you see here, I'm just demonstrating the mechanism that this is what's turning the neck, and the two there are the tilting servos. Now, the two servos there that are moving, those tilt servos will not be changed. Now, the rotational servo will be changed, and this whole setup will probably be changed also, but this is just a part of it because I'm trying to design this so-called chess piece, and you'll see what I've come up with, but I'll change it to mount it to the other servo block mount. But as you see my clearances, where these are mini servos, but if I had standard servos, I wouldn't be able to have the rotation. So not only that I'm concerned about the shape of my chest cover, the outside is also important, but also the inside is the most critical, because this is going to give the illusion of the neck turning, but everything that's turning the neck is below the chest. Now the center beam will probably be the standard, but connecting the servo to the so-called hub and then to the new servo block with that new servo, that will be changed, and I'll be able to make this so-called carriage is holding everything a little bit smaller. But as you see, I'm holding a light so y'all can see inside, 'cause it gets kind of dark. But you see the clearances that I'm having to have here to make this so-called head just turn left and right. But visually, when you see it as an animatronic in my designs, and then also when I put it in a ZBrush to put the skin on it, I want the skin to be able to flow onto this chest, but I can't bulk out the chest because it's going to bulk out the skin, and it's going to just make the whole character look kind of weird. But I'm just showing you what I'm trying to achieve here, but as you see the clearances, I mean, it's working really good, but it's only going to be, the rotation is going to be less than, 180 as far as degrees, but it's coming along, and this chest piece here will be changed to mount to the other servo, but I did a test, just testing the movement, and this is what I come up with, and this is BSA setup, and this is at the slowest speed when I'm starting. And when I edit VSA, I can edit it so I can make it run faster. But me just checking the clearances of mainly the only problem that I was having in this very beginning was the linkage was bumping that that forward edge there just a little bit, especially when it turned here. But but this is what I got as far as the first. This is the very first test of the gimbal. Now on the next test with BSA, I made some adjustments to the speed towards the end, and I also add the blinking, but I'm blinking it with a radio, and then that way I can just have BSA run it. But it's at the slow speed now, but towards the end it's going to get kind of faster. But once again, I can keep speeding it up, but yet this is just a movement test. I want to make sure everything's clear before I can, crank it up. But there was other things that I was wanting to do. I was thinking about putting tension springs on the back of the pivot point. And when I say tension springs, like some strong rubber bands that would do a counter, kind of a counterweight. That way it would appear that the heads floating are balanced. That way it would be any kind of, if there was any torque or heaviness to the servos, it would relieve that. That way it would be like balanced. Be easier for the servos to move the head. But if I add tension springs to it, it will help with less wobble. Anything mechanical that's on a shaft and it's moving, it will generate some type of a shake. And it's just a mechanical thing that happens. But when the skin's on it, all that will be eliminated. And then plus you got to calculate this older servo that is turning, or this so-called, this is a cheap servo that's doing the rotation. And it's not the top of a line. Later, that's going to be changed out, and that's what I'm waiting for. But as you see here, here's the design I mentioned earlier about adding a tension springs. That I would have a beam here, and then I would add the pivot point, and these little screws that are coming out will be holding the tension spring. Now I could use regular springs, and plus that I gotta make sure that I can do adjustments to this either by adding springs or rubber bands on one side to the other, because there's there's more servos on one side than the other, and that would throw off the balance. So I'd have to just dial that in, adding rubber bands to one side, just basically just trying to get the thing level. And that would just relieve a lot of pressure if there's any on those servos. But I got two videos that y'all have seen already, but I sped them up so y'all could kind of see the illusion. And eventually I'm going to get VSA to run this fast. But it looks kind of like stop motion. But it's pretty cool. And hey, I appreciate y'all. And thanks for all the subscribers and the kind words. And let me know what y'all think. Thanks a lot, y'all. Y'all have a good one. Later. Hello, everyone. This is 3D printed animatronic creature part 23. I'm moving all the servos just to show you some of the movements, but there are some things I worked on and did some testing. But as you see here is the design of the gimbal. And there were some other things. I did take off a little bit off the chest plate, but I've not printed that yet. But that would, at the very top where the opening is at the start of the neck, I did remove about 2-3 millimeters off there, just to give it some more clearance. But I'm trying to look at my other options for some little bit better linkages for that area. But here's me putting on the chest plate, as you see here. Now I'm waiting to get another servo, and it's going to be a little bit better for the turning mechanism. And I shot some video and and shot some really good video with a different camera. But this was another option. And when you get into making animatronics, you'll go down a rabbit hole to where let's do one more movement and let's do another movement. Let's do one more. And this was a tilting mechanism that I wanted to do. But then when you you get the head to turning, you kind of even want to turn it or tilt it the other way. But the more movements, the more realistic it's going to look. But as you see here, if I was tilted forward and back, that would look pretty cool. But I would still have to change the chest plate just to get clearances for the linkages. And also the servos too. So it would be more remodeling pretty much the whole chest piece. And before long, it's just going to get too big for the head. But I was sitting here and I was doodling around. And I was just wondering, with this chest piece, this chest plate that I have designed here, and I says, well, I wonder what would it look like if I put a body on it. So for me to put an animatronic body on it, I had designed a baby newborn. So I just took this newborn and I enlarged it to fit the so-called chest piece to a point to where I would still have to do some remodeling. And plus, I've enlarged it so the servos would probably be more likely have to be redesigned to fit the sockets. That way it would be probably standard servos because they're more torque. But, this is not a walking thing. It would just be kicking like a newborn or whatever. But it would be a pretty good size, uh, around probably, uh, I don't know, I guess about 3 feet, 3.5 feet. But, it's just something to play around with, just get to thinking about it. But it would be better as a rod puppet, though, I feel. But I did some movement tests and just testing, as far as what I can do with, all the servos working. Now, I am working the eyelid still with our RC radio. We're almost at 9,000 subscribers. I'd just like to thank everybody. Hey, I appreciate it. Thanks all for all the nice comments and the thumbs up. It's going to help this channel grow. And I'm trying to make the quality of my videos a little bit better. I pulled out an older camera so I can shoot some footage. You'll see here after this video here. But I appreciate y'all once again. Uh, you know, Eventually I'm going to have this finalized, and then that way I can put this on Patreon. Everything has to be designed correctly and set to where then I can make the final, you know, uh, finding all the right parts for y'all, have links available, so all y'all have to do when y'all join my Patreon, y'all have the STL files, order all the servos and all the nuts and bolts. But I am using BSA, and I've played around with this software today to where you can have a robotic look, and that's if everything is lined up in a certain way, it will move the jaw, move the mouth, and you can have that individually in it. But if you can mix it, and you'll see here where I'm mixing it, but I have all the lips moving, the jaw moving, and the brows, and it's turning left, right, and tilting. But this has 8 servos in the head, and it's pretty good. But as soon as I get this new servo, I'll be able to control that rotation a lot better. But it's coming along. But you see here, I'm plugging up the battery for the eyes. But we'll get this moving. But I left this video, this part of me connecting the eyelids on with a. It's got a RC receiver, and I left it in there so you could see the size, kind of a size comparison on really how big this thing is. But I mean, it's in this video to me. I mean, it's a lot clearer to me, and it's brighter. But what do y'all think? And let me know in the comments. And I hope y'all like my movements on this animatronic. You know, y'all been watching me do this for, I guess it's 2 months now since I started designing it, and we're at part 23, and we're moving now. Well, this animatronic's been it's about 2 months now, I guess, when I started designing it, and now it's moving now. But a lot of that might be, uh, trying to get a hold of certain supplies and servos and things, and still have some trouble getting them. But I hope y'all like this movement, and let me know what y'all think. And I hope this helps y'all. But I appreciate everybody. Thank you for all the subscribers and the comments and the thumbs up. Appreciate y'all. Later. Hello everyone. This is 3D printed animatronic creature part 24 gimbal rotation test. Wanted to show you the process on how I change out the servo for the rotation of the whole head with the so-called chest piece in place. The large block below it is something I've been working on, just kind of like, it's going to probably be a wooden block, something nice, just to support the whole thing. But as you see here, this is the Servo City servo block, and this Gobella servo is going to be used for this servo block because this servo block is made for this servo. But as you see here, this is how I'm going to be mounting it. And that large block is going to be attached because I don't want this, the animatronic's going to be somewhat top heavy, and I just want it to be stable, but this is later on, but just to be able to support it instead of the vise. But this piece right here is the hub that I chose. Now this is a wheel hub, but I like it because it had a straight axis for this beam, and what this is, that this is going to be sandwiched to the servo sockets that this is going to be rotating to. So it has to be center to the beam, center to the hub, and center to this servo hub to the servo block. And these beams support the so-called chest piece, allowing it to rotate within that chest piece area. And since I'm having to change this servo block, I had an older servo block, and it was Imperial, and it was, probably a few years old, and I ordered this one, and this way I could get everything back metric, and I really prefer metric over Imperial. And they mostly discontinued all the Imperial things at Servo City anyway. But this is what I got, as you see here, and this is the setup with this so-called new servo block. But a servo block is really good, and it's unusual how it supports the so-called servo in a aluminum or aluminium kind of a servo socket bracket, and it has a bearing. But before I can get into it, and y'all see it later, but I have to take the old one apart, and I can just show you how I'm having to do this. It's fast speed, so you can watch and enjoy this. But the servo block is really cool. I wish a lot of servos would make these. I mean, this is a patented, design from Servo City, but it's just really, really important how you can protect and give the so-called servo horn support with a bearing. And you can, in designing servo or animatronics, you really need, you can't put a lot of weight on a spline or the axis that rotates on a servo, and you can damage a servo if it's not done correctly. And this just helps on designing certain animatronics. But this is me showing you. This is the old servo block, and I'm just taking it apart, just taking just basically everything down to where I can transfer it to the new the new servo sockets, and then I can reduce the size of this so-called this whole beam area. And as you see here, I'm just having to, there's a lot of screws in this so-called design here, and it's much, it's bigger being so-called imperial, and I've had to use these extra beams just to be able to lay it onto this older servo block. But this hub that I'm putting on the end of this beam here is a hex hub for wheels, and you get two, but I only needed the one. But as you see here, I can make it where this will be center axis to the servo spline onto the so-called mounting it sandwich this whole piece here to the servo socket blocks that hold the servos for the tilt mechanism. And here is the new servo block using this servo here. And I'll screw this in place, but I'll make them loose. But then I'll put the servo horn into the bearing and connect it to the servo spline. That way I can center it correctly, and then I can just finish tightening the screws in place. But I've been working on other things too. I have a baby animatronic, and I've been working on also a large animatronic head, and been redesigning the jaw for it. But as you see here, it's a quite simple device on this servo block to put together. And as you see here, I'll compare it to the old one, and see the old one. It has a servo. That servo there is a high-tech servo, and its tooth is, or the spline is a 24-tooth spline. And most servos today are, the spline as far as a standard servo are 25 tooth, or a T25 they call it, and that's the most common servo horn. But as you see here, it's working. It just makes it so much more fluid, and I'm really happy with this design, being the size. And they have those screw points on the side there and on the top, all the way around basically, and it's all metric, and these are threaded, so that helps putting things together. But all these servo blocks have this, and it's just really a good design, and I'm happy to use them. But this is a pretty cool device right here. I wish they would make mini versions of this for mini servos. But as you see here, I can just pull this servo horn off. Now you can screw this down, connect it to the servo, but at this time I want. And in this case, I might not really need to, but because it's going to be always, um, standing straight, but you can, but I would redesign the so-called uh, beam situation so I can place a screw there and then lock it in place. But as you see here, I'm just sandwiching this so-called this beam and the servo sockets where I have the tilt mechanism, and it just fits on this block, servo block, correct. And then I can demonstrate it here. As you see here, the rotation is nice and fluid, And this servo here doesn't really have a whole lot of what they call uh, the pulse. Sometimes on the cheaper servos, they have a pulse and it kind of skip during the rotation. But here I'm attaching beams so we can connect the chest piece, the covering of these tilt servos and the rotational servo. Now these beams, there's a hole every 8 millimeters center, and the end of the beams is threaded. So that these are cool designs too, and aluminum's lightweight and it helps in design. And sometimes you will need beams to support 3D prints, and when you have a lot of 3D prints, you don't want to make it too fragile, and this will just add support to your animatronic design. PCBWay contacted me about doing advertisements, and I thought that was pretty cool. And they have a printing service where they print in all types of materials, and they also print things in metal. And uh, one of the things I would love to do later on in another project is do a small animatronic again, but have it printed in aluminum or aluminium. And I just think that would be so cool to have one in a version of all metal. And then the thing about doing that is it wouldn't be 3D prints. It would be, I'd have to design it to where it would be where I could put threaded into the metal pieces. That way I could just bypass nuts and just do straight screws into the, screwing in the, the servos and their sockets, and just bypass nuts, altogether. But that would be a neat animatronic to just be all metal. But as you see here, I've transferred everything to this new, this whole gimbal. And another thing I've been also considering is cutting down some of this chest piece even more to make it maybe more narrow to where, see, this is what I'm also thinking, that I'm going to be adding skin to this, and then I'm going to have to design skin to cover this chest piece. Well, the more area that I'm going to have to cover is going to be more silicone, and the more silicone, or the large of this so-called mask skin area coverage of this animatronic, is going to make the mold bigger. And if it's going to be bigger, it's going to be more supplies. And to keep costs down, I'm willing to sacrifice some of this, just to keep everything small enough so we can all afford this. Because silicone is a quite expensive material. I mean, it's come down in price. It used to be a lot more expensive than it is today. But once again, I'm just trying to keep costs down for y'all so y'all can understand on building something like this can be quite expensive, even though, this servo head has 8 servos in it, and I've gotten the servos down pretty low, and I might make even more adjustments to even to this, the gimbal servos. Uh, I'm trying to locate everything to where it'd be easier for y'all when y'all build this so-called animatronic that I'm designing for y'all, to where y'all can afford these and also be able to get them easy. But once again, on this so-called head, I was still having trouble with the mouth or the jaw neck. And what I noticed is I did put the jaw servo backwards, or it was upside down, so I had to flip it, and then I had to do another linkage. And but once again, I got the servo flip in its right position, and then just added the correct linkage length, so I wouldn't keep getting a backlash or a whiplash where sometimes if it extends too far and it folds onto its further hinge point, you'll get this so-called fold and it won't work correctly. And that's just in part of the designing of it. You know, you try to keep them short as you can, but if it's at a longer distance, your linkage is going to have to be long. But I got it working. It's working good. I'm happy with it. But now I'm going to get ready to connect it to the gimbal, and I'll do a gimbal test. But I like the opening. It's going to be opening wide. But once again, when we get the skin on, it's going to be really cool. And then we'll have the lips to move and to where we can open them lips up and see the teeth. But as you see here, I got the new gimbal all ready and set up. But now I got to mount it back to its neck location on the beam. Now, to hold this in place, I use this little, it's a milling vise, and you can pick these up, and I like them because I can kind of, hold my servo, because this, it's just standing on the servo right now. And this is where I was designing that so-called block, and that block would just inset inside that block and hold in place, because once again, it's going to be top heavy, and with this mechanical head moving all over the place, it's just going to be more likely to want to teeter. And I got to design that support the whole animatronic. But I have this in place, and as you see those metal parts on the top, that's the neodymium magnets to hold the skull in place, skull lid. But here's the first movement test. I was just testing the movements as far as the tilting, and I do some rotational movements also. And again, when we get the skin on there, it will act like what I call a tension spring. And that way we'll get rid of the mechanical wobble. And you'll have that if you have anything of a large structure mechanically. It kind of has this so-called mechanical wobble to it. But once we get the skin on it, a lot of it's going to be clean. But if you see here, here's the movements I did straight on with the camera, and I'm really impressed with it. And with the servo that I have, the new servo on the bottom there with the rotational, you can kind of see it. Now I am controlling this with the RC radio, and I'm going to demonstrate that in a minute. But just to show you the rotation and the fluidness of it, and it will also look a lot more fluid when I hook it up to the computer, because the computer has a different kind of, I guess, a format, and it controls it more fluid, and plus I can mix it better than I can here with the radio. But as you see here, it just gives it a little bit more life, more expression. But next, what I'm going to be doing is I'm going to reconsider maybe doing some design changes to the chest piece to narrow it down a little bit. Once again, I'm trying to keep costs down, and this is about 250 millimeters tall, and trying to keep it small enough so the cost of materials to molding and casting in this will be lower also. But once again, I appreciate all of y'all. Thanks for all the subscribers and all the comments, and I'm really glad to share this with y'all, and hope y'all helps y'all with y'all's future designs of animatronics. And I mean, it's really fun to do, and it's a really good achievement. But once we get skin on it, now we're going to look at core. We're going to look at just getting things ready to make the skin and get this process finished so we can see it move and come to life. I hope y'all like. Thanks for everything, all the thumbs up and comments and the subscribers. Later. Hello everyone. This is 3D printed animatronic creature part 25, servo movements. I put all servos, everything, every movement on VSA software. So I'm controlling everything with the software. And as you see here, I have a servo controller. And I'm only using 10 channels. But as this is a discontinued servo controller, I've had this one for several years, and the company was RC Endurance, and it's a wonderful controller. And I wish they were still, in existence. They were really big. I believe it was in 2007, but I but it was not too long ago. I went to the website and it was gone. But there's several other servo controllers out there to choose from, and some of them are quite good. But this is the setup here. But this setup here is uh, 1 through 25, so it's a 25 servo controller, and you have to plug up a USB and also a power. But to set this up, and once again, these servo uh, pins go from 1 to 25, but VSA software goes from 0 up. I mean, you can do a lot of servos on VSA. But as you see here, I'm going to show you how I set it up. I probably showed this before, but I keep wanting to show it, and then I'll record it so maybe y'all can see it better. But VSA software is set up by, as you see here, I'm putting the name in that certain area that it needs to be. But as far as setting up, like as you see here, the type of controller and the port controller, and then all the names. And then what I do, I just start laying out these little bar graphs. And you see this little window right here, it pops up and you can see me adjust the so-called little servo in the direction. And each time I move that, like for instance, if it's the jaw, it will move in real time right next to me when I'm doing this. So in a way, it's kind of like doing stop motion or go motion, you know, and right there in front of you. You'll move a little bit and you'll see your movement. But like if I had audio, and later on we'll have lot audio set up, and you'll see where I have the audio graph, an indicator, and then if I say a word, I can break down that word and how many syllables, which is if a one syllable word would be two movements, open close, and that would be two movements. But as you see here, I set the first movement and press play, and now I'm going to adjust it. So I come back and I just start playing it again, and then I'll see that next movement. And as you see here, it slowly builds up with movements, and as you see, it's a lot slower. And then it I just like doing things slow at first, and then I can reduce the bar graph into any speed necessary. And sometimes it can be too fast. I've tried all different ways or whatever until I develop some type of routine or with audio files. But as you see here, I just press play on that, and this is what it's going to show me. And it shows me the whole routine that I have listed on that programming of the VSA software. But once again, I like what I see, and I says, okay, I'm going to make the eyes blink faster, or I'm going to make the eyebrow move. But a lot of these movements are already done that I've done before. And what I do, as you see here, I'm doing the eyelids right here, and I copied and paste again, but I made them faster. And you'll see on this movement right here, at the very end, when I press play, but at the very end of that routine, you'll see how fast the eyelids blink compared to the first. Now I'll just add the skull lid or the
skull cap to it, and then I'm going to go ahead and continue. As you see here, I'll just fit it in place. But then what I'm going to do is I'm going to do another program and see if I can get this a little bit a longer routine. And as you see here, I'm still trying to make it to where I can get these eyelids faster, get everything pretty much faster. And just as you see here, I press play and then I'll see this routine again, which is not a whole lot of movements. It's just like the brow might go up, down, or the eyelids might blink 4 or 5 times, or the jaw opens slow. But then I'll kind of speed it up as you see here. You'll notice the jaw moving a lot faster. But a lot of this, what I'm doing here now, is I'm just testing everything on VSA. That's all the movements. And just make sure everything has clearances, make sure there ain't bumping. Now, I would love to have, you know, I mean, I'm trying to design this as lowest cost as I can and yet be dependable. And as far as, because it's going to have skin, and the skin's going to be somewhat expensive itself also. But once again, I'm just trying to make a good animatronic with silicone skin realistic. And but as far as like I said in the last video, I mean it'd be cool to have one all metal, and I would love it to have bearings in all moving parts because that would make things a lot more fluid. But to have all that milled would be quite expensive. But there's companies that would do that, and I could probably do that on a smaller scale. But as you see here on the VSA right here, I'm going to set up a longer program as you see this routine. But once again, when I have a planned routine where my voice is added or a character's voice is added, I can sit there and animate the entire thing and have an audio file to go by to see the movements and to add expression. And when it has the skin, it's just going to be, it's, I'm going to try my best to make this thing look alive. And also what I did is I picked my camera up and I started holding the camera and to just give some different shots as I'm just giving a different look for y'all to see, is and the perspective of it and just to give you, a better visual of the animatronic just instead of it just on the tripod. I like what I see so far. Now, the next process would be everything should be pretty much, everything should be just kind of dialed in, adding some nylon nuts to everything. Just make sure everything is tight. Make sure things are right. Maybe do some adjustments on the chest to make things little bit more narrow, and to keep things kind of smaller and tight. And then I can start designing the core, and then the core will be finalized. The animatronic will be finalized then. Then when I start doing the core work, it's final as far as the animatronic part. But then when the core is done, I can start sculpting, doing the digital sculpt in ZBrush or in Blender. But I just prefer ZBrush. But as you see here, here's the movements that I was getting it, and once again, some of the speeds were a little fast. But once again, when the skin's on it, it might not look as fast. But I'm just excited now, and I'm getting that close time to start thinking about what the skin's going to look like on it and have it a realistic looking creature. I hope y'all like it. But once again, I appreciate everybody, and thanks for all the subscribers and and the comments and the thumbs up. It really helps this channel, and even if you share it, I'm trying to keep this channel going, and we'll set up a Patreon and we'll have these files available for everybody. But once again, thanks everybody for everything, and y'all have a good day, and
Later. Hello everyone, I hope y'all are doing well. Sorry it's been a little while since I posted the video. I've been having other things to work on. But this is what I've been doing with the 3D printed animatronic creature. I'm changing out the servo controller for something smaller. Now this is, like I said, this is an older one from RC Endurance. This controller has been discontinued. The whole company is, I guess, pretty much gone now. But I just wanted to show you some of the things that I'm doing and come up with. And if I, make this servo controller smaller, and even though that we're running, I believe, 11 channels or 10 channels, and we'll need something smaller, but I still don't know at this time where I'm going to locate this. But as for right now, we're going to have it probably tucked in on this center beam inside the animatronic. But here's another servo controller, and I've had these things for a number of years. And this is a Servo 25 controller from RC Endurance, and this is the new one that I have on, or the newest one. But this is what we're going to change into, and this is the Maestro 12 channel, and it's just a lot smaller. And just to set this thing up here, this little controller, as you see, it's got a small format and a USB connection to the computer. And it has a jumper, but the jumper's not on there. And it's later on when we have it, I guess like wireless, or not wireless, but as far as, not connected to the computer, we can program it. But on the back of this little controller, you'll see the diagram or the schematic, just locating everything, the text, where the battery is. And then on the front, this is just to show you the indication lights and things like that. Well, to hook this up, you got to do this right. Make sure the dark wire, the black or brown, is on the outside perimeter of the servo controller. Then you plug up the USB, and then there's a software that you can download at pololo.com, and I'll send you the links and with this so-called servo controller. But I've been also doing some other things with the files, getting everything ready to put it up on Patreon. But as you see here, I got it hooked up, but I'm going to show you a different angle. This is the power, and make sure the power wires, which is the black, is on the outside, and that's just the way the schematic is telling you. Then I hook up the USB. But for the software to work, you hook this up first, and then you activate the software. But you can get the software from the manufacturer of the servo controller from pololo.com. And I'll send you all the links on this video in the description to where you can get this servo controller and the information on the software. But as soon as you activate it on the computer with your servo controller powers on and the servos are in place, it'll recognize it, as you see here. But you just click on the icons of what number the servo is inserted in, 0, 1, like we have here, and now I can control the servos by moving these little tabs. But once again, we have 11 servos in the animatronic, and 2 of them are on a Y cable, so that's really just 10 channels, and this is a 12-channel servo controller, so the smallness will help with space. But once again, I'm not quite sure where I really want to locate this device when the animatronics is complete with skin and all, because as far as wrapping around the back of the so-called animatronic itself, I would kind of like to have it visible so you could plug up battery supplies and stuff like that, or it could be enclosed in something. But as you see here, you can see the servos that I'm testing. Now this is quite different than uh, VSA software, but this controller can work with VSA and with other servo controller softwares. And there's several out there, but more than likely it's going to be programmed. You can program it with this Pololu software, but it's just another learning curve. And all controller softwares have a learning curve. I mean, it can be quite easy or it can be difficult. But once again, I hope y'all have enjoyed this tutorial on how to build a 3D printed animatronic creature. And so far, this is where we're at. Now, I have all these colored different, and what this does for me is that I have the STL files to these. And with a number of changes that I have made, like on the jaw and things like that, to get everything, you know, pretty much dialed in. Now I can start just listing all of the STL files and set up the so-called Patreon so y'all can join in and start building, this animatronic yourself. And I'm having the list of supplies to get, and more likely I'm going to rebuild this. I have I have some nylon nuts coming in, and that's going to be needed for some of these parts. And then I'm just going to put it together, and we're going to go from there and have it all complete. Then we start on the core, and then the core will turn into the skin. Once again, y'all, thank you everybody for the interest in this animatronic project, and thank you for the shares and likes and the thumbs ups and the comments. And I really do appreciate that. But y'all have a wonderful day. Later. Hello, everyone. This is 3D printed Animatronic Creature Part 27 core making. I hope y'all are doing well. Appreciate all the comments, subscribers, and I've been dealing with medical things and trying to get better and slowly improving. So this is what I've been working on. It's time to make the core. And I've been, as y'all have been seeing, that I've been making some test designing of the so-called mold. And this mold is going to be, where I make the mother mold that holds the silicone so I can mold the so-called creature. It needs to be, I guess, the right size for me to achieve this. And if that's going to be the right size, I got to make the core the correct size. And I've been looking at printers, and as far as an FDM printer, and you got to realize that, the number one printer in the country right now is the Bamboo, and it's usually the X1 Carbon. But you know, and me personally, as far as printing, or my main thing that I care about is printing. It's not speed and it's not multicolor. My thing is quality. I just want it to be right and the correct measurement, and it needs to be that perfect for me. And that's what I really care for. And we know that there's a lot of copycats, because if there's something good, they're going to copy it. But it doesn't mean it's going to copy the quality. I mean, you can have one bigger than Bamboo, but it doesn't mean that it's going to print just like the Bamboo. And I've seen some FDM prints come from Bamboo that was really beautiful and pretty close, or to say, as far as organic sculptures and stuff, it's pretty close to, the early resin stuff. And that's pretty a bold statement for me to say that, but it's come a long way, and Bamboo's kind of done it. Now, Bamboo has other big or large printers, but all the printers, when I say large, they all go by so-called size, which is 256. And that's 256 by 256 by 256. So if I was to get a bamboo, I need to make this size of this core. I'm saying 250 millimeters, and then I'll have a little give there. Now, the even though the mold pieces are going to be laying on top of the build platform as far as the on the core has a plate, and the mother mold parts are going to be laying upon that. So it can be actually taller than the measurement. But as far as them on there, but I'm not going to be printing them. I'm going to be printing them individually. But as you see here, I'm having to make adjustments to my chest piece. And I'm having to do that because if I'm going to do the so-called core at a 250 uh, build plate, I need to make sure I can get it in that size. So what I've done is I've changed this chest plate. Everything else is the same, but as you see here, I'm doing editing to where what I'm doing here is I'm adding a lip. And when I make the skin, you'll see later on after I get this, finalized here. And I got to finish this, so I'll have this STL file available. But you can see how much I've changed it. But what this does is when the silicone skin is poured, it will go underneath there a little bit and create a lip. That way, when you stretch the so-called silicone skin over the whole bust area, it will have, a kind of a physical locking point, and that's why I'm designing a lip to this. But once again, as you see here, here's some some kind of test frames that I'm doing. And I thought about making it kind of a split level design, but then and having, you know, the basic thing is what I'm trying to achieve here is I'm making sure that the core, and this would be the core part, that the core, when it's inserted into the mold, that it's going to be locked in place and it won't be moving around or a lot of times you have to have screw points just to hold your core in place, but this is all going to be mounted on this so-called plate. But here is a lot of it's not set yet, but I'm having to make the block out areas. Anything that's going to be open space, any holes like for instance, where the eyelids are, it's all open space there. All that needs to be blocked out because I'm making this into one piece. It'd be one mesh that's going to be printed. And once again, you don't want any artifacts inside. You don't want no like a shell. All of it has to be watertight, one piece. And this is the core to where I'm going to be also sculpting on. So when I sculpt on it, I'll have the same plate as the core as the sculpture. And that way, when I mold the sculpture, the core will fit into the socket with the plate. And all these areas here that are high and how I'm designing it, the silicone that I'm going to be cast or molding in, which is going to be hugging these points to where it's going to also help keep the so-called, it's going to be stationary, the core will be, and when it's inserted into this mold. And then that way, later on, as you see here, I'm removing the so-called shell part of the whole mesh here for this neck, and in that way, it will be watertight, and it will be no problems. Because if you have an artifact inside something, as you know, when you go to check your meshes or your your files to a SDL file, you'll have a problem in saying it's not going to print correct. So you just have to check that. But if you design the whole thing where you're not having these troubles, that way you ain't gonna be messing around trying to fix crap. But everything has to be center. I mean, perfectly center. I don't want to be a millimeter off on one of these pieces. It needs to be perfectly center. And then all these things have to be edited right, so all you see is the so-called mesh from the outside. That's all you're going to see for it to be printed. Now here is the build platform of the bamboo printer. And now I'm making adjustments where I actually want this placed. Now it can go out further outwards, like in front of the face, but it's how wide and how tall. And as you see here, I'll be able to, now this is just the core. Now the core is not going to be molded. It's going to be the sculpture that's on the core that's going to be molded. So I got to make sure that I do this correct because I'm going to have space for the silicone to mold the sculpture. And that's going to probably be close to maybe a ½ inch thickness all the way around. Now the skin thickness is going to be anywhere from 3 to 5 millimeters thickness, but it might be a little thinner, but it's just I'm just trying to get this thin enough, especially on the eyelids. That's going to probably be the thinnest area, and probably the lips too. But now I have not made the block out for the teeth yet, and that has to be where when I make the block out for the teeth, I want the so-called forks that move the lips. I want them to be like covered to where they have their own little individual socket into the silicone. That way it can be secured in place, and then I can also add some silicone adhesive if needed. But all these are going to have like, you know, kind of their own little socket to move the so-called, you know, that part of the skin. But like in some of these sockets that I'm covering, they might go in a little deep because like the center brow here, for instance, I don't want it to move the other part, the other brow. Like I could just move that center brow. I don't want the other brows to move too. I just want that skin, that area to move. But this is going to be a lot of work here because I got to tie everything together. I got to tie in the main skull to the eye plate, and the eye plate to the so-called uh, the lip mechanism area, and all that has to be, what's covered and what's behind what's covered is going to have to be removed. So it's going to be a lot of cleanup to do, but this is the key. This is the a key point of this so-called animatronic for the skin to fit it correctly. It's like making a life cast of an actor and doing some kind of makeup effect on it. It has to be correct. I shoot a lot of these videos. Anytime that I'm modeling or making any kind of designs, I use a capture software called OBS, and it's a great, you know, it's a great capture software. It just documents everything. But as you see here, here's all the so-called plates that I've made to cover any of the sockets, and I still have some other things that I have to cover. As far as the bottom lip needs to be covered, and that has to be modeled, and all that. And like I said, once again, the teeth is going to have to be done to where it needs to be blocked out. But this is kind of a critical part of this animatronic. But I appreciate y'all, and thank you for once again for all the get well wishes and the condolences since my mother passed away. But everything's coming along, and I hope this helps y'all. And I'll have another video up really soon. Thanks. Later. Hello everyone, this is 3D printed animatronic creature, part 28, core editing. I've still been under the weather some. I'm just trying to get healed up. I got new medication coming. My old medication kind of got me with some side effects, but I'm finally getting some kind of results, but slowly. But this is core editing. And what I'm going to be doing here is the animatronic has been built, but now I need to make sure to make a core. It kind of needs to be like the animatronic as far as so we can get this skin to fit the animatronic correctly. And the core is an important key. I mean, it's very important for this so-called silicone mask to fit on this animatronic. Well, we need to make sure that this is correct. And we just need the outside of this animatronic, and we need to fill in any spaces to make this one solid piece. And any so-called artifacts that are inside need to be removed. And if you design a lot as much as I do, if you have something inside that's going to create an error, and if you have anything that's inside this so-called mesh, it's going to try to print it. And as far as 3D printing anything, it's not going to like it. So it's going to come up as an error. So the best way to do this is to remove everything. And so we can keep that original shell of the animatronic. And as you see here, I'm starting to, uh, make everything in half. That way it's easier just to mirror everything. But we still need to keep the measurement. And as you see here, these parts here are just going to be sticking out of this mesh, and it's going to be part of the model. And we need this so the skin of the lip, for instance, will hold on to these so-called lip mechanisms. And we need to block it out to where, that silicone won't go into that socket and lock it up. So it needs to be kind of designed as like a real lip would hold on to that so-called, device. And it's also designed that way, like in the eyelids also. And everything needs to be center. And it really needs to be perfect because this is key. But like all this needs to be filled in and just made sure that everything's, watertight to make one big model. But as you see, I'm just sitting here editing because if it's not on the outside, there's no sense of me even having it, and that would be an artifact, and it'd be show up as error. And I know there's probably software out there that would probably make this a lot smoother. But once again, always there's a learning curve with all softwares. But there's some softwares that do things, and they do it pretty good. But then as much stuff that I do on certain software, which is SketchUp, Blender, ZBrush, sometimes the software don't work correctly, and you have to figure out a way to do it without, you know, wasting a lot of time. I've used a lot of software, and I've just kind of developed my own little workflow on how to do certain things. Back in the day when I was in high school, I took drafting, and we used paper and pencil to design things and compasses, and we had to do it, old school way, and there's a lot of people still do it that way. But as you see here, I'm just editing this chess piece and just dividing it exactly in half. But I've already taken a lot of these measurements just to make sure that everything has to be perfect. But as you see here, this mesh here on the neck, I kind of cleaned it up a little bit, kind of straightened it up because I got to kind of move this towards the mouth chin area. That way you don't really want, like, as far as the jawbone is going to be completely covered. And that's fine, but like closer to the mouth or where the teeth are, which are blocked out as the correct size, because I don't want the silicone to hug the teeth. That way it would kind of make it stick on the teeth or whatever, and I'm trying to avoid that. And it's just like I want like part of the chin to be touching as far as the animatronic chin. I want it to be hugging up against the so-called inside silicone mask. But a lot of this, once again, is I'm just trying to clean up the inside of this this
big mesh. And this is going to be a very big mesh. But here I'm just kind of editing and, just clean it up. Less work I have to do later. But as you see here on the eyes, I'm just taking this whole eye here and connecting it to the bridge of the nose, the eye socket area. And that way, and this goes quick in editing. It doesn't take a whole lot of time. Uh, but I just got to make this all one piece. And when I start the sculpture onto the core, all I want is the outside of the creature onto the core. But I'm going to make it also to where there's going to be holes in the so-called sculpture for the eyes. And those eyes are on the core. So I'm going to transfer those eyes to the sculpture and also the lip hole or the mouth hole area. All that has to be joined into the new part of the core. But then I can remove that so-called mesh or the core mesh away and then add that to it so I don't have to sit there and edit the inside of the core to adapt to the so-called sculpture. And it's a lot of things you get to thinking about it, and it's just trying to make things easier on you. That way you don't have to worry about, because if I made the sculpture onto the core, like you see here, all I'm trying to do is get the skin to have uh, a so-called shell. When it's poured, it's going to copy this. But that will be later when we physically cast the skin. But as you see here, I'm just editing, and what I'm doing is I'm connecting everything, all these parts together. And then I'll go inside and I'll remove any vertices that is making a so-called, artifact. And it can be kind of time consuming, but if I just connected everything, all the pieces without doing this, it'd be a lot more work to do. Molding this so-called animatronic, the sculpture in silicone, this way we can avoid or be easier to avoid a lot of some of the undercuts that we're going to have in this so-called animatronic. And that way we can get the so-called uh, skin attached in only certain areas, and it will hug this so-called this core, which will hug the so-called animatronic like a mask, and then try to avoid any kind of a so-called like raincoat effect where it's too baggy or looks kind of fake, and I'm trying to avoid that. But as you see here, I mirrored it, and this is just a test mirror. And the reason why I'm doing a test is I take these measurements at a certain point of the eyelid, and I'm trying to get the same measurement when I didn't have it before I cut it in half, basically. And I have the same measurement. So we're good to go, and it's going to be all cleaned out on the inside, and it's going to be, you know, a perfect mesh. That way we won't have any errors. But it's coming along. But like once again, I'm going to have to do some other things to the plate, make screw holes to the plate, and get everything pretty much ready. Like foresee what we're going to need to do for the as far as the molding and stuff, and like have vent holes and things like that. And also the vent holes are going to need to be to where the silicone will pour the skin into, because this is going to be this is the main core. But like I was saying earlier, that I'll be able to remove this so-called sculpture or the core sculpture off of this and just use that plate to connect to the sculpture. That way we won't have to do any more editing to it when the sculpture is made. But it's coming along well. It's just, me being ill and having to, you know, take off a little bit from this, but it's coming along, And soon I'll have a new chest piece available for my Patreons. And this it's just kind of a short version of what we had, but this is going to be a key component to where the skin's going to fit on. But I hope this helps. I know editing is kind of boring, but I appreciate y'all. Y'all have a good one. Later.
Hello, everyone. Hope y'all are doing well. This is 3D printed Animatronic Creature Part 29, Core Editing. Well, I've come a long way. Now, a lot of these videos are old, because once again, I just document everything. And I'm just trying to, I'm still under the weather. I'm supposed to hear for my new drugs coming in for my Crohn's and this so-called, I guess it's some kind of skin thing, but it's attacked my hands and feet, so I should have something this week, hopefully. But but this is what I was working on. I'm trying to, finalize the so-called base plate, and for me to get it's kind of a foreseeing what I need to do to achieve this by molding the creature to produce a creature skin that is on this core. And it's going to be poured upside down. So I could go with sprue holes through the whole core itself, but I'm going to try to avoid that. And I'm going to go with more of a sprue method, kind of like some of the things I've done over the 30 years of dental. It's you learn certain molding techniques, which is wonderful. And mold making is an art form, and it's precision. And but if it's done right, it'll work out good. But I mean, I've had failures, probably a lot of other people too. But you're just trying to work this out, especially when it's digital. But anyway, as you see here, I'm putting screw holes to where I feel like they need to be, but I still have, uh, as far as the measurement, to keep the measurement, and then these screw holes are going to be like 4 millimeter screws, and I got to make sure that the 250 millimeter is not crossed. And but as you see here, um, I'm having to remove the so-called block out shoulder area so I can have more space there for the silicone to flow in that area. I mean, it had space, but I felt like it wasn't enough. So it was about probably close to 10 millimeters right there that would give me, a little bit of elbow room, but, or shoulder room. but, but as you see here, this whole, I guess this build platform area here is 250 by 250. So that's my work area. And so I want to add these sprues, and I want to be able to have a big enough spout and kind of a sprue to where it has a reservoir on the top. And that way it'll flow. But in the sculpting, I will make indication points, kind of a cut line, I guess you'd say, sculpted on the sculpture itself to where you cut that sprue off so it'll blend in well, because that's going to be at the very bottom of the so-called animatronic skin. But as you see here, here's the first hole here, and it's roughly, I believe it was around 12 millimeters or so. And but it's going to be, poured upside down, like I said before, and then that way it will flow, and everything is at the highest point. You have the highest point as being in the front, but I could also use these back ones as pour holes if needed. But there's only going to be 3 holes here, and it's going to be in the center chest and these 2 shoulder areas. But so basically just cut everything in half and mirrored everything. That way I can get this so-called, I guess the core base plate. That way it'll be, finalized. It's still not attached yet, but the only thing that I have to do, and I also cleaned out the core, animatronic core itself. It's all clean, and now all I have to do here, as you see here, I've copied this eye, and I'll show you the process. What I've done here, and some of the footage, I do document everything, but sometimes it just don't record, or I forget to press record or whatever. But I copy these eyes, just the eyelid area, to where the skin's going to attach to the eyelid. And that's going to be open, so that's the indication spot to where the eyelids need to stop. So I'm going to place these onto the core, and what I have done is I've transferred just the so-called base plate and the eyes, and the only thing that I have to do next is the mouth area, because it's open too. But I have to design it a way to where the so-called lip mechanism will grab a hold of the lips. But as you see here, since I kind of got the, you know, finalization of the base plate, now I can really concentrate on making this so-called frame for the mother mole. And I'm just sitting here just kind of doing some sketches. Now, this is not final, because I'm going to also add screw. And this is going to be two pieces here too, but it's going to have some more of those 4 millimeters. And I was trying to determine if it would be better to have larger screws and less holes, but and that could be changed, but as soon as I make you know, the core itself and that base plate, that's final. So, but as you see here, I'm just going by from, what I have is the core, but it really needs to be done with a sculpture. So I have a pre-sculpture kind of done that has no detail. It's probably, uh, you know, I can only do so much high poly work in SketchUp, and I like SketchUp, man. It's as you see here, I got a workflow, and I enjoy it, but I can work fast with it. But it's just like I just love the measurements of it all. But as you see, I have to make it to where I'm going to have room for the skin and room for the silicone that's going to be molding of the skin. So that's why I have to, and these frames are going to have a notch inside there also. When it has the shell covering the whole thing, it's going to have a shell cover that has locking points for the silicone to kind of pop in place. So when I stand it up like this, it won't droop. It's going to have something to bond to, and that would be the mother mold. But I can still be able to remove it from the mother mold, but I can still, place it back in. But it's coming along. It's just a lot of it's just foreseeing. But once again, I kind of, I'm not a big fan of narrating videos, but I've done a lot of them. But I just don't like to hear my voice, the southern accent, and hearing myself breathe. This is a cheap microphone and headphones, but it gets the job done. But as you see here, I got two pieces, and all I have to do is just put the screw holes and make sure my measurements are correct. And but I can still make changes after I get a more, you know, I guess the sculpture pretty much done. But and then I gotta add these lips, the so-called core lips, to the core, and then I got to copy that teeth area to transfer to here.
And what I'm going to do is after I get the sculpture done, I will remove the core that I'm sculpting on. Because if I go ahead and try to make that like a big STL file, it's gonna have I gotta edit that. Or you could do one of them. I'm trying to prevent having a skin inside there, so I'll have an error. But as you see here, I just got a basic plain setup what's going to be needed. This way I don't have to do any editing inside and removing all of that core, mesh. This way I can just transfer the sculpture itself and attach it to the so-called base plate, the eyes, and the so-called mouth area where the lip's going to be. But here, this is where I was talking about the little sprue reservoirs to where I'll sculpt a little cut line right there. And that way it will have something to pour into. And I have to, make this so I can have outside sprues instead of inside. And the inside sprue would be kind of long. And that way, if I might have trouble taking it off, and it'll be easier this way to just cut along this so-called shoulder area, and the center chest, the sternum area. But and this is a kind of a higher poly for a SketchUp to be able to handle. But you see what kind of dimensions I'm looking at as far as getting get ready to, I guess, start doing this, detail sculpting on it. But it's coming along. But I'll just transfer this so-called sculpture to this, and then I won't have to edit or remove the so-called core from it. It will already be done because and the eyes itself are already stationary. That's a that's a you know the main point, and I'll do the mouth too. But this is what I got done so far. It's coming along. It's just this is once again this is some older videos, but I appreciate y'all and thank y'all for all the nice comments and get wells but uh thanks for the thumbs up and all the comments. It helps the channel. But I appreciate y'all, and y'all have a great day, and y'all have a good one later. Hello everyone, hope y'all are doing well. This is 3D printed animatronic creature part 30. The first 10 minutes of this video was posted on my Patreon a week ago. So, and then I've added another 10 minutes to this video. Hello everyone. I just wanted to let you know that I got this new chest plate, which is like a neck plate, I guess, really now. Even though it's in the same position, it's just that some of it has been shortened or removed. And that way I can get this in a printer like a bamboo carbon, A1 carbon. But because the build platform is 256, but we need everything to be 250. I don't want to go max out 256, but this is so I can make the so-called core. And then also I can make a sculpture of that. Like I had said earlier, I was going to do this in resin, but I'm really determined to try the bamboo. And even though the bamboo's leading one, I've seen some really good prints come out of a FDM printer. And but if there's any touch-ups needed, we're going to use some clay. But anyway, this is what I'm working on. As you see here, I'm just editing the new chest piece and just building up, giving it some kind of supports and things like that, and make sure I have my clearances and things. This took me, now I have this cheap printer right now, and I have a Ender 3 version 1. It's like 7 years old, and it works great. I got it dialed in great. The holes, and I kind of design everything so I don't have that much as far as supports. Uh, you know, but when I do have them, you know, they come out really easy. And I got this Elegoo, a Neptune 4, and I'm really disappointed in it. But you know, once again, you know, it it's the cost of a printer. You know, even though that bamboo's like, I don't know, 1,400. But I'm not looking for color. I'm just looking for a good printer. I mean, I could care less about color, and I really don't care much for speed. I just want it to be accurate, and that's the whole point of, especially mechanical design. You know, what's the point if it's, you know, I could care less about color, but you know, some people like it, and that's what they like. So, you know, everybody has their opinion. But anyway, as you see here, I'm just kind of like showing. Now, I know y'all might not like seeing a lot of editing and stuff like that, but this is just part of making an animatronic. But what I do here, these supports. Now, I could put more holes in this, but it really wasn't necessary. And but you know, I bring this so-called piece right here that's going to be, you know, a connector piece, and I go through and I highlight these vertices and these little triangles, and I highlight them, and I press on SketchUp, intersect with the model, and then it'll make the line there outlining that so-called piece I just want it to be connected to. But I still have to edit, and then I just drag this hole here, 8 8 millimeters, and it, you know, I have the hole there. So what I do, I just kind of, you know, give it some kind of supports and just think about, you know, I don't want something that's going to be narrow and squared off. Make sure it has some kind of, you know, support and some strength. And, but, you know, this is kind of a fragile piece, but, you know, and, and also that there's going to be some other things added to this beam that goes across that these are connected to. And that's going to probably be more like the controller, and it's a small controller, but I can't really put the controller inside. I want y'all to be able to, you know, reset or press any buttons. You know, there's a reset button, I believe, on this one too. Or, you know, if you have a loose wire, you could actually get to it without having to remove any skin or anything. And but as you see here, I'm editing, removing all these, you know, what needs to be removed inside to make it watertight. And then the centerpiece is just one screw that, you know, that comes in. You just put the nut down. But as you see here, the only thing that's different is these beams. And these long beams they're 6-hole beams. As you see here, they're connected. They're connected to the end of the long beam. But we're going to remove that letter. But here's the print, and it's been reduced a pretty good bit. But, you know, this is something, you know, we had to do. But, you know, once again, it came out good. Now I just want to remove this piece right here. I'm going to take it out of this vise. And the vise there is to keep it stable. And later on, we're going to design something so we can put this in some kind of frame or a piece of nice wood, you know, as far as a table support to where it looks good, like it's some kind of, you know, a base, a good looking base. But I just remove it easy, and now mine's connected. Now those servos y'all don't have. Y'all ordered other servos, and the reason why that is, I had to. It would be hard for y'all to get. This company doesn't even have a website. They're more like for people that, you know, uh, distribute servos. But this is my hands, y'all. This is what I've been dealing with. Now, it's healed a lot, but my hands, I had all these, I felt like I had fiberglass in them all the time. And they would crack open and they'd bleed, and it was kind of embarrassing. And that's another reason why I ain't filmed that much. But they were hurting, and all my knuckles were
infected with this so-called skin rash thing, and this is all because of my so-called shots. But side effect. But they got me on another drug coming, and it is healing. Now my feet are really bad, but they're a lot better too. My left foot's completely healed. But anyway, these are the beams you need to move. You need to move them to the second hole on the long beam on the right left side. They need to be moved to the second hole. But and then you just screw them from the bottom. As you see here, they're connected on the end. So we're going to remove those screws. But on the long beam, these 6-hole blocks are moved on top of that long beam. When I say top, when it's vertical. But you just place it, and you just place it on the second hole on both sides. And you'll see here. And I just screw it in place. But it's coming along, and I had to shorten it, but I did some tests, and it seems like it's going to work well, and this way I can finalize the core now and just get everything going so we can start sculpting this creature, this alien / creature or whatever. But what you do, you just, now mine's already set up with all the components and control rods and things. And now all you have to do where the space is, where the first hole is, it just lays upon that one. Now I only have 3 screws in there. You can use 2 or whatever, but 2, one on the top, one on the bottom, or all 3 if you want. But I'm just going to put 1 right now for demonstration. But they just snap in place, and I'll just tighten this nut. But no, I'm slowly getting back into. I want to start filming now. I was going to start wearing some gloves. I'm going to get back into doing the mouth setup on how to do all of that. And, as far as the building of the animatronic, more details for y'all. And but it's just been kind of a crazy time right now for me. I've never had this happen to me before. This is something new. This so-called having a reverse reaction from my Crohn's medicine, and man, it stopped me like a wall. But anyway, I'm feeling better. Appreciate y'all. Hope this helps. And as you see here, I got clearance still, and everything's working good. So I'll have this STL file on the engineer on my Patreon. So hope y'all like. Now this is the new part of the video that I've added to this existing video here, and this is me doing the finalization of the core. And as you see here, I'm just adding meshes to it, mirroring it. I actually do the editing part on one side, and I just transfer it to the other. But as you see here, it's all cleaned out. Now it's final. This is final as this part here. But I have to add these moving parts to the core also, and so they can be printed. And then we're going to have to add the skin to it, and then that will be covered with the skin. And then that will, when I pour silicone, those will lock in place and surround those moving mechanisms to be a socket inside the skin, in the back of the skin. So this is just me just doing some editing, and I've edited a lot of this out so y'all don't have to see it. But once I add these pieces in their place, I have to come back inside the so-called mesh and just edit all this out, make sure there's no artifacts in there, because if you have anything inside of your 3D print, it's going to try to print it, and that's when you do a test, it's going to have an error, and probably 99% of the time that's what the error is. But here I'm just checking to make sure I don't have any more artifacts, make sure that nothing's there, just cleaning the whole, because this is one large piece. Now here what I'm doing is I'm getting ready
to make what I call a sculpting canvas. And this is what I'm going to be sculpting on when I get everything set up so I can start sculpting the skin. And this mesh right here is what I've kind of come up with. It's a low poly version, and I'm just going to remove these vertices and triangles and kind of get some clearance here so I can add these eyelids, which I've done a copy and paste of the eyelids. And then as you see here, I'm going to have this where I'll raise these eyelids forward 1 millimeter. That way I'm going to attach it to this so-called skin, or this canvas I call it. That way that part will be pretty much done. And as you see here, I'm doing the socket here, doing a mesh. And see, it's easier for me to come in Blender and do a lot of editing with the so-called mesh or vertices or whatever, and I can just transfer this into SketchUp. And I use so many different softwares to achieve this goal, and a lot of it's because it's free. And another thing is that I can't edit like I can in Blender in SketchUp. So you kind of juggle, and it's the workflow of juggling these things. But as you see here, I'm going to raise this out some. I believe it was close to 3 millimeters, I believe it was. But all this is going to change because I'm going to change the so-called, or I'm going to remesh the entire this skin canvas. I'm going to put it through a process in ZBrush where a Z remesher, where it just it rebuilds everything, even though I have a bunch of triangles here. And this is what I see as a STL file, but the STL file being exported or imported into SketchUp is still the same size. Now you really can't do it with an OBJ because there's no size or unit. It's just the same. You'd have to make it too many adjustments to get that accurate. As you see here on the left side, I have it all set into the sculpting canvas as far as the left eyelid. So, and what I'm going to do here, this is critical of the whole process of what we're doing, and that's measurement, but a measurement key. And what I'm making here is a 10 millimeter cube, and this is perfectly 10 millimeter cube all the way around. And then I'm going to take it and I'm going to attach it to the so-called core, and it will be removed later, but this is just to keep my measurements and my placements accurate. So before I put the placement key onto the sculpt, I'm going to bring it into Blender, and I'm going to do some minor adjustments to the sculpture itself. And I just basically export it as STL file into Blender, and then I already have the so-called core, and I'll just make adjustments to the so-called low poly skin here, and then that way I can transfer it to ZBrush and start getting ready to do the final remesh of this whole low poly, and kind of clean up some of my editing and things like that, which is okay, but I like it to be clean and mirrored. So basically I'm just looking for any protrusions coming from the core that's poking through the so-called canvas, just making sure. And then basically I do a check, make sure it's looking pretty good here, and then I'm going to just import it into ZBrush. Before importing it, I'm going to do some adjustments on this creature's lips because I don't want it to have that smile look. So I'm just going to move it more of a natural looking. And I just don't want to go too far and interfere or go through the so-called lip movement areas. Just keep it kind of short. But once again, when we get into sculpting, I can, actually sculpt lips and things like that. But now this is it smooth in Blender, and then I can adjust it. But I rather keep it just like it's original, like this. Now this is in ZBrush now, and I'll go into ZBrush, and I'll do the Z remesher. And Blender has one called a remesh, and I'm just not really too keen on it, and that's why I prefer ZBrush. But as you see here, I'll do a mesh twice, remesh it, and add more detail to it, or up the resolution, and then I'll reduce it again, and it will just clean up any of the work and make everything pretty nice. But then after that, I'll do another import as STL file into SketchUp. Now you'll see the pour spouts, or the vents where I'm going to be pouring the silicone skin into that when it's upside down and the mold's made. I'll be able to place, and I actually did it in SketchUp in CAD, to where I made like a reservoir on top of each one of those three pour and vents. But as you see here, you can kind of see the thickness of what I'm dealing with, and this is just an X-ray in SketchUp here, and you can kind of see it, and it's looking good as far as a canvas. But then I'm going to have to make adjustments when I'm sculpting. So now what I'm going to do is I'm going to make 2 more of these 10mm cubes for a placement guide, and just a measurement guide, just to show where everything needs to be center. And I'll just lay each one of these on top of other, and some of them look different, but mainly is when you put 3 cubes together and they're all the same size, I have to have these lines or little shapes connected to them. That way I'll have something to grab when I separate each one of them. But once again, as you see these green reservoirs right here, that's going to be where I'm going to be pouring. After I make the mold pour, I'll be able to pour the silicone skin into that so-called vent hole, and that's going to be able to fill up the silicone for the skin. But as you see here, I've connected that placement cube at the top, and also I have these so-called eyelids in the mouthpiece. And the reason why I'm doing this on another core, because after I get the sculpture done, I can just transfer the sculpture to this so-called base plate, and that way I don't have to edit inside of that or do that bowling, and this way it's already going to be clean. But that's what I have so far. And what we're going to do next is I'll be able to transfer the skin into ZBrush and start doing some detailed sculpt. But as you see here, I'm going to make this the core, which is now final. Now, don't get me wrong, I'm not going to print it until I have the sculpture done and make it, because I just don't know if I might need to make any adjustments. But as you see here, I can do a cutaway in SketchUp so I can see my thicknesses, and I'm just checking it according to what I have as far as the canvas now. And then I can just do my sculpt to that. But this is what I have, and this is what I'm coming up with. Next, I got to make sure I can get ready to make molding parts too. But I hope y'all like. Thanks for the comments and thumbs up, and all my subscribers. Later. Hello everyone. This is 3D printed animatronic creature part 31 sculpt testing. Now, I took the canvas into ZBrush and I started just doodling. Now, it's something quick. I just wanted to do some testing, see if I can get my measurements right, and testing on, ZBrush and Blender and SketchUp. Now I do these little doodles on these sculpting, just kind of not get too high poly, and just see what I can do. If it gets too high, I can do that decimation in ZBrush. But as you see here, I'm just doing some testing with some sculpting. Now, this is not complete, so just bear with me there. But I'm working on it and just trying to keep this thin, but not too thin, and surely not too thick. But here I'll just testing on so-called nose, make it a little bit different looking, and this is like a kind of an alien hybrid thing, and I'm not going to put any kind of a ear lobe or anything like that. And this is going to help in the mold design too. And that's going to be like later on. But as you see here, my thickness is still kind of thick here, but I want to bring it into Blender. And I'm just checking, I'm double checking all the core things and stuff. And when I have this transferred into the other core that doesn't have the animatronic on it, it just has the eyes and the eyelids and the so-called mouthpiece. And just making some adjustments just to see if I can put this into SketchUp. But I go back and I do that decimation to where I reduce it because I'm up there in the 2 million area as far as just to reduce the polygons. Because, in printing this, I mean, you can print pretty large files, but you are limited on what kind of slicer you use. And I mean, you can go on up there pretty high, but my main thing is right now is I'm just trying to, get this going as far as measurements are going to be correct. But as you see here, my core is correct. It's 250 by 250 by 250 according to what I did a STL file of the core into ZBrush, and it recognized it being that large. And once again, ZBrush don't like anything too large. You got to make adjustments to your brushes. And once again, I'm no master at ZBrush. I mean, ZBrush is a pretty huge program. And as far as Blender, you know, I've done a lot with Blender, but I'm I'm not a master at any of these software. I don't claim to be, but I've just put a lot of work and learning these as far as my workflow. But as you see here, I mean, this is in Blender, and see, and in Blender they don't like large things too, and you got to so-called up the, I guess the whole frame of things um, to where if it's too large, it won't appear. You have to make adjustments to the so-called visual look of it. But I was able to import it into SketchUp after, reducing some of the polys so I could see this. And but it's coming along. But I just wanted to show you this. Now the canvas is still on there, so I'm just comparing the canvas to the sculpture. But as you see here, I'm going to move this the canvas and put it back in its position. But eventually I'm going to have this all worked out where the canvas will be available to my engineers on my Patreon, and then they can sculpt what they would like to sculpt on it as far as their creature if they would like. But my main thing is that we got to make sure that the thickness of the silicone is the right thickness. You cannot have it too thick. Now you couldn't put a muzzle on this because it's not matched up to the so-called core. You're still limited on what you can sculpt on this because the skin is going to be soft, but if it's too firm, it's not going to move it. It's going to have the raincoat effect. And this is what I'm trying to avoid. I want a realistic looking creature. And I'm going to show you what I've done here. And then when I do a cutaway right here, you're going to see the thickness of the mouth area, and it's going to be somewhat too thick. And I'm checking these things just to show you the thickness.
And this is roughly like 5 millimeters thickness, if not a little more, on the top of the head. And I'm going to want to reduce that too. And as you see the thickness here around the brows, a lot of this can change, but right here around the lip area, upper lip and the lower lip, need to be reduced because the skin's going to be soft enough where it will be moving the inside more than it would the outside. So I'm going to make adjustments to that. But the key is the skin. Now, no printer can print the skin. It's too soft. And I'm going to show you some of the skin right here. And someone commented the other day about skin being printed, and it's not going to be printed. And the reason is because the skin that we're going to be using is going to be way too soft. Now, I've done a number of tests on skin. Now, this is dragon skin. Now, this piece right here is going to what we're going to be using to mold the sculpture, so we can cast the skin into this. Now, the other skin that I have in my hand, which is this dragon skin 20, and the 20 is standing for the shore, and that's the softest of the silicone. Now, the mold material, the blue one, it's a shore of 30. Now, this is also dragon skin. It's just too thick. Now, we're going to be using a skin called EcoFlex 10, and it's really, really soft. Now, you could realize that there's no way to print anything like this. Now, maybe later on we might be able to, but not now. But you can see the flexibility of this being more like human skin or natural skin, and it has a good flexibility. And this is why you need to hug the so-called core well, and then it's going to hug the animatronic correctly to give a more realistic look. But this is what we're going to probably be using. Now, there's other silicones available. I mean, this is Smooth On, and then the other brand is Polytech, and they have a lot of good silicone also. But we're going to be using, uh, products from Smooth On. But I just wanted to show you that how this skin is gonna has to be, because if you go too thick, it's gonna have the raincoat effect. It's not gonna look realistic. It has to be soft, and the thickness is the key. And these thicknesses here is anywhere from 4 to 3 millimeters. But but what I did here, this is what I'm working on now. I brought the sculpture back into ZBrush, and I made some some changes to the lip. As you see here, I I did in the sculpting program in Blender. I pushed it down some, the nose area, to not make it so thick. And then after I did that, I brought it back into SketchUp, and I'll show you the big difference here. But I'm able to manipulate this by going back and forth between SketchUp and Blender. That way I can make adjustments even when I set this as far as the mold part. But as you see here, I reduced the thickness of the lip and even the lower lip too, because I actually wanted to capture the lip itself, because that way it can pull it up. But I still need to make adjustments to the back of this. Now, once again, this is not the final sculpt, but just to show you that there's going to be some areas here that's going to need to be thicker, because I don't want it to be, 4 to 5 millimeters would be fine in the back. But overall, it's coming along, and as far as testing, this is really helpful. I'm planning on upgrading my computer because I could probably get a lot more power out of the computer to be able to work on some of this, SketchUp being CAD. But as you see here, I can get in different angles to look at my thicknesses, and that will help also. But once again, I'm also working on editing tonight the Patreon video on how to put the mouth part of the animatronic together, a little bit better video for my Patreons that are engineers. But look, I hope y'all enjoyed this, and thank you for the thumbs up, new subscribers, and the comments, and it really helps the channel. But thanks a lot, y'all. Have a good one. Later.
Hello everyone, this is 3D printed Animatronic Creature Part 32, Sculpting Canvas Rim. I hope y'all are doing well. I'm just going to show you what I've been working on. This is just making adjustments to the sculpting canvas that where uh, where the creature is going to be sculpted on. And there's this rim on the chest piece that I want the silicone to make a flange or a rim or a fold over kind of a locking mechanism for the skin to, to just roll over. That way it'll just be locked in place there. And to make this so-called flange, it's already on the core. And when I pour the silicone, it will go underneath there and it will be hugging that underneath part of the chest piece. Well, I'm trying to do this part that way I can connect it easily when I make the sculpture, and that way it won't be me trying to go underneath it and, remove any, artifacts inside this so-called, you know, base plate. So what I did is I kind of made a partial rim around this. And these red parts here are the reservoirs for the silicone. Now, they're not on the core, but they're on this part. And whatever is on the sculpting part is going to be transferred to the mold. And when we pour the skin, that's going to leave a space there for the silicone to travel through when I pour the silicone for the skin. But that's after we make the silicone mold itself. It's considered like a spacer. So whatever is on this sculpting base or base core of the creature here is going to be transferred to the silicone mold itself. But even these pieces here, I'm going to have to, you know, connect to the to the creature so we can get this molded. So what I'm doing here, I'm just kind of trying to match the height of this rim and matching it to this rim. And so people might think this is overkill, but I'm a planner and, you know, this is, maybe a couple of $100 worth of silicone and I don't want any failures. And this is just part of it. I enjoy mold making. It's an art form and I'm, I like being kind of precise with it, but anything that I add on here is going to be the reservoir for the silicone when I pour into this. And anything on the inside of this needs to be removed. So there's no any kind of a hole or anything as you see here, or a bent hole or a pore hole. But all this needs to just be sealed up watertight. And sometimes when you're doing this kind of design work and you get to thinking, now, do I need this or is this right? Is this going to work? You get kind of you're seeing things like from the inside when usually it's on the outside that you're working on. But as far as doing this mesh here, and I'm adding these vertices and these lines and triangles and things, it may be harder for me to do it later if I had to do the rim when the sculpture is done. So I'm going to try to add this to this base plate here so I don't have to do it later. Now this base plate here is the sculpting core, I guess you would call it. And these reservoirs need to be on the thick so to give me an airflow and a pore flow. But this has got to be connected to the rim so we can pour the silicone. And I'm just trying to get everything pretty much precise to where I can cut this away with scissors as far as trimming the skin after this has been done. What I'm doing here is just really connecting the reservoir to the rim itself. That way it will get a good pour and airflow as we pour the silicone, and everything that's inside this mesh is going to be removed so it'll be watertight. And then now I'm going to just copy half of it, and I've only worked on half, and that way I can just mirror it and flip it on the red axis and then connect the two pieces together. But on mirroring, you have to be careful because it can be off a little bit, but you just have to make sure that it's cut correctly. And that's why this line is always center. And then I can just clean it up and connect the two pieces really together. And there's some places that I might have to change, but anything that I change on this green area will, you know, be different in the silicone. And I'm just trying to avoid, because this is pretty much the bottom part of the key of the mole. But I did all this mirror by bringing in the piece inside another SketchUp window. That way I'll have, I guess, more memory to work with. As you see here, I made the measurements 250 by 250, and so it's correct. So it matches up to the original core base plate itself. So now I have a new base plate for the sculpture itself, and with a flange already there. So now I don't have to worry about, all I need to do is just, when the sculpture is done, is connect it to this flange. But first I'm going to take the very first sculpting canvas here, and I'm just going to remove some of these faces and vertices. You can do this mesh editing like you see here I'm doing it in SketchUp. But once again, I like SketchUp because of the measurement. It's more CAD-like. But you can do it in Blender, and you can also do the editing in ZBrush. But I'm just removing these vertices and kind of keep it like in a mirror shape, and I'm trying to get it really close to that new edge or that new flange area. That way, when the sculpting's done on this canvas, I can just easily transfer it, and more likely it would go into Blender to do that, because SketchUp won't tolerate too much as far as higher poly. But I mean, it's getting pretty close, and maybe if I updated my computer, I could probably handle a lot more. But what I'm doing here is I'm doing a coloring to where I've made the I guess the border where I'm cutting, and I do a copy and I mirror it, and then I just kind of see a guide what to remove to keep this in its right shape. And then I'm going to do the back of it here and just remove it and kind of round off these shoulder areas. And then I'm going to bring this back into Blender, and that way I can, in the sculpting in Blender, and kind of bring this closer to that flange. I hope that when you see this, that this shows you that you could make your own animatronic. You could design your own creature, your own teeth. I mean, it's a process, and it can be somewhat tedious, but yet, that way that any kind of a creature that you would make, you could make it become alive, kind of like, Dr. Frankenstein. But we can always enjoy making creatures and animatronics and things, and the sky's the limit. Just all depends on how big our printers can get that are dependable and accurate enough to do it. But as you see here, I have this canvas pretty much done, but I'm still wanting to bring it into Blender so I can bring in that flange of the canvas closer to the new flange on the base plate. So I'm going to import the base plate with the new flange on it, into Blender, and then I'll just get rid of the old part, and then that way I can just kind of show you here is when I bring in the core into the new uh, base plate here, and you can kind of tell that it's matching pretty good, but the only ones that are not having any kind of reaction is one with the reservoirs in it, because that's the space where the silicone's going to be poured in. So I got the canvas in place, and I'm just going to slowly just kind of sculpt it close as I can to the new flange rim area, and that way it'll be easy after the sculpture is done. I can connect vertices and faces to this empty space rim here. Instead of doing it like a bowling or a join, or that way I don't have to do any kind of cleanup or of any sort later on. And so here's the new canvas, and here's the old canvas. So now I'm just going to let you see how close I got it now by just doing that. And a lot of this doesn't take a whole lot of time to do. It might seem like, even though I might have shot maybe 90 minutes of footage, and some I might have forgot, or just because you're just only seeing roughly less than 15 minutes of this process, but it doesn't take a whole lot of time to do this. Now the canvas is done, so now I can resculpt or just start sculpting a new creature on this canvas. And as you see here, here's the older one, and I'm just going to go ahead and delete this one, and then I can start fresh and have a new creature, and more likely that's what you will be seeing on the next video. I hope y'all like. Thank you for everything, and the subscribers and the comments. Later. Hello everyone, I hope y'all are doing well. This is 3D printed animatronic creature part 33, mold designing. Now in a previous video, I think it was part 29, where you saw me kind of making these frames for molding. Well, now it was kind of time for me to sit back and this is pretty tedious work here. I mean, I put about, I guess it was 6 hours of video that I shot, and it just, in a nutshell, just show y'all what I was basically doing, and having to design these where this is going to be a mother mold to where I can pour silicone in these molds with it's going to have a divider, so I'd have to pour, the back first, and then I'd come back and pour the front part second, and it's a lot of designing, and you have your flow levels, because you don't want to put, like, your vents in the wrong place, or your pour spouts in the wrong place. But here I'm putting screw points in this frame, and y'all had seen the frame in an existing video that I done, part 29, and I had done some previous other tests, just testing these so-called theories on how to make this mold. And mold making is an art form, and I really enjoy making molds. But as you see here, I'm putting the screw points because this is going to have to be, I guess, bolted together with 4mm screws and with washers, just to give it more strength when I'm tightening uh, these bolts and screws in place, to just hold the frame and to hold it to the base plate, and just to be a good solid structure. But after I did that plate, the main new plate on the back mold, I just copied it and pasted, so I can just transfer it to the front flat edge of its mold, and we'll have the same, flat edge with the screw points. So all the screw points will match from the front frame to the second frame. Now this molding design here, it needs to be robust, because it's going to be holding silicone for the molding of the skin. Plus it's going to be holding the skin. So it needs to be kind of robust just to hold. And what I'm working on now, these two frames would be considered the mother mold that will hold this together. And you really don't want it to be able to come out or come off out of it. It's got to have its own kind of a socket for this part of the silicone to fit inside this frame here. It will be able to be removed from the frame, but it will be able to go back in place and lock in place. Because I really don't want any of the silicone, even though the shore of the silicone is going to be a 30 shore, and the thickness should give it the strength to keep its shape. So, because you really wouldn't want it to sag at the top, or if you poured it, if it sagged a little bit, it could be bumping. If it was too soft, it would be hitting the core, and then you wouldn't be able to pour your skin. But what I was doing with these screws here, I, I made these screws, and then I was calculating that, well, I'm going to have a washer to go on this too, just to, you know, to give it more strength there. So when I'm tightening these nuts down, it will hold that frame in place. So what I did was, is I made a little, I guess, an extrusion to where I know that that's going to be clearance for the screw and the washer. So what I wanted to do is put those there is when I put this mesh that will, the main structure of the mold itself, and there's going to be uh, a front mesh and a inside mesh, and that's just going to be a heavy duty structure just to hold the mold, just to give it strength. So here I'm just making this extrusion here for the back mold, and I'm just going to keep recreating this. And then after I get the meshes, the two meshes on each frame, I will just mirror these two together. So that way I only have to work on one side. Earlier when you saw me doing some design work in Blender, when I was putting that mesh in there and I was kind of designing around the screw holes, I just really didn't have any guide to determine, you know, that I, was going to have washers with those screws. And that way I need to make some adjustments to where I can lay that mesh on the extrusion. But like here, I'm designing meshes, and here I'm redesigning this mesh here, as you see, and I'm doing the inside mesh first. Now I won't connect the inside till after I get the sculpture done. That way, if I need to make any adjustments to it or the inside frame, I can do that. But I I basically have a shape of the creature, and I'm just trying to get a lot of this done instead of waiting till after I get the sculpture completely done. This way I can keep all the parts going at the same time. Here in Blender, to make cuts, I use a program called Box Cutter. It's a plugin for Blender, and it works really well, and it works better than SketchUp. And sometimes it really doesn't cut well in SketchUp, and I do prefer this. But once again, it's just trying to work with multiple softwares because you get where, I guess, in a way, spoiled for, like, I love the measurements of SketchUp, just love it. And it's just hard for me to choose another software. But, in the measurements in Blender, I don't really care for. But as you see here, I'm just modeling. See, this is a flatter edge on the inside of the mold. And as you see here, I'm just sculpting, just moving the mesh around to fit that that open area there, and just match it up to the frame. So then that way I can just import this mesh into SketchUp, and then I can connect it to the frame. But as far as this, I'm having to make it higher poly. But what I did here is I just copied the existing inside mesh, enlarged it to fit the outside mesh. So that way, I'm just doing this back frame, I guess, corner, but I'm going to mirror all of it, and each, like the front frame will be mirrored and the back frame will be mirrored, and then that way I only have to work on two separate pieces. But it's coming along. It's just kind of tedious, this was, because as you see here, I'm just kind of trying to form around these little extrusion areas here, and that way I can give space for the screws and clearances and things. Just make sure that it just goes in place correctly. But once again, it's just a process that I'm, making sure everything is kind of in its right position and make sure I have all the clearances inside. But as you see here, my meshes are really high poly on the outside of the mold, and I I believe what I'm going to do is reduce it, and you'll see later where I have reduced the number of polys on the outside mold meshes, because it just gives me a lot more work to do. But uh, but here's my clearances as you see here from this cutaway. But and I should have plenty of space for any detail on the sculpture. But once again, I'm not going to attach the inside mesh to the inside of the mold until I have the sculpture complete. But as you see here, the dollar, it looks bigger when you're working on it, but when you put a dollar on there at a measurement of 156 millimeters, it's a lot smaller than what you think, but it's coming along. But as you see here, this mesh has not been fitted yet to the extrusion where I have there around the screw points. Now, when eventually I print these pieces, there will be three pieces: the core and the two mold frames. And I will probably do a wall thickness pretty high, and an infield is also pretty high, because I want this thing to be strong. Because I'm going to have several screws and washers connecting these three pieces together. But once again, this whole mold thing has not been completed yet, because I still have to connect all the pieces together, and then I have to mirror them. And then I have to add the pore and the vent holes to each one of these frame parts. Once again, I hope this helps, and just to show you what you'd have to do to make a good skin for an animatronic. But it's in the design works, and I hope I get these pretty much completed next time I make a video. But I appreciate everyone, and thank you for the support, and thank you for the likes and comment. Let me know what y'all think. Y'all have a great one. Later. Hello everyone, I hope y'all are doing well. This is 3D printed animatronic creature, part 34, ZBrush editing meshes. Well, what I've been doing is on this project is I'm getting ready to, connect this to its own base plate as far as the sculpture canvas. And there's certain things that has to be just right. And see, and when I'm wanting to bridge these pieces, like the mouthpiece and the eyes. And as you see here, the eyes are on the core, and this is going to be what I'm going to be bridging to the sculpture. And this has to be perfect and cannot move. Like, for instance, these eyes. Now, if they wish to move back just a little bit, or the mouth, well, that would throw the mold that I make of the sculpture off for the core. The core wouldn't fit right around the eye area, and then silicone skin would leak into that, and it would mess things up. So once the sculpture is molded, the eyes and the mouthpiece, or the mouth blockout, and the base plate is one large key. So when I insert, the core is going to fit perfect, exact. It's like that's its marker. But I've been working on that, and then I've been working on bridging. Now, ZBrush has a form of bridging and also Blender. I like Blender's, uh, bridging better than ZBrush. And don't get me wrong, Blender's great, but it's a lot to learn. But the first thing I wanted to determine on how big this file, STL file, is going to be. Now, on the highly detailed canvas, as you see here, I brought it in the Blender as an STL file just to see how big it was. And it was a little over 100 megs. And, I was just trying to figure out how big can I go without it being, non-necessary to print. If it was like 400 megs, I mean, could you print? But then you got to also think about, you know, like my computer, you know, I do have problems when I push it, and I can crash it being, too high resolution. But I've done the ZBrush, decimation, but then I got where I didn't do that anymore. Like as you see here, I'm putting the detail on, and then I'll do a Z remesher, and it'll cut back on some of the polygons, and it'll also make the STL a little bit smaller. But I'm not going to be making it too small. I mean, it's still going to be close to 100, but I might be able to push it maybe to 100, but we're just going to have to see after I get everything bridged in. But as you see here, I'm working on these polygons right here and trying to get it to where I can create a bridge point so I can do the bridge into ZBrush. And for me to create this bridge, I need to remove some of that block out of the mouth. Now, and there's going to be some removed off the eyelid area also because like in the mouth, it does an inside fold, and I want that inside fold crease to be the bridge, and that's what I'm trying to do now. And it's kind of like sculpting the inside of the mouth. That way it will be more like a lip instead of just a flat laying down on that mouthpiece or on the inside of the eyelids. And as you see here, I've done the remesher in ZBrush again to kind of clean up any editing. But what I've done here to just show you a demonstration, and you'll probably see this later on again, but to demonstrate the bridging of the edge loops, what I do is I highlight this canvas and I'll just capture, the bottom edge, and I'm just highlighting the edge loop, and then I highlight the edge loop on the base plate. Now in Blender and also in ZBrush, I would recommend turning off symmetry, and there's no symmetry in right here in Blender, but I'll just turn it off and then I'll hit Bridge Edge Loop. And as you see, it cleans up and it does it automatically. It really, I was really impressed when I did it with Blender, and I've used it a few times before, but in this case, it was really important that I would do this because I want to keep that base plate and the canvas kind of separate, but as one file. But after I get everything edited just right on those eyelid eyeballs and the mouthpiece there, I'll do the exact same thing, edge loop, bridging on all the pieces, and then we can have this, a clean mesh, no artifacts inside. But once again, this is what else I've been doing that I wanted to show you. You know, I've been working on a baby animatronic, and a lot of the stuff is I'm just using measurements with calibers. Well, my dial maker sent me her 3D scanner for me to test around and let me see if I can fix this baby because the dilemma is here, even though I can take measurements and caliber measurements and I can get everything as close as I can by even taking pictures of the baby and getting it, but it needs to be a little bit more accurate than that. And see, and I had a core and I got her to sculpt on the core. So I cut the sculpture in half and just scan this so-called baby, and then I have the existing uh, core that I've already made that's from the copy of the baby animatronic, but I need to make adjustments to fit her sculpture. But I don't want to sculpt the baby, I want her to sculpt the baby. So this is kind of the old school method, but I'm trying to put the two together, digital and you know natural sculpting together. So I scanned the model. This is actually the first scan that I did. And it's kind of a, different feel. I know probably some of y'all have scanners, but this is my first test and it did bog down my computer. And I would recommend having a little bit more, powerful computer for scanning. But I cleaned up this so I could make, you know, uh, just get my correct size to create a skull with this baby design so I can make a proper uh, core for her to sculpt on, and then everything would be like, actually putting a skull inside of a, baby skin. This digital scan will help me go to the next level to where the skull that I have on my baby animatronic now, I can manipulate this skull now on the digital design that I have with the new digital scan. That way it will match her future baby shape. I guess you could say it like that. And once again, the digital scanner is a wonderful tool. If you're a traditional sculptor with clay, you could scan it, make a 3 to 5 millimeter shell inside, and then you would produce a skull with that thickness. But then you could scan your own face and do a 3 to 5 millimeter thickness, and that would represent the skin. But then you'd have your skull thickness, and then that space left over would be for the mechanics and all the servos. But then you would have your measurements to the space between the eyes, or pupil to pupil measurements. But there were some things, and this is just from the first scan test that I've done. But I've been thinking this for some time, what you could do with a digital scanner, because it's still all about measurements. But my doll maker is a really good sculptor, and I want to keep it where she is the sculptor of the baby, but I'm wanting to make sure that my skull, that's the animatronic skull that's inside her skin, will match the inside of her skin. And this is the whole key. But as you see here, I'm doing a lower poly version of this right here. And it turns out really well. It was a remesher and ZBrush. But as you see here, I did a number of tests with different kind of cores from the pre-existing first animatronic I did as a baby. And then I made the core. But as you see, this is the new scan. So now I'll just reduce the size of this our copy, and reduce the size, and then it will create a shell as you see here. But then I can just once again put this on the skull that I have already, and then now I know what I need to manipulate to make this fit, and it'll be more accurate. Well, once again, I hope y'all like. It was a fun test. Another way to do an animatronic. But I appreciate all the subscribers and the comments and the thumbs up. Y'all have a good one. Later. Hello, everyone. Hope y'all are doing well. Sorry I ain't posted in a while. Been involved in other projects and been working on this, making the molds. So let's get started. Where I left off on part 33 is making this mold, but this is the back part of the mold, and I'm going to give it a little bit more room back here for the back of the sculpture. So I'm going to add like maybe 4 millimeters thickness here, and I'm going to extrude this away to where I can just open this up some. But this is part of the design just to make sure I have enough for the silicone pour to pour in there, and it's, just to give it enough room. And I'd rather have, a larger mold than, not enough. And that's just to be on the safe side. But as you see here, I extruded it away. And now I'm going to add the inside piece to this mold. And it's going to be a thickness close to, uh, probably close to an inch thick here. And maybe a little less. But, I'm just trying to get it. Now, when this is printed, it's going to be, heavily infield because it needs to be able to support, since this is going to be the mother mold, it needs to be dense enough to support the silicone. And as everyone probably here knows, that silicone is quite heavy. And when I 3D print this, is going to be, once again, it's going to be durable because this is the mother mold, and it's going to be strong, and the layer line or the layer thickness is going to be quite thick and a lot of infield. But as you see here, which I'm in Blender now, and I'm manipulating this mesh here to conform closer to the edge of that inner mold edge. And in this part, I'm not going to be able to do an auto bridging but this frame is more like I guess you would say, a hard surface shape in a design of a CAD. And it's kind of hard to get edge loops on this. But doing bridging, you know, manually, even though it might take some time, it really doesn't take that long at all. These two pieces that you're about to see in the video probably took me less than 2 hours to do, and I'll be putting 3 pieces all along. Y'all had seen the first part I did in 33, but this is to finish this up. But once again, when I get the shape in here just like I like it, and I feel like it's even enough, I'll just export it, the mesh itself, as an STL file back into SketchUp. So now we're back in SketchUp. Now I'll just check the mesh, make sure I got it even enough, and sometimes I might remove some of those polys there I just don't want no I guess indention around this. I kind of want this smooth, but yet I still want this to kind of grab the mother mold where it's not just going to fall out. But as you see here, I'm starting to do the bridging and just, connecting the vertices and just, bridging it all together, which doesn't take long, and it's kind of to me, this is relaxing. I've done it so many times, and just trying to fill in the space, but just trying to keep it, you know, even and trying to make sure that I have clearances, especially around on the outside. You'll see later when I'm going around the where I place the screws, the bolts that bolt the mold to the core itself or the sculpture core. That way, I'll have clearance for the screw, so it won't. The head of the screw won't bump the edge of it. Now I'll do the exact same thing to the front part of this mold, to where I'll reduce the polish to the inner skin and the outer skin, so it will produce the shell. And then later on, when I print this so-called the shell mold, all this will have a really high infill count, so it will be really strong to hold the silicone mold. But I do the exact same thing as far as doing the bridging and connecting all the vertices to finish out this half of these two molds. Now the next step, all I'm going to do is just get everything prepped. But as you see here, the thickness and all this will be having the infield here, just to give it a lot more strength to be the mother mold of the silicone. Here I'm doing a plane cut, that way I can just divide it exactly in half. so I could do a mirror. But you know, and I'll clean out the inside of the inside to remove any polys, you know, to make it watertight as a 3D print. And that way I won't have any errors when I make it an STL file. And here to mirror it, I'll just highlight that component and then reverse it, and then I'll explode both components and they'll automatically join together. And now I'll just repeat the same mirror process on the back, or the yellow piece as you see here, and just do another mirror and then join them together and make sure everything's cleaned out on the inside mesh. That way it'll be a clean STL file. And when I actually mold the creature, I'm gonna probably at the flat edge, as you see here, there's no key or groove right there. I will probably mix a small amount of silicone and just like brush it on the flat side, and then I'll join the two pieces together. That way I will create my own gasket, and I'll just let that part just set up, and then I'll do the molding as far as doing the pour. Now I'm just designing the pour hole and the vent hole in the highest point of this mother mold, and this is where I'll pour the silicone, and I'll have a vent also so it will pour more freely. But once again, it's at the highest point, because when I pour this, this part's gonna be laying down. And once again, you know, it's at the highest part of the mold, and that way all the air will flow upwards when it's laying down. And I also might add some more pegs to each one of these halves here, so it will have some type of table, I guess, legs. That way it will, when it's laying down, it won't be rolling all over the place. But as far as this, the back vent hole and pour hole, I I wanted to kind of lay it down, but yet it would be getting in the way of the screw uh, holes there where it will be mounted to the base plate. But what I'll probably do here is on the top vent hole, I'll add a plug. That way it'll be a displacement of the silicone. That way that whole piece there will not be one big solid, you know, plug. But yet more likely, if it's any kind of a plug, it would just be cut away with a scalpel or a razor blade. In SketchUp, when you have a component, it's highlighted as its own object. And if you explode that component and you have two of them that are exploded, they'll join together automatically, but you're risking it being off. But you can intersect the faces with as a component, and it'll make the indication line where the other object is. And this is where I can do cleanup, and then all I have to do then is explode the component, and it will join in that area without doing so much cleanup. And overall, these two pieces, and actually there's three pieces so far that I'm ready to start printing. And that's the two mold pieces as you see here, and the core. And I have one more other piece, and that's the sculpting uh, base core. So, and overall, this is the space I have to work with as far as the flow. I'm putting it more thick in the front because of the detail, but it worked out pretty good. And to work on the sculpting uh, canvas and mounting it to its base plate, and as in the previous video, y'all saw me working on the areas around these eyelids and eyes and the mouth. And I wanted to reduce some of these polys here to kind of get close enough to what the mouth is really, you know, doing here. So I just took a picture of that and matched the original that we've been working with in ZBrush, so we can do the bridging to this mouthpiece, and also doing the same for the eyes. So I just kind of made a somewhat of an oval circle and then extruded it. And this way I can just remove what little and keep what little shape we need there to do the bridging. But I just, took a screenshot of ZBrush and saved it as a JPEG and imported it into SketchUp and did an X-ray version so I could see through, so I could just basically see this shape, just to get where I could have like a stencil to cut out. That way we can bridge it much more easier than me trying to do it in ZBrush. But when I was in ZBrush, I brought the so-called base plate that's strictly for it, so we won't have to do any heavy duty cleaning out the inside by keeping the core in there. I'm just doing what we need. But overall, this turned out good. As you see here, this is the original that we've always had. That so we can make this core base plate for the sculpture and keep these blockout areas open for the mold purpose. But you see how much I've taken off the eyes, and you just saw what I did for the mouthpiece here. And all this will be bridged into the sculpture. But, once again, I've reduced the polish to the sculpture. Now I'm going to do some fine detailing and clean up and get it all the way to where I want it so I can import or export it into Blender. And that's really where I'm going to be doing the bridging, because I like their automatic. And once again, the organic bridging is a lot easier than, doing it on a simpler shape. It's easier to do. So I'm just going to do that in a Blender. But overall, it's coming along. So we got 3 main pieces ready to print, and this is the final print, so we can start printing soon. So I hope y'all like this video, and thank you for all the subscribers and comments. And once again, I thank y'all for all the support. And I hope y'all like this video. Thanks. Have a good one. Later. Hello, everyone. Hope y'all are doing well. Well, I'm still trying to shake what I have. Still got kind of like a cold, but I'm slowly getting over it. Well, just wanted to get started on a part 36. This is 3D printed animatronic creature, and this is bamboo settings and silicone theory. Just wanted to show y'all what I've been working on, and mainly just trying to learn the Bamboo Studio and get this started. There were some things in the measurements with Bamboo Studio, or the bamboo printer itself, as the height being 256 is really not 256, and I've had to make adjustments to my molds. And as you see here, I'm just kind of working on my molds here, make sure there's no artifacts, just doing some cleanup and things like that. But I just thought it was kind of strange where it says it's 256 as far as height, and it was just showing up in the studio as being too large. I'm still working on my computer, so I'm just kind of dialing in a little bit, and adding other softwares, and about to add this my doll maker scanner. But I'm just trying to tweak it a little bit. My computer is, just it's so new, and I'm like right here, I'm learning new editing software, and it's my old software. It's just with this new computer it was just kind of grainy, and I'm having to learn new software. So this is Shotcut that I'm using now, and just trying to get some you know it's a learning curve with every new software. But I'm getting there, and it's a slow process, and just trying to uh, get these mold files, right, get everything ready for for printing. But I still got to work on the sculpture and you know uh, get it all in one piece and get it ready also to print. And I've been you know just researching and learning this bamboo studio. But I do have some questions as far as I just wanted to see like I mean like it, for instance this piece that I'm working on now and I'm once again, I'm just cleaning up the inside, making sure that there's no artifacts or missing pieces that I have to make sure. Just, cleaning up the mesh so it can be a clean STL file. And I'm loving Bamboo Studio, but it's telling me that like this piece here, uh, as you see, it's saying that I'm going to be using an entire roll of filament. But if it goes over an entire roll of filament, you know, I can stop it or pause it and add another roll. But this AMS system, if you had two, if I had the AMS system and I had two of the same filaments, would it continue? But I was just wondering things like that because some of y'all do have a bamboo printer, and I was just wondering things like that. And if y'all could, help, that'd be great. I just, I'm new to the bamboo printer and I'm just trying to figure things out. But as you see here, I removed 2 millimeters off the top of these two mold pieces. And I'm kind of glad that, I'm learning this now because I'm having, to make some changes, but it's no big deal. It doesn't take long for me to do this. But as you see here, I just made adjustments to both of these and now they do fit, uh, the printer and I'm happy with that. I primarily use Cura with all my printing, and I used it for probably over, shoot, 7 years, I guess. I was just kind of happy with that. But my thing is like certain settings like wall thickness, your my outer wall thickness, and it when I tried to make it thicker, for some reason Bamboo Studio didn't like that. And I guess it caused a lot of it because of its speed. But and I need this piece to be strong and the infill would be thick. I would want it to be because, I'm going to be putting some heavy silicone onto this. But like, I'm just like testing the core. Total filament 301 meters. Quite a full roll. But like when I do the sculpture core for molding, I know it's going to go over, but I'm just wanting to make sure that because I want it to be a clean print and would a AMS be good to have or I'm just trying to figure things out. But here what I'm doing is I'm going to make what the silicone is going to be like as far as and I just wanted to show y'all this. Now this is like a silicone theory that I have. As you see here, I'm removing the outside of the mold. And the inside of the mold where the silicone is would this mesh would be considered what the silicone is in the mold. So what I'm going to do is I'm not going to be printing this, but this is going to give me a measurement of how much silicone I'm going to be using. And in the molds that I made a lot of silicone molds, I would do a water displacement. But being 3D prints, I'm going to try to get away from that. And I will probably do like rice. I learned this the other day about somebody using rice, and I thought that was a cool idea. So before you would make your silicone mold, you would pour rice in there, and then you would pour the rice out and do your measurement, and that would give you an accurate measurement of how much silicone to measure 1-to-1 ratio. But my thing is like if you wanted it digital. Now I did this Blender physics test with liquid. And I did this 12, I guess maybe 11 years ago, I think it was 2012 maybe. And I've always been fascinated with fluid dynamics. And I was just thinking, well, if I took this and I molded this, and as you see here, this is, now I'm not going to be molding this. This is just a test. But I'm going to use this to make a silicone mold mesh of what I'm going to be using to do this test. But once again, I'm not going to be molding the core. I'm going to be molding the creature sculpture. But I just like to would know if I could do this in Blender, and what I would be doing is just testing this piece. And this would give me a rough estimate of how much silicone to be using. And usually it's 1-to-1 ratio in Molestar 30. So I would get a measurement. And this setting all this up as doing the physics is somewhat kind of difficult in a way, but it's just a learning curve. If you do it enough times, you can pretty much turn anything into liquid. But my theory is, if I have scanned a measuring cup or a bucket of some sort, the size that I need or whatever, and I turn this mold into liquid, and it would drop into a measuring cup, it would give me a digital measurement of the amount of silicone I need for my project. There's a lot of settings in dealing with this, and I'm just playing around. That's all I'm doing right now, just to do a test to see if it's possible. Now, there's a domain for this particle physics to work, and you could make gas or smoke, but I'm doing a liquid, and the mesh itself, as far as the mold that I'm doing, I'm doing volume, not just the outside of it. So it'd have to be a lot of particles to do volume. And this is not to be rendered because it would take forever to render this. Even mine that first little test y'all seen me do 12 years ago, I think that took me a day just to render it. And that's once again a 12-year-old computer. But as you see here, I'm just playing around, and then you have settings like fluids, which I didn't get into some of the fluid tests, but like there's settings, domain settings, and things like that, and I would clean it up and just do tests. And there's a number of where you have to bake these images and just doing some testings, and you have like settings like viscous materials, like do you want like a water liquid, and silicone would be more like 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 honey or maybe thinner than honey, but or like an oil. But that's just certain settings you would have to go through just to get this measurement to fall into this measuring device, so we could get an accurate measurement of how much liquid digitally I would be needing to use for this process, or this whole project. But this is roughly what I'm trying to get, is this. If I could just get this so-called measurement. But once again, there's settings of flow and gravity, and then this cup has a collision put on it, and I'm just trying to do some tests to see if I can get this to work. Now, I did another test and remodeled it a little bit, and just to see if I could get how accurate it is. But once again, that this particle physics, as far as flow, to be accurate, it would be some settings. I did a kind of a bake, render, or cache of this to get the flow to work, and just did some testings with this. It came out pretty good, and I was happy with it. But is it's just the settings of the viscous material to turn it more like into an oil and things like that. It's a quite a bit of a challenge to do, but it's something fun, test, and it would be a neat way to
to make everything digital to get a digital measurement of the silicone that I need to do this project. But to bake 500 frames into cache, it was probably about 15 minutes. And this is with my new computer. But look, y'all, I hope y'all like this. It's just a test, just to try to think of a new digital way to get measurements of the silicone I need for this project. But I hope y'all like this and appreciate the subscribers and the likes and any answers to my questions. Thanks, y'all. Y'all have a good day. Later.
Animatronic Creature Part 37 test prints. Hope y'all are doing well. I've been busy working on this and been working on newborn stuff and also this big human head as you see here. So I just been working on this. Just been kind of busy, but my main thing is just getting this thing working right. I mean, this thing's huge. I mean, this just the head's probably 17 inches and has, I believe it's 26, 24, 26 servos. But back to our project. But this is what I had to do. I had to finalize the creature core. And I had to make sure that the thicknesses were correct. Now I'm in ZBrush and I'm manipulating this, but I needed this to be finalized so then I could bridge the gaps with the mouth and the eyelids. That way I could make this one solid STL file ready for printing. I was happy with the sculpture, so it was just mainly is to get my thicknesses right. Now, like by the mechanisms of the eyelids, I felt like that was correct, but the only ones that I had just wanted to double check was the back of the head and this around this ear flesh area and the mechanisms around the lips. I wanted to make sure that I don't want to produce an undercut in the silicones because even though it's going to be soft, it's going to still have to go on to that, lay up on that area where the teeth are going to be. So I had to make sure it was all correct. And once again, I have to bridge this to what I have, and it's going to be bridged behind that center lip mechanism and the two fork lip mechanism. I decided to do the bridging in Blender. So I'm going to make sure that because I can manipulate some of the vertices and just overall faces better in Blender. Uh, but it's coming along. It's just making sure my thicknesses are correct and being able to see it right. But as you see here, I'm just trying to double check, make sure the thickness of around the neck. But I want to be able to, even though I'm using Ecoflex 10 and the mold's going to be Moldstar 30, so it should be firm enough. But yet, I just want to make sure that everything is correct. And I'm also, you know, uh, I got to make sure my my STL file is not too big because there is a max limit. I've read things on the internet. Now it might be different with resin, but we're doing FDM printing. And I'm working with ZBrush, Blender, and SketchUp. So I had to make sure that I had this correct. So this is the old canvas. So I had to, decimate it. I did do the decimate in Blender. And, you know, I'm limited what I can do in SketchUp. But, I got it decimated and I placed it on this older version because I've changed the sculpture and removed it and then checked my molds. Then I did a cutaway so I could just really see how everything is going to be as far as my thicknesses area for my silicone. And I just had to make sure that everything was correct. And this is with a core in place. As you see here, Now I can see how much more that I need to bring the lips up, and or the center lips okay, and also these fork lips, which is the turquoise color. That's correct. So I'm happy with this, and I this is where I had to transfer everything to Blender, not from here. This was just a decimated version for me to bring it in and test it on SketchUp. You know, having this new PC has been wonderful, and now I can actually do certain things now that I wasn't able to do earlier on the older PC. But as you see here, I've I feel like my nose is correct. You know, I'm the the thinnest area needs to be the face and the lips and the eyelids, and everything else is just pretty much okay, just as long as it's 3 to 5 millimeters, maybe a little thicker. I mean, everywhere else but the face can be a little thicker, but you know, I was happy with that. I just wanted to check my molds and just pretty much check everything. As you see here, I'm doing a top version just to kind of see where if I do need to change the sculpture. And as you see here behind the ear area, it's a little thick, and right here on the back of the neck was too thin, so I had to manipulate it so I could get it, you know, thick enough so I wouldn't have any holes. But you know, it's just one of those things is which way is the best way to visually see this other than multiple cutaways. So I brought it back into ZBrush so I could see, you know, just check different color situations so I could actually see my thicknesses right. But I was happy with this, and I got this sculpture almost. It was 4 million polygons, and just trying to get everything just right so I could bring it into Blender and do the bridging. And once again, I had to make sure that my STL file was small enough, or you know, you could only go so high as far as, you know, I wanted to keep this, you know, under well, mainly under 200 megs, but I even went further, and I believe that this was like maybe 120 meg, and but I had to uh, decimate it, and then it generated some double edges that I had to remove so I could get this border around the canvas, sculpture canvas, so I could do the a bridge loop. So that's what you're seeing here. I'm adding a new edge loop all the way around, and but it took some time, but it was nothing, you know. Some stuff is hard, but it's fun. So, so, but this is what I had to do, and this is one of the other things about Blender's decimation that is different than the decimation in ZBrush. And I just chose this version because I was already in ZBrush, and as you see here, I'm working on the mouth area here, and I'm actually inside the sculpture itself, and I'm just, you know, adding all these or removing a lot of these edge loops and faces so I can bridge this together. But to do all the bridging and all might have been 90 minutes. You know, it was no big deal there, but I was happy with the results. It's easier for me to edit in Blender than it is ZBrush. You know, I've had ZBrush for a few, maybe 2 or 3 years now, but I'm, you know, once again, still learning it. But, you know, I've been playing with Blender for years, but I just wanted to, you know, go ahead and just bring it into Blender, and I can. But you know, there's pros and cons on all softwares, so it's just a workflow thing. But you know, after I got the bridging around the mouth and the eyelids and around the border of the canvas, and I was happy with, and and the results turned out really well. But once again, I had ordered my Molestar 30-gallon unit and uh, just some trials of EcoFlex and Moldy's, release agent and some Psycho paint and some clay because I'm gonna do a clay border on on this whole, the molding process is a dividing wall. And but what I've been designing was the mother mold to hold the silicone. But here it is here in ZBrush, and as you see here, it's the one in the back is all sealed, and it's ready to be printed. And this is these multiple build platforms that is in Bamboo Studio. I really like this. This is pretty cool. And I'm kind of the only thing negative about Bamboo. Don't get me wrong, I'm loving the prints. It's great, but the only negative is it's just the build platform is not. It's 256 by 256 by maybe 248 as far as height. But I just mainly just really enjoy Bamboo, and I just got this time lapse on there, and times 24, and this is what it is right here. I just wanted to do a test just to see that this is not the one that's going to be molded. I just wanted to test, and it really came out well, and I was really happy with it. And but I'm gonna be printing this in a PET G uh, from Bamboo, and just to give it some more strength. But this is me just taking. Now I've always liked these kind of supports better than I do those trees. I don't really care for the tree supports. But once again, maybe later on I'll be using them more. But this is that one I did a test, just a small print, just to check out a little sculpt version or whatever. But this one came out really well. I'm happy with it. There's some little areas, with you know uh, FDM print, very tip top of the head, and there were some areas underneath the chin where some supports, but I can clean it up, and I can also add clay to it. And the clay, you could actually sculpt on the core in clay, especially with some of these PET G. You can get some that can tolerate, a lot more of the chemicals with sculpting. But once again, that's just something we need to work on and just do some patching. But I'm really happy with the results. Everything. This, you know, my designs here of the mold, and I ran out of PLA doing a mold, and I added some other PLA to it. But I'm really happy with this mold, but there was one thing I'm wanting to change to it. Like when you see it here head on, I just don't want my silicone, the Mold Max 30, to do any sagging. So I'm going to put a key at the very top. I thought about putting some other keys, but I feel like the way the shape, it should be locked in pretty good. But here's the key that I added, and I've not print this yet, but I will print it. But this is just me designing the key, and I have one in the front and the back mother mold. But it's just mainly just to make a small groove that will you know that will somewhat lock in. I mean it's going to be just something to hold that top, but it's not gonna, it's gonna be poured upside down from the bottom. So that's the other thing. I just wanted to make sure to give me some kind of, I don't want really any kind of a sagging. And plus the mold down, when I make the mold down, it's gonna be not straight. It's gonna be, in a certain area that I want it to flow with the sculpture. But I think this will help a little bit just to keep it when it's, right side up. But And this is me here highlighting everything so I can reverse the faces. But as far as the screws, you know, they're 4mm screws. They'll go all the way around. I'm really happy with the results of this mold piece. Now I'm out of the PLA, but I have I've ordered another PET G. I have 4 of them here, but I'm going to need another PET G. But I hope y'all like this. I appreciate y'all. Hope y'all like the video, and thanks for the likes and the subscribers. But let me know what y'all think. Y'all have a good one. Later. Hello everyone, hope y'all are doing well. This is 3D printed animatronic creature part 38. This is 3D printed molds and core update, silicone measurement. Well, as you see here, I've been doing a lot of printing. I've been working on newborns and that big creature also, but I've been getting ready to start molding this creature, and but what I've been doing is printing mother molds and getting everything prepped. And as far as you see here, the way I've divided this mold, now this creature doesn't really have any type of ears, and I'm trying to keep things small and not so complex, like having human ears or like elf ears or wolf ears or whatever. But I just kind of divided it straight down. No difficulty in designing anything with tolerances if it was off shape or anything, but mainly just to keep the same size of what I got because I'm still limited. Now I've maxed out the printing uh, build platform on this P1S, but it's I mean it did really a good job on printing this. But you know, as far as my dividing line, it's going to come pretty much straight, and plus what I'm about to show you is how I'm getting my measurement to my silicone of how much of this Molmax 30 or this Molstar 30 I'm going to be using. And on this back piece mother mole here, I was kind of worried about it locking in on the silicone and I wouldn't be able to pull it off. As you see here, I was looking at as once again doing a dividing line right here, and it would probably lock in right there at the neck shoulder area. But once again, I've divided uh, this back mother mole into 2 pieces. That way I'd be able to remove it when it's time to demole and remove this creature from the mold. These 2 mold pieces here, even though it was a lot of filament, it was actually, if I laid them down, more filament as far as having more supports. But each one of these halves were about 16-hour print time. Uh, the creature was roughly about 25 hours, and the core was also. Now, I had trouble when I was removing the core. I broke off the lip mechanisms off because of the supports. But and I investigated, you know, other options, and you'll see later what as far as me solving that problem, what I did. But these supports were removed so well, and just they're just so easy just to take off. But once again, it is a lot of waste. But you know, doing it this way, I feel like I'm saving a lot of money. And even though it's not resin and this is FDM printing, I, I feel like this is a, a more economical way of doing it. And then once again, you know, I have to order some more clay. I have the
the moldam clay that I'm going to be using. But you could sculpt on this sculpture here, and once again, I would probably go with a PET G because it can tolerate some chemicals more than just straight PLA basic. But but as I put this mold together, it really comes together really well. But once again, a resin printer for this size creature would be $1,500 printer, and then on top of that, once again, resin printing, you have a lot of cleanup, and that's using alcohol and submerging the whole piece in there and doing a cleaning, and then you have to cure it, and then on top of that, you have to get special molds or molding material or silicone, you know, to hit the to mold resin. And I'm just trying to put this as a budget, but overall, I'm happy with this mold right here. But I mean, this front piece probably took, I think it was 19 hours, and but as far as the core, I'm having to redo the core, and I'll show you all that next. But right here is where they broke off, and this is because of it got locked in because I have a space underneath them. But what I did is you'll see later where I kind of made just removed this upper lip area and made a socket and created a tolerance of, I think it was 20th of a millimeter maybe, of just to remove this whole piece right here, and that way I can just pop that in, just avoid that. And as you see here, I just pretty much copied this area right here on the core and just brought it in a SketchUp, just removed this. And as you see here, I just doing a plane cut, straight across. And I have two different sizes, one smaller than the other, and that would be the tolerances to make a socket on one side, and then have the lip mechanism on the other. And it was quite easy to do. It's just having to do it. And I even checked into doing, you know, water soluble filament, and also there was some other type of support filaments you could use that way. But it's I mean this whole core is taking a little bit more than a whole roll of filament, and I'm trying to still trying to keep costs down of producing this 3D printed animatronic. You might hear my printer going on in the background. I'm printing the core as we speak right here, but I'm just doing a cleanup after I do a intersect with faces on this main cut right here. I'm just removing the what I don't need on this one because I duplicated both of them. That way I can just make the socket and then just make the lip mechanism. But a lot of times when I do intersect with faces, it has trouble, calculating some of these small areas here because, I mean, this is less than a half a millimeter right here. But just part of the design, and, physical, editing, which is, I done got used to it, and I got kind of quick at it. But as you see here, I'm just trying to, when a lot of times I'll have like, you know, uh, hidden geometry that I'm not seeing that I have to turn that on so I can visually see where the problem is. As you see here, I've turned it on and I can see these other areas. But if I don't turn it on, I can't remove them. But I just clean up this whole area right here, and I'll just go to the second copy, and I'll just copy that and then just add it to it. And that way I don't have, as you see here. But you know, this didn't take, I mean, 30 minutes for me to do. But and I'm quite happy with the results. But once again, I'm printing it right now, and should just have this socket fit in place. And I'll probably glue it, and then I'll probably touch it up with some clay around there, and then seal it, and then. But once again, I'm going to be adding some clay to the core underneath the chin and on top of the head where you see some of the uh, the layer lines. But I'm happy with it, and we'll be able to get us a 3D printed creature skin soon. Once again, the core has been printing as we speak, and it's been printing for 2 hours, and it's 22-hour print. And it takes a little bit more than a little bit more. It takes a whole roll and just a little bit, maybe a quarter of another roll. And but I'm happy with that, and but I really designed this animatronic to this printer as far as being its build platform, and I've maxed it out. I can't go any wider or taller, even though it does say 256. I'm at 250, and as far as height, it's maxed out at 248. For some reason, I can't go any higher according to what their specs are. But and I'm happy with that. But I was expecting 256, and I cut it back down, uh, to 3 millimeters as being an extra space to work with. But I'm stuck at 256. I mean, 250 all the way around. But I'm happy with the printer. It is a really good printer. But I wish it was a little bigger, because when it gets bigger, uh, we'll be able to print even bigger animatronics. But as far as a bigger printer, you know, most inside doorways are what, 32, and I would think it would have to be you know, I guess no bigger than that, because they couldn't get it in their doorway. But what I did here is what I copied. I just removed it, and then what I've created as far as the socket of the lip mechanism, I'll just place it in there and join the two together. But it's worked out pretty good, and I'm happy with the design. But now I'm printing, and we'll see how that works. But that'll be up probably on the next video. But I'm using an ABS system, and I have 4 rolls of filament in there, and they're all gray. And when it runs out, it'll automatically detect that and go to the next roll of filament and print. And that's great. So it's always continuing to print. But I'm happy with this design here, and I'm once again printing the core. I've already printed the lips too. But as you see here, I'm gonna put this together, and we're gonna do just to see how much silicone I'm gonna be needing to mold these two with Mold Star 30. In the back of these mother molds, I have a vent hole and a pour hole, and mainly it's going to be used also as a displacement of the silicone when it starts to get close, because I really don't want to fill up those holes, because it'll be something that I have to remove, or it could interfere with me demolding. But Mitch from Brick in the Yard, uh, he he recommended using rice, and I've used water for years to get a measurement of my silicone. But once again, PLA and or 3D prints and water really don't really go go too good together. But I just poured in the rice and removed those plugs and released all the rice to get a proper measurement of how much silicone I'm going to be using for this front or this back half of the, on this one here is the back half. And but it really worked out pretty good. Now I'll probably go with a little more than what it says, because I just don't want to waste a whole lot of silicone. And I'll probably go a little bit more than, as you see here, probably up to 48, maybe a little more. Because, once again, I rather have extra, but not too much extra. And I believe on the back mold, I mean, this is the back that you're seeing here. I might have edited this wrong, but as far as this one being, we'll probably go 48, maybe a little more. But as you see here, I'm going to do the other part, and once again I got plugs for this, and then when I pour them, I'll pour them up to these holes, but one's lower than the other as far as the shape of the inside of the mold. And I'll just use it as far as a displacement of the silicone, and then I'll just tape it down, and I'll continue pouring up to that pour hole. But I'll just pour in some rice, and probably once again I'll probably be finding rice all over my work area for a while. But this one here worked out pretty good also. I'm happy, and it's I ain't got to deal with no water, liquid, and cleaning up and drying any kind of parts or prints. But once again, this measurement here is, I believe I'm probably going to be mixing according to this measuring uh, bucket that I'm going to be using. I believe it said it was 250, I mean it was 56 ounces that I'll probably be mixing, but I'll just remove these plugs and let it pour out. And this little trick works out good. And once again, I'm used to water, but this way keep everything dry, especially being a 3D print. But yes, this right here was going to be probably a 56 ounce, and then divide this in half and doing a two-part pour or two-part mix. But it worked out really good. But what I'm going to be doing like right now is like, here's the animatronic. I got to replace the servos underneath the chest piece area, and I recommended some of these high-tech servos, and I'm going to be this is the ones I recommended for y'all to get, the ones that are building this animatronic. But I had some old some King Mac servos. Kind of disappointed in them. They kind of drain the battery a little bit too much. And then I have my teeth here that I will probably put these in, probably one of the last things I do, even after I make the skin. But as you see here, I'm printing the new core now that's going to have a socket for this lip mechanism, and probably have another 19 hours to go. And here's the clay that I ordered for the mold dam. And I use this cheap clay here just to create, the mold dams for a lot of my sculptures and things. But what I do is I'll fill this the mold up with some plastic, trash bags, something like that, to just do a filler so I can lay this clay and do a dividing wall right there. But before I do that and I get everything finalized to get ready to mold this, and after I do some clay touch up on the sculpture, I'm going to put some silicone on these flat areas here of the divider wall, and so I can kind of secure it with some silicone to create a gasket. And I'll be doing that also with this front piece. I'll just put on some just brush on a thin layer of silicone right here and let it set up. And I'll also put it on the bottom there so it'll set up on the bottom plate of the core. And then that way I can just have everything kind of a gasket all the way around so I won't have any type of a blowout. Even though this is all flat, but that should help a lot. But I'll also have like tape and it'll be all secured down with screws. But once again, I got an animatronic, got a core, sculpted on the core to produce the creature. And then after that, I'll remove the creature and put in the core, and then we'll mix up some EcoFlex tin to produce the silicone skin. I got 3 of these little trial units, and but as far as what we're going to be using is going to be a Mole Star 30, and I ordered a gallon kit system for it, and but we'll be able to uh, create the mold for this creature so we can produce an animatronic skin. But I've used this a lot and I've always enjoyed this silicone. But look, and also I got some man's uh, release that's really needed. Hope y'all like. Let me know. Later, y'all.
Hello, everyone. Hope y'all are doing well. Happy New Year. This is 3D printed animatronic creature part 39. This is mold prep. Just wanted to show you what I've been dealing with as far as getting this thing prepped for molding. And some of these 3D prints, as far as the molds and the master creature, I'm just showing you how I'm blocking out some of these, I guess, scars from the supports. And I reprinted the creature again, but this is a light gray. But I was just wanting to show you that there are some, with FDM printer, you're going to have some, I call it like, especially on the top of things, as far as the layer lines, or you'll see these patterns that looks like a topical map. But overall, I am happy with the result, especially with the FDM printer. This is a quite good detail, and you really have to look for it. But if you look carefully, and I had plans to do this from the get-go and mentioned to you in the video that I was going to be adding clay to this to get rid of some of these blemishes. And as far as sanding and things like that, but uh, I try to avoid that because I rather not take away, I rather add to it because taking away could, change. It could change things. But but as you see here, you really don't notice it. Uh, I mean, even just a few inches away. But like things like this has to be repaired underneath the chin. And by me sculpting this on the chin, and this is from supports, and I have tested other supports as far as a tree, but and you'll see that later. But a lot of these things is that this thing is one big massive print, and once again, I did not want to go resin. But if you see here, and once again, it does look like a topical map. But anyway, just to show you as far as the size of this compared to like a quarter or something. But like, and this is me just adding some clay and smoothing out some of this topology, and but I'm keeping the clay with the sculpted area where I place the so-called wrinkles and folds. But even though that you might see me lay the clay over some of these wrinkles, I'm going to come back and resculpt them that way to give the same form. But as you see here, here's in Bamboo Studio the tree supports, but I'd have to do a manual tree support because I'm at the I'm at the top of the or the end of the build platform here all the way around as far as around 250. But and then I wanted to see if just doing a test that I added the tree supports onto this. I did cut the model up just to see how it would look, if it would look any better. And as you see here, it still is the same. I still have it. Anything that's hanging over and then on top of anything organic, you're going to have these type of blemishes on as far as a you know FDM printer. And then I just cut the top, and then I did some adjustments in the settings, and did uh, as far as just to test to see if I could eliminate with the ironing on in the settings, and it did okay, but it's still there. I'm still going to have to sculpt, and anything larger, as far as a larger animatronic project or anything like that, you're going to have to sculpt it. Now, you could sculpt a creature directly onto the core that I've designed, and you just do away with the ZBrush as far as a digital sculpt. But just to show you, this is my plans from the get go, is to just sculpt and patch, because once again, everybody knows you have to do some sanding with FDM printer, or you have to add something to it to just cover it up, even if it's like some kind of sealer spray, some Krylon Crystal Clear or things like that. But I'm just kind of just adding clay throughout this. But the biggest resin printer that would take this file is, I think it costs around $9,000. And then you'd have to have the resin and all that. But then we get into a whole nother realm of, certain silicones. And then you wonder that if it's tin based silicone, and there is another silicone that works with resin, but it's sold by from what I found, it's sold by I guess the liter, and it's really quite expensive, more than I mean, all of this is expensive, but it's just a just something that we're working through. But as you see, anything lower, it has you know your layer lines, and I've adjusted these settings, but a lot of these things you just don't see because you'd have to really look for them. But up close, micro, you do see them. Back in the day, I used to get this clay and absolutely loved this clay, and it was Roma Plasticina, and it was number 2. And the thing about it is, I went through cases of this stuff back in the day, especially in the 80s and the 90s too. But it's just, it was a wonderful clay, and I got used to it. But it had sulfur in it, and when it had sulfur, you could never mold use silicone. It doesn't like sulfur, and but I just love that texture, and I've tested so many other clays. And don't get me wrong, Monster Clay is wonderful, but you know, with my 62, about to be 62 years old, it gets kind of hard on them knuckles. And after I get this all sculpted, I will apply a sealer like Crystal Clear over that, as far as a light coat of, you know, a sealer. But but as and I'm going to add some more detail to this chin, and maybe a skin fold right there too, and just do some testing. But this will be able to work with the animatronics some, and I just want to see what I can do as far as, if when I add these things, is it going to change? And once again, that's going to be the thickness of the silicone there. It's going to be a little thicker. And and I'm trying to keep this uniform because the thinner it is, it's going to be more flexible. It's going to be more lifelike. I'm hoping, and just if this is just a testing phase, but it's pretty cool. I'm happy with it. Yes, I am happy with the results of this print, and I'm just going to do some touch-ups, fix some of these blemishes, and fix around the eyelids a little bit. By me adding some to the eyelids and not removing is a plus because I designed this skin to be around the animatronic like eyelids, and I'm gonna fix the nose to give it a little bit more, you know, some nasal holes there, and come in here around the lip also, and then I guess add a little bit more to the lips and to the eyebrows, and but it doesn't take long. It's just things I just have to do, and I'm my worst critic, and I want to make sure that this thing looks good. But from a distance of 2 feet, you really don't notice it, but I do. But once again, I just sit here and I mix me up some clay and get some of my old sculpting tools out and just kind of fix some of these blemishes here. And but I'm not adding a whole lot of clay. I would say the only thick part of this clay that I'm adding in what area would be the chin. And I'm playing around with it also because if you did anything bigger than this, you would have to sculpt it. I mean, because once again, resin printers, I mean, unless there's some industrial printer resin that I don't know of, but I mean, you're getting in over $10,000 there for just a resin print. And don't get me wrong, resin prints are beautiful, but there's a lot more work to it than what it is for FDM print. And also that large animatronic, you know, the head y'all seen me move in the last video, you know, that print's going to have to be also FDM printed and then sculpted over. And a lot of this will save clay, and but yet you're still going to be using like doing silicone molding. But like here I'm adding you know some clay around the nostrils, and also I'm making the nostrils a little bit, I guess, larger here so I can make the nasal holes there, you know bigger or deeper, uh, to make it look like it has holes there. But I'm just right now. I'm not sculpting. I'm just laying in the areas that I'm going to be sculpting on, and just continuing with the so-called wrinkles that I had put in ZBrush. And a lot of these things I see that you know when when you're designing something or sculpting something digitally, you know, it looks good on 2D, but when you see it in 3D, well, that looks kind of weird, but you know, it, you know, I I used to do a lot of, even before digital stuff, I used to sculpt a lot, and as y'all know, I did a lot of dentures and made a lot of teeth, and I like making teeth, and but by me here is just sculpting all over again like I used to, but it's just blending, and you also, like you can put rubbing alcohol on this print and it won't hurt an FDM print. But I'm just adding the soft clay in the areas here, and I'll just continue adding to the areas to kind of match the wrinkles. And anything that's like overhang is going to have a blemish, and anything on top is also going to have that topical map look layer line. But in here, on the corners of the mouth are a little sharp, so I'm going to bulk up the so-called the area there, especially where it's going to be opening more to give it a little bit more strength. And I know some people mentioned that you could add
what is it, a nylon material or pantyhose material to make it where it's not going to be like a anti-tear, so it won't tear when it opens up. But this this silicone that we're going to be using as far as the EcoFlex 10 is going to be pretty flexible. I don't think it's going to be necessary, but we'll see. And if it needs to be, I will add that in the next pour if I, need to do that. But here I'm just, adding some clay and I'm trying to keep it, especially when I start spraying it with or adding rubbing alcohol. I'm going to try to keep the base plate clean, and I'll probably be having a kind of some plastic there, like a garbage bag of some sort around it, so I can keep that plate clean because that's part of the mold. And but like when I was talking about tree supports, I didn't want to put tree supports on that build platform there because I didn't want it to make any kind of a blemish on that base because that you know if it has a blemish there and then my core doesn't have that blemish, that could be a problem. And I'm just trying to avoid that. Now, a lot of these sculpting tools that I've got just collected over the years, I got so many, and some of these are just a handful that I have. But I've always liked these Ken Bank tools, and I have several of them, and they've always been, and Ken Banks has been doing having these sculpting tools available for years. And I've always really enjoyed them. But once again, you're you're sculpting on a core just like you would be sculpting on an armature. But this way, your armature is going to be a lot thicker, and your clay is going to be a lot thinner. But I've been working on other things too, as far as that large creature and a newborn. I had a program, uh, an animatronic piece, and just for testing, and I got that done. But this is what I also been working on. As I tape this off, and I laid this clay here to block off the blemish. Anything that had a blemish or it looks like it has stringiness, I remove the strings because I don't want the silicone to grab that string and either damage the mother mold or damage the silicone, which I don't think it would, but I don't want anything to lock it in permanently into that mother mold. But I got the tape there because I didn't want it to be on any edges where it was going to be matching up to either the positive or the negative part of the mold to the base plate that's on both of them. But I'm just going to peel that tape off and that'll be ready. But overall, as you see the big boy here I've been working on, and I've been working on some other like the a future animatronic, and I've been working on another project and hoping I'll be able to do some testing as far as a prop that I've been wanting to try and see if I can get it to work. But overall, I'm happy with it, and I hope y'all like this video. It's fun, it's just part of it, and hope y'all like. Thank y'all. Later.
Hello, everyone. Hope y'all are doing well. This is 3D printed animatronic creature part 40. Now, I'm going to show you some more stuff later that I've been working on for this year's project, and I hope to have a lot more projects going for the YouTube channel. But right here, I'm working on the mold dam or the divider wall, which is clay around the 3D printed, mother mold. But just been doing a lot of stuff, working on a lot of things, and bad weather here in Louisiana, but we didn't really get the heavy snow like New Orleans did. Here I'm just prepping this creature to get it ready to mold, and I'm putting this masking tape here around the whole bottom edge of mainly just a sculpted area. And what I've
as you see here, I did some touch up in the clay, kind of did some little detail work, and especially underneath the chin, and just kind of, I want to spray a sealer on this whole part here, but not a heavy coat, just a light coat, and just something to kind of protect the little touch up areas I did with clay. But overall, I'm really happy with this sculpt here. I'm really happy with all the prints, especially from the bamboo printer. But as you all probably noticed, there's a lot of stuff going on with bamboo right now. It kind of makes you not really want to trust them that much. But overall, I'm happy with the printer, but I can't really recommend it because it's kind of, some of the stuff's kind of shady. Well, as you see here, I've kind of got my border of tape around, and I really don't want any uh, spray on the base. I want to keep it original. But as you see here, I'm just doing a light coat. I mean, it's really light, but it's not really to cover up any layer lines or anything like that. It's just to protect the little little areas where I put some clay and a little bit on the shoulder areas. Molding this creature in silicone this way, it's it needs to be kind of precise, because one thing is I'm trying, I don't want to have a blowout, and what I mean where it just pours out of the edge. But as you know, this back piece right here of the mother mold, it needs to be pretty precise and fit correctly and not have any gaps in it. The tolerances are great, but it's just like, as far as the screws, there's a hole that I designed, but it fits that screw okay, but there's a little looseness there because it's a screw. But I got to make sure that this mold will fit correct, flat edges, everything is just done right. But as you see here, I'm putting this plastic bag inside to cover the back of it. But what I'm doing this for is that uh, when I put the clay on, as far as the dam, I want to make sure that even though it's soft clay, I just don't want to fill a bunch of clay up in there. So I'm using this as kind of a dam. I'm filling it up with pieces of, trash bags or whatever, and just giving me something to put the clay up against, to make it kind of to give it strength for the clay, because once again the silicone's going to be heavy, and I just trying to do my best not to prevent any kind of a blowout. Now these three mother molds right here are really flush. Now I made sure that I made sure that the two pieces in the back were flush. That way I could put this mother mold so it wouldn't be any gaps. And I'm telling you that, being these are flat pieces, there was a slight gap on the I believe it was on the right one, but it was just because the tolerances were kind of loose there. But that's because of the screw holes. But I got it just right where I want it. Now this is considered flat, but now I'm going to put this clay, and this is some cheap clay, but Savant, it's just a really soft clay that I can, it it's really would probably be used for something. What we're doing here is making a dam. It's kind of too soft to do any kind of sculpting with. But I imagine there's other things you could do with it. I just don't know of what they're doing with it. But as you see here, I'm kind of pressing in the clay inside this area here, and just kind of building it up. Now, if it seems to be weak, I'll keep pressing more clay in there, and that's what I'm trying to do. And that's why I got the trash bags in there, to give it something, so I could have some kind of support in there, so I don't fill the whole back of it, and be more cleanup for me to do. But but uh, people use wind clay or water clay, and there's all kind of clays you could probably use. But I went with the soft stuff because and it's cold weather area here, and getting some like monster clay regular, it's kind of firm. You could probably soften it up some, but
it just gets kind of hard to work with. But I want something that I can clean up pretty easy when I remove the back. And now when I remove the back, I can't take apart the. I don't really want to. I need to leave the mold. After I pour this top piece or this front piece, it needs to stay there. I can't take it off. But that's why everything needs to be flush. But but as you see here, I'm adding the clay and I'm building it up so I can make a pretty much good flat seam here. You'll see later. And you could probably put some keys in it if you wanted to, but I'm trying to avoid any of that because when I put it together, I don't want anything to interfere with what I'm doing. I mean, the keys is a good a good piece of it as far as the joining the pieces together, but in this case, I want it to be flat or semi-flat. But it really doesn't take long. The clay is kind of soft, and that's pretty firm because I do have those bags in there. So I'm just going to have to come back later, and I'm going to smooth out these edges that are up against the creature sculpt. That way, it kind of, you know, it look nicer and just like a flat piece of dam right there. But once again, you might have heard me say this in the other videos. Before I enclose it with the front and get ready to mold, I'm going to put, a small brush, a small layer of silicone on there to create a gasket. That way I'll brush it on there when it's kind of thick a little bit, just a little bit, and just try to, make a gasket to prevent any kind of a future blowout. Here, what I'm doing is making some large, that big creature head that y'all have seen, the big Hulk creature, and I'm making, I'm trying to get everything that I need to mold so I can mold everything at once. As far as like, you know, a molding day, just have everything that I need to mold being on that day. And these are pretty large teeth because it's a pretty large creature. But what I'm doing here is this is the mole uh, base, and I have a piece that goes over this to to make it into like a mold box. And I'll show you this. It come up in here in a minute, but it's just making sure that I have all this ready. And as you see here, I have it all ready for me to, to get ready to pour. And once again, right before I put it on, I'll brush on a little coat of silicone there, and then put the box on, and then that way I can let that set up and have a little gasket there. And what else I've been working on is this an animatronic, werewolf. And I'm a big fan of werewolves, and I decided to do this one, and I've been working on this thing ever since. I think I started like January 5th. It was right before my birthday, which is the 6th. And but I wanted to show you what I've been working on. This is the new gimbal that I designed, and y'all probably saw me do these in other videos. Just I get to thinking about stuff, and I have to draw it out and see if it would work. But as you see here, you got a rotation and uh, a looking up and looking down, and like a double jointed as far as the neck movements. And I'm really happy with this design, and I think it'll really work. And I decided to build it, and I'll show you. But a little bit on this werewolf design. It's pretty. I've always wanted to do this. This is one of my pieces I've always wanted to do, and but this is a werewolf concept that I've kind of you know been working on for a number of years. Just little doodles here. This is the way I would do it, but this will be a rod puppet, but it'll be a lot of animatronic in the head, but you'll be able to to have like a large rod puppet where you could walk this thing, and it would be good for you know uh, filmmaking. But here I'm just kind of designing the body.
the way I'd see it to be, biped creature. But as you see here, I have this gimbal design that you might have seen earlier, but this is the whole body. But as far as the animatronic head should have probably 10 servos in it. So far, I have 8. But as you see here, the body, as I have here, it will it'll be able to have two purposes, but mainly mainly it's going to be as far as the as you see here, I've taken the body and I've divided it up into, hands, arms, bicep, tricep, the chest piece, the pelvis, and the hips, legs, calves, and then so on and so forth. But then I have the metal structure here so I could tie those pieces into it because all of those will be divided into two and they have a way to where I could actually take them apart. But as far as the body design, what I would do in my design thinking, the best way to add skin to this is you would put a spandex suit or a shirt and pants that's spandex. And this is a small creature now. This is a little bit more than 40 inches. But but what I would do is I would use this like a mannequin, and I would apply silicone directly on there, brush on silicone directly on it, and onto the fabric of, like I said earlier about putting some kind of a shirt and pants on there, and then brush it on there with some spandex, and then I would add a zipper to go all the way around the crotch area, all the way to the front to the back, so I could unzip this whole thing, and then I could remove it, and it would be jointed in the shoulders and stuff to be easier to remove. But still, that would be one of the best ways because then after I put silicone all over it, I can start, putting hair strips on there to make uh, as far as the whole body and fur. But this is something that I've kind of designed, and I've been working on this for about 3 weeks off and on. And this whole video that I'm working, I've saved, I think it was 13 hours of footage, and I'm editing all for y'all right now. Now, as far as the teeth, and once again, I've always been a werewolf fan, but what I'm doing here is this is in an old software called y'all probably played with it, Sculptress. I've Before I got a hold of ZBrush, this is what I was, learning, and this is an old set of wolf teeth that I had designed, and but I'm just going to use these, and what I do is I'm just making sure that the bite's correct, and as you see here, it's an older file. Now the lower interior teeth are covered up too much, so I'm going to raise these upper interior teeth up a little bit just to so you can see the upper and lower interiors together. I really enjoy making creature teeth. I mean, being a dental lab technician for 30 years, I've always liked creature teeth. But I'm just, doing some touch up. A lot of this will be done on the dental lathe, and I'll add a lot more details to it and kind of, put rougays in it and stuff like that. But as you see here, I'm just kind of giving it more of a flat because I'm gonna cut this in Blender or cut it in a ZBrush as far as having a flat base. And I'm trying to, you know, I'm trying to make sure that my skull will give enough look to where it snarls, you'll see some gum. And but I don't I want this wolf to be more of a wolf than, it might have some characteristics of a human, but it's going to be more wolf-like than it is human. But it's just going to be what's going to be more of a just a wolf walking on two legs. But as you see here, I'm just slowly pulling these interiors down and to show more of them, and then I'm going to raise these
upper interiors up some so we can get it to look pretty good. So this is the final what I've done. And now to import this was a OBJ, and I just got it in Blender, and I'm just manipulating the size, you know, and I'm using both of them as an object to keep them both the same or keep the bite correct. So I'm this, and this is, some of this footage that I'm going through, I have a lot of footage of me doing this, but to sit there and just see me tinker around with it for an hour, but I figure I could just eliminate some of that footage. But basically, this is all I'm doing and just kind of matching it up to the skull. But a lot of these things is that you know I have to put these teeth here because it needs teeth. But then I got to make sure that I have room for a mechanism like the nose and the muzzle. And I want to separate. I know I've seen some other designs of where they open their mouth or the nose raises too high, and I I want to be able to control my muzzle and the nose, and that be two separate servos as you see here. But if you raise it up, if you're not careful, your wolf will become a bear, and a bear, if it raises its nose too much, it looks like a bear. A bear raises its nose really, really far up high. But and as far as the eyes, I'm not going to have an eye mech in here. I'm going to have a blink mech. And the best way to do this is to show people on how they can do things. And and as far as the size, it'd be hard for me to do an eye mech in this because I don't have enough room. Because I'm going to have, like, once again, probably a little more than 10 servos in this inside already, because I'm controlling the muzzle, the nose, the jaw. Then you got the eyelids. Then you have the ear mechanism, which is 4 servos just for the ears, and then there's in the brows. But here we're going to make them with glass eyes, and the glass eyes are going to taxidermy eyes, and the eyes have to look straight. Well, if you ever had taxidermy eyes, that it's not a true half sphere. It's almost a sphere, half sphere, but we're going to kind of make it have the illusion like it is a full sphere. And for me to do this, now these are African lion eyes, and they look kind of like wolf eyes. And but I've designed these little pieces here that will fit inside the back of the eye, and this is 28 millimeter African lion eyes. And to work out all the tolerances, I rather just print several of these, like these little pieces here that you see, and I check to see if they fit snug enough, because these will be secured with glue or either epoxy or whatever. But I need something to keep these eyes straight, and they need to be secured straight and level at all times. But the eyelids are going to be screwed in. Uh, they're not going to be going through no rods or anything like that. They're just going to be having some flat screws inside the eyelid mechanism itself. So I need to fit this on a rod. But what I've usually done is I did a while back uh, a design of a Grogu where I made eyes that just floated inside the eyelids, and that way, and with tilted eyelids also. I like my eyelids tilted instead of being a flat, blink mech. So if you see here, this is the old Grogu, and it's controlling 4 lids with 1 servo, but it's a floating eye. And the floating eye is a rod, a support rod that is going through its support to a standoff. And that's basically what I'm wanting to do with this wolf. And as you see that yellow support rod going to the back of the eye, that's what we're going for. But to do this, it's just
it's just a design thing. But but I mean, it works. It worked with this Grogu, and we just got to keep the eye stationary. But but here the eyelids are too far tilted back, so I got to make sure that I make the eye tilted less. That way we won't see the side of the eye of the glass eye. But that's kind of a this is just to show you also a number of servos I have in this design concept right now. But also I've been working on a 3 servo socket to where I can join them into all these beams that I'm using from Servo City. But here's the eye socket here that I've kind of designed here that will work with a glass eye. And I'm using a standoff, a 3mm standoff, which the length is 12.5 mm. And it fits in snug. The tolerance is kind of tight. It would probably be best to go ahead and secure it with epoxy. But this is what I have here. And but these glass eyes would be either glued in place and they'd be center and straightforward, and they would match up to the support, and they'd keep it floating in between the eyelids. I make my eyes with dental acrylic, and the reason why it's just kind of hard for some people to get dental acrylic because they have restrictions on who can actually buy it. Now you can find some places that have it, but a lot of the chemicals and a lot of even some of the putty matrix material, you have to be, either involved in the dental lab industry or a dentist or but it's kind of strange though that they allow other things to be sold that, are considered dangerous or hazardous. But here overall what I'm doing is I'm touching up the eyelids to where the the pull push tabs on the eyelids itself were at an angle, and I just made these here to give me basically what I'm doing is when I tilt this eye, now it's straightforward, so I'm going to tilt the eyelids and the angle that I want, which I think is maybe 4 degrees and 5 degrees inwards, but I'm wanting to tilt the servo with it. That way it will always be a straight line of sight to the servo horn. And but and this is just the way I like having it to where I don't have to I can just use a straightforward, linkage. But as far as me to tilt this eye, just leaving the eye alone and just tilting tilting the eyelids as you see here, and then I'll come to the top and I'll just tilt it like so, and that way I'll have just a little tilt, give it some little character, but yet the servo is stationary also to the angle. So now I have that done, and now I'll just mirror it and flip it. Then I'll have this in the right position by measuring it. I believe it's 75 pupil to pupil, and that way, and now I can set this. And as you see that the servo socket has already been designed, that way I'm going to tie the ear control and the jaw. The jaw now there's 2 servos on the jaw. They're going to be direct, but as you see here, I'm just fitting it into the eye. Now it's just placing it in that area. I'll make adjustments. But as you see here, I'm doing work like I was telling you about a 3 servo socket that I will be 3D printing. And I'll just tie in all those um, existing servo sockets, and I'll combine them into one that will connect to those beams. And that way, it'll be a simple process. and everything will be measured correct, and then all I have to do is just connect the pieces together. But overall, I'm happy with it. You know, it's the time consuming part is the planning it, and it's like, well, you want a wolf, then you make a skull, and then you want to know how many servos you can put in it, and can I put a servo here or there, or do I have room? Do I need to extend the linkage? But you know, this is what the servo socket would look like, but then I have to add the other two servos to it. But it's coming along. I'm really happy with it. But I'm going to show you me building this new gimbal, but I'm going to have it up and running probably on the next video. But I really like designing these things and see if these things kind of, you know, you design them, you really want to see them work. And this is I'm choosing these servos. Now the animatronic servo will have, I mean the animatronic head will have reef servos in it, and they're micro servos, and these are all our standard servos for the neck. And this is good because you know that way I won't have any worries about torque and about them lifting the head. And I just now as far as the wolf head, except you know, just basically thinking that I can enlarge the wolf head to a standard servo. That way I could actually make the animatronic head bigger if I wanted to. But as you see here, though, I'm just putting together these servo blocks, which are great. Now, I I like the simple fact is that this is metal, and you know I don't have any kind of CNC machine because you know it's a lot of money for that, and plus you know if a part's already designed, let me just buy it, you know, and it's just cheaper for me instead of buying a machine. But I mean, there's some parts I would love to have milled, you know, just to have them, you know, and I love the bearings on from Servo City because it just makes it makes a lot of things more fluid. And these servo blocks have bearings, and that helps with a lot of torque and helps the so-called you know servo itself. But you know, it's kind of you know some of these things you got to watch on how you put these things together because you got to make sure that you know you can put them together this way, and then you know if you if, if you block an access to a screw, you know how you're going to put the screw in. But you know, you just kind of work through that, and you might have to cut Allen wrenches to shorten it to get in certain areas. But you know, you put in one piece, and then you can follow it with the next one, as long as you have space and room to do so. But I'm I'm designing now. Well, I've actually got it finished. You'll see at the end of the video on what I've changed on the bottom mechanism, and it's another tilt and or another you know up down, but it's actually a rotation left and right. That way it will you know look left and right again. That means I can make the creature neck look one way and the head turn the other, and that's but as you see here, here's it moving as far as the center floating, and then that top servo there is the roll, and then or the tilt, and then the bottom one is a left right movement. But it's come out really good. But as you see here, and then but then also it does that tilt on that top servo horn there. But as you see, I'm working on the bottom. As you see there on the very bottom, that's going to be the the tilt there, but it's also the servo is going to be rotating it left and right. But it's coming along. Look, I really hope y'all like this video, and I mean this is like 13 hours of video, and I've edited it down to 30 minutes. So, but I'm gonna try to get going on this mole on this 3D printed animatronic creature, get it knocked out, and but as you see here, this is
the design for the rotation for that gimbal, and I'm hoping to get it finished pretty soon. But hope y'all like. Please share, and thanks for the likes and comment. Tell me what y'all think about this design, and but I appreciate every one of y'all. Thanks for the thumbs up and likes and the shares. Y'all have a good one. Hope y'all like. Later.
Hello, everyone. I hope you're doing well. This is 3D printed animatronic creature part 41, silicone molding. I'm using silicone from Smooth On Moldstar 30. I have more sculpting to do on the nose. I hit it with my arm and messed up the nose, but I'm also working on the corners of the lip. But I mainly wanted to go ahead and finish this mold down area, this divider wall. That way I can just mainly, because this clay is super soft. But I just wanted to work on this because, and plus, kind of, keep the seam kind of, lessen, and just knock this out of the way, and then I'm going to do up the touch-up work on the clay nose and around the mouth and underneath the chin also. But would I recommend this clay? Well, maybe a medium version of this because it is kind of it is just really super soft, but it's just not knowing. But it it worked. But I'm just cleaning this up and smoothing it out around the edges. I can get really, really close on the areas that it doesn't have any clay, but I got to be careful and just kind of clean it up around like at the top of the head here. It's already been sculpted and I've sealed it, and I just want to make sure that I don't, dig into that clay. But even though it is a monster clay and also the Chavant soft clay mixed together, but I went ahead and just added straight monster clay to the nose and around the mouth because it was really just too soft. But here I'm just kind of cleaning up the edges around this mold down here and getting everything ready to prep to mold this thing. But as you see here, I'm going to go ahead and seal this clay wall. And I don't really want a whole lot of sealer onto the mother mold wall. I'm kind of trying to reduce that. And but you'll see later. But I'm just going to spray a light coat with some Krylon Crystal Clear. I just sprayed a little layer of crystal clear on this, kind of seal this clay because I got it in the right position because I'm trying to eliminate any kind of a heavy duty seam to where I have to touch up. You will have a seam because it is a two-part mold. But here I'm putting this silicone to, like I said in previous videos, that I wanted to put this silicone, just a light coat, to make a kind of a gasket so I don't have any kind of a blowout. But and this is where some of the footage is lost, where I actually sculpted on the nose and the mouth. But anyway, I seat this down, pretty quick because I do have kind of a working time, and I think it's like a working time of about 40 minutes to where it really gets kind of, you know, more a thicker version of the silicone. But once again, there's like 56 screws in this case mold, but you have several different, like I made a lot of molds like putty matrix molds, blanket molds, and this is just like a blanket mold, but you really not using a blanket to make it because this is a digital mold. But once again, when I'm piecing this all together, you know, uh, this front part on the bottom screws in the front uh, will not be removed through the whole process. Now, this is a 3-day process from prepping, getting everything ready for me to mold this front. But like right here, I want to go ahead and just like paint on
some around this, even though this has been set up already, but I'm just going to make sure I don't have any kind of a blowout. And that would be like me pouring it and it would just come running out. But the joint is pretty secure. It's just, to make sure I don't have any problems. So I mixed the silicone, and this was 56 ounces of silicone, Smooth On Molestar 30. And here I am molding the face, the front, the chest area of the creature. And during the meantime, I pour a thin ribbon, that way if I have any bubbles in it. Now this is supposed to be bubble-free silicone, but I want to just make sure I don't capture any kind of a trapped air pockets that are inside the so-called mother mold. But after that, and then another thing is that when you're cleaning up, your mold, this silicone, especially with the way the weather is here in Louisiana, I mean, last week was 85 degrees, and like right now, today, it's almost 30. But it has a static electricity, and it wants to stick to cling to everything. But once again, now I'm removing the back part of the mold, and the front part will be left on because now I'm going to get ready to cast or mold the back half of this creature. But once again, I can't remove any of the screws in the front because that mold has been done. But as you see here, after removing all the screws, and there's a lot of them, and I know you might get tired of seeing me undo all these screws, but it's just part of it. Now the back part, once again, I designed it to be in two pieces so I could remove this. I had a feeling that it would be locked in, and I didn't want to do that. But here's them trash bags in the previous video that you've seen where I loaded the back up so I could push a lot of this, the clay down in place so it'd be strong enough where it wouldn't be all solid clay. So I'm just doing a cleanup here, and as you see, the silicone takes 6 hours to cure all the way. But now I'm prepping all of this and cleaning up any residue of the clay. Make sure that I have it. Once again, I'm trying to make sure I don't have any kind of a heavy duty seam. But now I'm just removing all of that clay that's soft, and just and once again, all these little pieces of silicone that I cleaned up, make sure there's none in there, and I'm cleaning up that that edge there of the mother mold to make sure there's no, I removed that so-called, silicone gasket that I made because I'm going to apply another one. But here I'm just putting some alcohol on there and cleaning up any residue of clay. Now here I'm going to spray this mold release, and this is a must because if you do not spray this on there, your silicone's going to stick to itself, and more likely it's not going to come apart. But you have to have this. This is really important that you put this on there. But in the I've used Vaseline, and I've used other types of paste wax and things like that, and it's worked also. But I really like this spray because it's like a light coat. But what I do is I take a brush and I go ahead and brush it to make sure that my brush does get in there, and any areas that I miss with the spray, there that release will be there. Now this is day 2, and once again I got the mold, the front part ready for me to put this back part on, and this is day 2. So what I'm doing is I'm putting on that silicone gasket around the edges of the mother mold here, and I'm doing a loose fit with these screws because I want to make sure I match up like I had it before, as far as in the design, to where I got 2 pieces that I want to make sure they fit correctly to the front half. But it's going along pretty good. It's just, after letting it cure for 6 hours, actually it cured maybe 12 hours, I think it did, because I come back to it later. But once again,
I've removed the screws and now I'm putting them back so I can pour the second half of this mold. And once again, there is a lot of screws. And the amount of silicone that's in the front is 56 ounces. Now, the back, my estimation was going to be around, with doing the rice test, this was 48 ounces. And I did a mixture, it's 1-to-1 ratio, but and that's the key, you got to make sure you stir it right. And you got to be careful that you do not want to put, a lot of air, trapped air. Now, once again, this silicone is supposed to be bubble free, but it does create bubbles when you're mixing. But I tilt this mold around to make sure I don't have any trapped air, that even though I have vents that are in the back here, I want to make sure I don't trap it. But I kind of roll around every few pours, and when I'm pouring it, I'm holding the bucket probably about 3 feet above it, about a yard. And I'm doing that to keep a stream coming down here. And as you see, I keep it a thin ribbon. That way it will eliminate some of the any bubbles that might be trapped. Now I stopped here and I put some of these buckets, the mold buckets there, so it won't teeter or tilt. And once again, this thing is getting some weight to it, and I just don't want to have any kind of an accident here. But as you see here, I'm going to be pouring it. As you see here, a thin ribbon here, and I'm holding this, like I said, about 3 feet above me here, and just pouring a thin ribbon to neutralize any bubbles that might be in the silicone. Now here, you might see that tape. There's a plug there, and I also molded these large teeth. But I put that plug in there, and it was one of the videos that I didn't record because the simple fact is my hands got covered, or my gloves are covered with silicone. I don't want to be touching my camera. But it was a liquid displacement where I put the plug in there. That way it would just not fill up that area. But once again, I'm removing all of the screws, and now, each part is molded. And when you're doing silicone or demolding, you got to watch it where you have like a suction. Plus it's a light, it's sticking to it, but yet you got to break that vacuum, But I'm just slowly just prying it up. I don't want to pry too much, even though that this is pretty strong PLA. But here it is. I'm happy with the results. It really came out well. But now it's just clean up and getting it all in back in its mother mold. And now on this one here, it's it there's a vacuum, and it's still stuck to the sculpture. It's just gotta you know getting a good leverage there, just to try to get it to release. Now this is the third day. I gave it a good over 12 hours to cure all the way, and really it only takes 6, but I didn't want to rush it. But I slowly pry this off, break the seal and release the vacuum. And these little inserts here, these little pour spouts and vents, I just cut them away so I could easily insert it into the mother mold. But overall, I'm really happy with the results. It really came out well. Now I got to get everything cleaned up and get ready to take my measurements of how much skin silicone I'm going to be needing. But that's on the next video. But look, once again, I hope y'all like, and thank you for all the comments and just all the likes, and let me know what y'all think, and y'all please share. But look, y'all have a wonderful day. Later. Hello everyone, this is 3D printed animatronic creature part 42, silicone skin casting. Look, I hope y'all are doing well. I just wanted to go over what I've been doing casting these silicone skins. There's a lot of pre-setup, you got to make sure that you spray the outside of these with mole release. I mean, this is important. You cannot never forget this. Each time that you cast the skin, you must do this. And the underside too, you need to make sure, because if it leaks through, it's gonna stick. But I spray these a couple of times and just give them a good coat. But I let them dry between coats. I'll give them a good 30 minute. But once again, after I did the moles with a release, I gave a good coat. Now this is the first run of me doing a skin. The very first skin run, you just really don't know how it's going to go. Now, I did measurements and things like that as far as pouring in salt to make a measurement of this, how much silicone I'm going to be using. Now, I want to make sure that I'm also putting a light spray on this mother mold area, because I'm trying to avoid any kind of leaks. It shouldn't leak. It should be great. But I just want to make sure it's going to separate. But right here, you see where I've removed some of that flash area there, and you just don't want any silicone to go inside there. And then that way, if there's no release there, it would stick. And I might have told you that I did a salt test, just a quick, really, salt don't like silicone, but it was just a really quick measurement. But I wanted to get a measurement of how much silicone I was going to be using for this, and it was just an estimate. Well, it was a little more than 8 ounces. But I'm doing a trial kit, but I have two kits right here, the EcoFlex 10 from Smooth On. But I wanted to make sure that I had enough, and I have two kits here. And if it was to be over, if it was going to be over the measurement, I would have the second kit to go by. I was trying to keep the design to where I could get, one trial kit. Well, I'm going to mix the B first with the pigment and just now this is the very first run, but I wanted to make sure that I wanted to test the measurements of how much is in each bottle. And I was surprised there's a little bit more than 8. And so maybe I could do it with just one kit. And this is what I was trying to do. So I want a little bit extra from what I'm, doing the first run. I'd rather it overflow or waste a little bit or just sacrifice it. But as you see here, this is my measurement. Now I am using 2 containers because I wanted to mix my silicone pigment to make sure, because that's what they say in, Smooth On, you mix it in the B component. And I'm using this silicone colorant right here, and I've been using it for, a couple of years, and I seem to like it. But I'm just doing a guess, just trying to get some kind of skin tone. And when I add the other part A to it, it's going to kind of give it a translucent and kind of weaken that color a little bit. But I'm just testing and playing around and just getting everything kind of a feel on doing the first run. Now with this silicone, the Ecoplex 10, you really do need to degas it. I mean, vacuum it, and and as you see here, I'll bring it up to the top, and I'm just going to fast forward a little bit. And I did this twice, like they recommended. And you got a mix time of 3 minutes, and also you have a pour time, and this is what got me on this first run, of 5 minutes. So I demolded this first one right here, and this picture here is the second one. So I didn't take a whole lot of pictures of this first one, but you'll see me here demolding this first one, and you'll see where I ran into the problems, because towards the end it started to set up on me, and it wouldn't go down my pour hole or my bent hole. But as you notice, it's short on the chest piece area. And here's some of the flash area, as you see, is as far as the seam area, it really turned out well. I was pleased with this test, even though it did fail. I understand you're going to make mistakes. I do, and I'm just trying to correct them. So what I'm going to do here, as you see here, I do have a bubble under the chin, and that was kind of like, okay. But when I'm pouring, now, as you see here, here's another seam test. Now, this is not me removing anything, but I got that bolt there so it will focus in
on that area there, because translucent, it doesn't want to focus right. But overall, I'm really happy with it. Now this seam here is on top of the head where I did the sculpture to cover up some of the 3D, you know, topology. But I'm pleased with it. It really turned out. Now I can touch up some of this, and plus I'm going to probably have hair on this creature. But everything seems to line up, and you can see the detail on this brow, and I'm really impressed with it. I mean, the mold did good, and I'm happy with it. I just wanted to get a, a complete, full, full first cast of the silicone skin. But there were just little things I just needed to work out. But you see me here, I'm peeling this away, and just to show, it's still stuck to the core, and I just have to slowly remove it. But I'm really, overall, I'm happy with it. But what got me was the 5-minute working time. And I was kind of shocked. I thought I'd have a little bit more time. You mix for 3 minutes, you degas, and then you degas again real quick. But as you see me here, just peeling away from all the sockets for the brows, and it'll just peel away, and then I'll have this mask. Now, it's hard for me to film the process of me actually pouring things because, once again, I have a 5-minute window just to pour it in there, and I just want to make sure I get it full. But I poured this last night, and this morning, this is what you see of me demolding it. But and I put a different, you know, coloring, kind of my flesh tone, and then when you add the A part to it, you kind of realize what true color you will have. Now, once again, I will be painting this, but and I put it in that 5-gallon bucket, and you'll see maybe later to where I'm in a 2.5-gallon bucket, and I have some some trash bags in there with some tiles inside of them just to support it so I can do a tilt method. But once again, I'm taking all these little screws out so we can demold this mold here. And but as you see here, it does stick somewhat, but it will peel away and it will be clean. And as you see here, I'm removing the front part, and this one here actually came out really good. But I do have a bubble on the chin, and I'm going to explain that here. What happens is that I am pouring this upside down. And when you pour it upside down, that just shows me that there's a light undercut underneath the chin. And for me to correct this, what I need to do is tilt it more towards the end of the pour. And that way I can, because once again, it's got the core in there, then the skin space. And then when you have it upside down, any other bubbles might accumulate there later and build up a patch of bubbles. But I'm thin here on the back. And what I'm going to do is I'm going to kind of remove some of these. If you see the pink knobs on both sides of the back, I'm going to open that up with a knife in the mold. And I'm going to cut away a little bit so I have a better flow. And I don't know if that's it's just too thin there in my design or what. But as you see here, this is how much I'm having to pour, and I want it to go in that thin skin area, and I was going to open it up a little bit more so I'll have better flow. But I'm happy with the results. There's a few bubbles, like you see that one where it was really thin there, but sometimes bubbles will stick to a certain area and they won't move. I have a bubble there, and then I have a bubble like right here. It's kind of hard to see with the base plate the way, right there in the chin. But and you can patch them, but I'm just going to try to avoid that. But this is what I'm saying. If I pour this upside down, air is going to trap right underneath there. Now, we're not seeing the core inside, but it's easier to see it this way. So I just
trying to get this thing poured in the 5-minute time, and then I can do a tilt and even use stoppers in the other two vents so I can get that air out of there, as soon as possible. But right here is where I plan on cutting some and just remove some of that where it doesn't hit that barrier and flow down slowly. But I'll cut out some of that. But I'll leave the 3D printed area hole. I'll leave it alone, but I'm just going to open that up on the next pour. So that will be the third run. But that will be later. I'm going to order some more Ecoflex 10. But as you see here, here's this first skin on the animatronic. I did a test, and you'll see that where the lips will eventually close. But I'm just the teeth are really really loose there. But and once again, a lot of times, y'all, I will film stuff, or I'm thinking that I'm filming, and I miss footage. But here's the teeth, and what I did was is I secured them with a little glue stick, just not permanent set. But here's me taking off the skin, and it's pretty neat though to watch this process. But you have to slowly lift this skin up a little bit, to get rid of the stickage there, and then slowly just peel away, and you'll see it right here. I slow it down. Now I'm removing from the sockets of the brow again, and I'm just slowly peeling it away, and you'll start to see it. It's pulling away on its own by gravity. But I just slowly remove it, and I'm happy with this skin. Uh, the flesh tone, yeah, it's okay, but I wish I could go a little lighter on it, and not much brown, maybe a little bit more tan like. But I'm really happy with it. But it peels off the socket of the lip mechanisms, and all of them have their own socket. But as you see here, I got it on the animatronic. I did film me, at least I thought I was filming it, of me putting it on the animatronic. But it's basically you're turning the mask inside out and just putting the face and you stretching it over. But overall, I'm really happy with the results. But I'm going to change it to where I can get a better color and maybe get rid of that bubble. But once again, we might have to patch. But look, I hope y'all like, and please, thanks for all the subscribers, likes, and comments. Later.
Hello everyone, hope you're doing well. This is 3D printing Animatronic Creature Part 43, cast in silicone skin, the third one, and it's painting. Well, for this third one right here, I wanted to change this one that I made that was flesh color to, a little bit more of a skin tone. But, before, I prep all my molds, and I made some adjustment to these the back vent points or the pour spouts here. And I cut away some of the silicone to give me some more room so I could kind of flow this silicone in there a little bit quicker. But once again, I have to wash all these molds with soap and water as far as the blue Mold Star 30. And so it's, you know, it's like a 3-hour process for me to do each one, to get everything prepped and spray all the release agents on and put the molds and all these damn screws. But, it's just a part of it. This is a case mold and just want to make sure everything's, right. But this is here. I molded this on the 10th of March here. And this is me just demolding it. And once again, it's a process, and it with the release spray release and the Ecoflex 10, I can get a full cast, and this is what I was wanting with less bubbles and things like that. Now I did make adjustments to the core around underneath the chin area, so because I kept getting a bubble about the size of a pea. And I did have a small, tiny bowl, but it could just be covered up with paint. But as you see here, I'm just demolding here, and finally I got a nice full cast, and I kind of like the pale color. But once again, I'm going to paint this thing, and I had a piece of blue Molestar, I guess, that was floating around in there, but it just popped right off. It was nothing embedded where it would just be noticeable all the time. But as you see here, it is really nice, and I just touched up here, and my seams are really not that noticeable. But once again, if you stare at it long enough, it gets kind of annoying. But I just slowly put some naphtha there, and just give it a softness. And it's it once again that's a silicone solvent. And I just kind of cleaned it up much as I could. And I didn't really want to cut so much of it off because I didn't want it to make a indention into my skin. But this is what I'm using here. And overall, the very first thing I do is I took this whole core and I washed it with soap and water to get a lot of that residue of the spray release. And then I came back with this naphtha and just did a good brush with some paper towels and stuff. Just give a good cleaning because I want my paint to stick. I'm quoting Smooth On's website that clean all surfaces will contact Cycle Paint. All surfaces to be painted need to be free of contaminants, especially mold release. If necessary, clean all surfaces with solvent, Novex, toluene, xylene, and naphtha. Allowed to dry before painting. End quote. Once again, I will put everything in the description on this video and links to where you can get these products from Smooth On. And once again, I am using Psycho Paint, but I'm using uh, this silicone colorant right here. This is $9 or around $10, and I'm also using the naphtha, this regular naphtha. Now, there's a lot of toxins and stuff. You need to be well ventilated when you're using this. But a lot of this is I'm trying to save money. And the Novex is like $39 a can, $40, something like that. And you have a matte base, and you have a gloss. And and I do recommend going that way because it would probably be less toxic. But still, you just need to be ventilated when you're doing this stuff. But once again, I just mixed up the naphtha and my colorant, and I'm just laying a base coat, mainly just kind of doing like a dry rub, and just working it, and I'll put a coat on, and then I'll allow it to dry, and then a good 30 minutes, maybe a little longer, in some cases, but I'm just doing like a wash on this, and once again, when this dries, it's going to be glossy. And like I'm using a brush, and some brushes, it's really thin. Not for, I was going to airbrush it, and I have like five. I bought an airbrush for this project, but I decided just to do it this way because a lot of people don't have that, and I'm trying to keep costs down. But once again, even though my eyes are black, I didn't want to blacken my eyes or the eyelids too. I want you to be able to see the bead eyes. But and I added probably about 6 layers of thin paint, even some blues around the temple, and it turned out pretty good. And once again, it is glossy, but I'm going to take off the gloss with a translucent powder, and you'll just see it here later. But I'm just kind of touching up some. Remember that the deeper it is, the darker it is, and higher it is, it's light, and just trying to give a good look. Once again, the budget of this creature on the whole animatronic project is around $2,000, and I'm just trying to keep it lower, or just trying to, cut costs. But once again, this is the translucent powder that I'm putting on this animatronic skin, and it really turned out well. As far as the seams, I've covered up the seams. Now it just makes it noticeable with a powder, but I'm going to touch this up with some thicker solvent and kind of make it a little bit thicker there so you don't notice it. In some places you don't notice it at all. But overall on this whole project, it will be haired.
and I can cover it with the hair. And that's the next video where I'm going to put some hair on this instead of this being just a plain surface. And that's going to make it pop, my opinion, because this whole creature is kind of a mix human alien hybrid type creature, and but you'll see on the next video when I do the hair work on it, and I'll be punching some hair. But overall, I'm happy with the results. It's going to look good. But I did this on the core so I could paint it, and I'll be doing the trimming when I remove it because I'm going to have to attach it to the animatronic. But and plus, you'll see in the next video how I'm going to lift it up off the core. But overall, I'm happy with it. I hope y'all like. Thank y'all for all the comments and subscribers. And I'm almost at 10,000 subscribers. But thank y'all, and I hope y'all have a wonderful day. Once again, thanks a lot. Later. Hello, everyone. Hope y'all are doing well. This is 3D printed animatronic creature part 44, herring and animatronic prep. Well, as once again, as the title is I'm starting to hair the creature. And I had plans to hair it to have it to where it's sporadic hair. As you see here, I'm starting to get some hair build up, around the nape of the neck. And I'm happy with, my results. And mainly I'm trying to build up hair because I do have a slight seam and my colors there kind of made it pop a little bit out there, but they're really not that bad, and I'm really happy. But what I'm doing with herring, and I am doing this needlework for punching the hair in, with a needle, but each time before I punch, I put my needle in silicone. So each time that I punch, I'm having to put my needle in there, and I rub it on some aluminum foil to pretty much get the residue off, and then I punch. And, I'll have anywhere from 1 to 5 hairs. And this is an alien, and it kind of resembles the doll look. And this hair is from the National Hair Institute. And the hair that I have was from 2007. Now, I've collected a lot of hair because I really like, making creatures, and I use hair a lot. But as you see here, I believe this is yak hair. And I like the way it is. It's kind of wiry and makes it fuller. But overall, I'm trying to get to that seam there, and I'm slowly getting to it to where I can just get rid of the look of the seam. But plus, I want you to still be able to see the skin through the hair. Like I said, I want it kind of sporadic. But I'm leaving it on the core just for this reason, so I can get the nape of the neck. It's kind of hard in some places, like when it hits around the shoulders, to get my tool in there. And you'll see later where I pretty much just cut my tool in half so I could have some more room. But and plus, my plan is now is I'm going to take it off of the core now, because I still have a lot more herring to do. But I'm going to take it off the core, and I'm going to put it like some plastic bags inside there to fill it like a plastic bag mannequin, so I can like be able to get to any direction I want to flow that hair. And you don't want to lay the hair upside down, because the hair will flow up. You have to have it to where it will flow down the back of the neck, or around the jaw area. And that's what I'm pretty much doing here right now, just dipping the needle in the silicone and pushing it through. But I'm pushing it all the way through, and then when I remove it from the core, I'm also going to mix up a kind of a thick base, but yet it's going to be a little thinner than not as thick as it comes out of the jar, just a little bit of thickness, so I can do a kind of a stipple sponge on the inside of the mask
to where it will secure the hair even more. And plus, once again, when I'm doing this, I'm putting a hole every few millimeters, and I don't want to make a tear line, you know. But but by me putting this silicone each time, it's pretty much sealing it in place. But you know, I won't overkill. Now, doll makers, they kind of you know, their silicone babies are solid, and they're punching their hair further in, and you know, my thickness might be, you know, anywhere from 3 to 5 millimeters thickness, especially on the back of this neck here. But but you know, it's I really like it, and but you know, it's just the whole thing is you do a sculpture, then you cover it with hair, and it's just like a werewolf. You really don't have to do any really super detail, you know, on the back of the head and you know the back, you know, because a wolf, you know, like a werewolf, for instance, is going to have a lot of hair on it, and then you have other things like the electrostatic hair that you know where they generate like a fuzz that sticks by you know using electricity, and it looks really good. But you know, once again, you know they're painting like I guess it would be like a psycho paint, and the electricity's running through it, and it's attracting that hair fiber. But it has to be a certain type of fiber. But it looks really cool though. I've seen it done really well. But you can only get so long of a fiber. But and here what I'm doing is I'm using aluminum foil, and it kind of presses down the hairs that I have there because they get in the way, and I don't want to push a piece of that hair, you know, you know, through a new hole. But but you know, it's tedious work. It's long process. It's just once again, I'm using a bare needle. Uh, you'll see me use a bare needle with no I guess handle, and but I just sit here and dip it in that silicone and push it through. And here I think I'm getting close to that seam area of the silicone mask itself. But uh, I really enjoy it. It's fun, but it is time consuming. But like once again, I don't want to cover up a lot of that sculpture. But I still want you to be able to see the detail of the back. And it, being on video, you really don't see it, you know. But I see the detail in it, and I'm really happy with it. Even though that this is a FDM printer, it's a bamboo, you know, P1S, and you know, once again, the size of the printer is the size of an animatronic, and this animatronic was designed primarily because of the build platform of bamboo. Now they have a new one. That means I can make a bigger animatronic. But once again, as far as this process that I've done this way of designing an animatronic, which creates a core, then the core becomes the sculpture, and then the sculpture can be modeled, you know, as far as to do the mold parts and have it all done on a build platform of the 256 height and or 256 all the way around. And they have a new printer out, and that would be a bigger animatronic. But you know, I could care less about multicolor or laser or dual heads because that's primarily for multicolor. I just like to have a bigger platform to make bigger animatronics. But once again, that's the new thing. But uh, I probably won't get one until maybe later. But but here it is. Oh, and another thing about this silicone, the skin of it, it it's not tacky. It's not sticky or nothing like that. It's just the way silicone is. It kind of like it's kind of like a magnet. You know, if there's a piece of fuzz, it's going to stick to it. But but you know, once again, as you see here, the nape of the neck, and I'm just doing some filler. But it's going to pretty much be haired, maybe to the very top of the head, and then it's going to become lesser, more like a receding hairline. And then it's going to more likely have kind of a small goatee and, you know, hairs around the chin and then hair, some a little hair on the eyebrows and things like that. Around the, you know, I guess around the nasal fold area, and just some small little strands of hair here and there. But I'm happy with it. But once again, these hairs stick everywhere. And it's just, you know, I guess just electricity in the air. But, you know, you got to make sure you're careful. And then once again, you know, on the back of the neck, my controller's back there, and I don't want it to interfere with my controller also. But once again, I use this aluminum foil quite a bit just to make sure I can get the main bulk of the hair not in my way. And also, when you punch in hair, you know, you got to have enough, you got to put a little bit of extra hair to punch it through, because sometimes that hair will just slip through that eyelet of that needle, and you'll just punch a hole in the silicone. You know, it happened a few times to me where I actually didn't place a hair at all. But it's coming along, and this, see, when I do the silicone, I'm timed, and that's the silicone adhesive from Smooth On. And what it does is there's probably a 15-minute working time for the little dab that I'm using, and then all I'm doing is I'm once again I just dip the needle eyelet in there, and I clean it off to where the silicone is just in that U fork of the eyelet, and I press it, and I keep doing that. It's about 15 minutes. That silicone gets kind of thick. I don't want to use it anymore. So, and then I'll start on the next section. But then after about 4 times of doing it, maybe an hour, I stop, and then I'll let it cure for an hour or two, and then I'll go on to a next row. But I just keep doing this until I build up, and even though it's sporadic, I just gotta just keep moving up, and then like right now, it's getting close to the area where I'm getting close where I'm going to stop, and then like once again I'm going to pull it off the core, and I'm going to use some plastic bags or something like that and stuff it and make kind of a mannequin that way, so I can just hold it and just punch it through like so. But and plus all of this is just getting ready to prep it and get it looking nice so I can put it onto the animatronic. But the aluminum foil works really well. You know, it just keeps the hairs out of my way. And I just kind of press it down on the neck, kind of conforms to the mask itself. But you know, you can see where, as far as this being no 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 time lapse, you know, view of this. But just to show you how much, you know, I'll just punch it through and just take it out. But that's with each group. So you can imagine that I'm putting some time into it, and you know, probably about, there might be, from where I'm at now, I probably put in about 10 hours, and that's counting curing too. You know, a cure, and then the next day I'll go in there and I'll, you know, punch, you know, 3 or 4 rows, and then
I'll let that cure. But it's coming along. Once again, it's just a long process. It is kind of difficult, you know, doing the hair on the core because of the large base plate. But I'll show you more hair later because I'm probably going to go with the further or the higher I get up to the top of the head and probably some around the ear area, I'll switch to some goat hair. And you can get a sample pack, or when you call, the National Fiber Institute. That's it. And like on my box that I have right here, I received this on the March 16th, 2007. But it's the National Fiber Technology, and I might have said it wrong earlier, but and usually that's what but it's been a while since I've ordered any hair. But they have, I'll probably be ordering some for the werewolf project that I plan on doing next animatronic. But here, as you see, I'm just getting ready to remove this. I'll just peel it right off. And when I'm placing this, the hair, the new skin on, and when I get ready to mount it, I'm trying to figure out in the beginning, there's a permanent way and there's a non-permanent way. And there's kind of you know, I'd rather just do a test first, put it on there. And now if I use the adhesive from Smooth On, it can eventually, lift up and peel off. But to secure it in place, I would, like on the picture, the chest plate there, I would put some material there and I would glue it in place so it would have a mechanical bond, a physical bond to the so-called fabric and then the silicone. And that way it would give more of a permanent bond. But right here is when I was fooling around with the animatronic, I snapped one of these servo sockets off, and I got to looking at it, and I said, well, I just need to redesign that because that, looks kind of weak. So I did some some drawing here and some CAD work and kind of made it a little bit more, uh, you know, stronger than what it was. And but it was a quick thing, something that took maybe 30 minutes to do, and pretty much and print it also. But I got it fixed up, and then I was working on the and there's some those servos there are the D 89 MW servos from High Tech, and as you see here, uh, this is the new one that I had made, and then I just modeled off the one I have there and just added some kind of bulky around the servo sockets, and plus I made the infill like close to 75, that way it'd give it some more strength. But as you see here where it broke off, but it was just one of those things. What I was having, that middle shaft beam going to the neck movement area, like the U joint, what I did was that that U bracket was rotating, and I even put a while back I had put some Loctite on there, and that screw still backed out. So I took that screw out, and what I did was is I epoxied it, and then that way that shaft wouldn't move. But here I'm just testing what I was doing. I'm just testing the so-called the linkages and what I have designed here. And that's just bending wire in the area I want it. And plus it's inside, and I wasn't happy with it. Now you see the tilt,
it's rotating from that shaft, and that's when I stopped, and I changed that out to where I put some epoxy in that area to stop that from doing that, because I surely don't want it to do it when it's covered with the animatronic or with the skin, and then it do that. And how am I going to fix it? I'd have to remove the skin if it was already stuck on the animatronic. So I have to just pretty much prep all this, and here's me putting it back on right now, or either taking it off. But I epoxied it and got it all, you know, fitted correctly, and it's holding a lot better. And I was kind of disappointed in that Loctite, and but it's coming along. I'm happy with it, and everything's getting set up. But now I got to go to as far as me redesigning the linkages, because I'm just not happy with these, these ball joints here with that wire that's bent. Here I'm just putting on the linkages. Now I designed it and I printed them, and I printed them with an infill of like 90, and it's just like a S shape, because really I wanted my linkage to be on the outside on here on the skull instead of the inside, because I didn't want it to interfere with anything as far as my linkages or my movements or anything like that, or when or when it tilts. But as you see here, it's just a test. But but everything is getting there. But as you see here, I got the bottoms connected. Now, that's just a test. I don't have any lock nuts on those, but I will put lock nuts on those. And but as far as just the testing, I just test to see what kind of movements are. And one thing about these servos, these are like, I don't know, $79 maybe. But when they start up, if they're out of their placement, they do this so-called I guess a slow movement in the start, and I like that. That's pretty tight. But overall, it's coming along. Now for the other thing that I did for the animatronic was it was time to kind of like redesign this chest piece. It's nothing. What I'm doing is going to be, a lot. I'm just giving me a little bit more clearance since I made adjustments to the linkage. And what I did was here is I just, and I'm in SketchUp, and I just kind of designed kind of a shape where I could just take, a couple of millimeters pretty much all the way around except the front, and but it won't affect the animatronic piece at all, because it's just pretty much laying down on this chest, the chest piece here. But I just removed just a little bit so I can get a little bit more room. But it's overall it shouldn't even really come close to it, but I just want to be safe. But and I made this and I tested it, and it did really well. I'm happy with it. It's just something, once again, I think this print and another print I did, you'll see later on the control board, but this right here, what I did was here is I added a hole here, and this is where all the wires are going to go into. And I got some servo wire extensions coming. And I have some here, but I think it was time to go ahead and get some newer ones. But I was going to put uh, two holes, but I decided to just open it up and just put one, because on the controller, all of the servo points are on the left side. So that way I'll just put this hole on the left side, so it'll be an easy connection point. But I have to pretty much have all when I have the extensions placed, just kind of, thread everything into the hole, and then that way everything will be just, pushed in its right location. Like for instance, the two servos that do the tilt and the look left and right, I guess, turn mechanism. That's three servos. There will be three separate channels, but they'll be a separate thing. As far as on the controller, I'll have them like the the 8 in the head would be on the top, and the 3 controller of the movements of the head will be on the bottom. But and once again, this is that servo controller area, and I printed the whole today, and all I do is just transfer this controller onto the new print. But and I'm happy with it. It's just a simple process, just change out really quick. And these screws on the controller board are 2mm screws, and those lock nuts or nylon lock nuts are really small. But I'm using these 4mm screws to mount it on these Servo City beams, and just holding it in place. And when you would build this, you would put this on first, and then you would put on the chest piece. But it's coming along, but I really hope y'all enjoyed this video, and it's a little bit longer than I usually do, but I've been doing other things too. I'm working on a big set of creature teeth, and y'all should probably see that, and I'll show you more videos on herring. And but I'm excited with the results of the skin, and I can't wait to get this thing moving. I'm going to get the animatronic all set up and get it moving, and then that way I can just put on the skin and figure out the adhesive. I mean, I did the animatronic in 2007 and did the adhesive, and it's something that you just don't paint on all over. You got certain spots you got to do it. But look, I hope y'all enjoyed this. Thanks. Later.